Hi friends, good morning. Good morning guys. Anyone there? Hi Kumar, good morning. Good morning, good morning. What about the other guys? Good morning Vipul. Good morning Vipul. Good morning Diggy. Duggi, sorry. Good morning Duggi. So we have completed what is that? We have completed, right? So we have completed transportation till yesterday, and today we will be starting hydrology as promised. I think there were other persons that are asking. That girl Prachi was asking, isn't she here? Fine, 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 fine. Ready for hydrology? I hope it would be useful for you. Hydrology, and hydrology is generally for 2 to 3 marks. Hi Soumya, good morning. I hope this will be useful for you. We will try to complete hydrology today, and other subjects at the end of the day. Let me know which subject you want me to take. I'll take that subject. Okay. So what have you done yesterday night? Soumya, what have you done yesterday night after the class? The class was end around 6:37. After that you might have read other subject. So, you can read another subject. Good morning. Good morning. 7 people are watching and there are only 4 likes. Why? Good morning. So good morning Patnaik. Mm, Good morning Amit. Good morning Amit. Amit. After Arjun Reddy, Amit dialogue was very much famous. Arjun Reddy in Telugu version. I'm not talking in Hindi version. Geotechnical engineering and transport. Once again, why you read transportation here? Transportation is already finished. Huh? Fine. Anyway, it's up to you. So, guys, we'll be doing hydrology today. We'll be dealing with the hydrology today, contents of hydrology and all those things. Fine. So, the very first thing, if we get into the introduction part, general aspects of hydrology, that would be your first chapter. So the first question in that, hydrological cycle. Always the first question goes with the hydrological cycle. So hydrological cycle, hydrological cycle will be like, what is hydrological cycle? What is hydrological cycle? A very basic concept of the hydrological cycle would be, if I take this as the land, there will be ocean also. Fine. Land will be undulated. Fine. Let us say there is ocean here, ocean, rain, ocean, lake, anything, river, there can be lake here, there will be some trees, there will be groundwater table, there will be groundwater table that can be present over here. So what happens from the lake? Evaporation takes place, evaporation, condensation, that means formation of clouds, precipitation takes place, precipitation, and this would be infiltration, right? Infiltration, precipitation, evaporation, fine, and some water can be going like this, that is runoff, and from trees there can be some that is called as evapotranspiration, 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 fine. So this is the hydrological cycle, whatever that is, water that comes back to the original position once again. Once it reaches to the groundwater table, obviously it has to go to the ocean. Runoff also, finally it has to go to the ocean. Whatever the drainages, everything, finally it reaches to the ocean. And once again there will be evaporation. Evaporation can be from oceans, evaporation can be from the lakes, fine. From this we have to generate an equation that is called as water budget equation, right? Water budget equation. Water budget equation, like financial budget, same water budget. Inflow minus outflow. Inflow, that means water that is coming and water that is going. Inflow minus outflow equals to storage. Change in storage, to be more precise, inflow minus outflow equals to change in storage. This is your water budget equation. Water budget equation. Inflow minus outflow equals to change in the storage. Inflows means precipitation is an inflow, infiltration is an inflow, runoff would be an outflow, evaporation is an outflow, evapotranspiration is an outflow, everything. Finally, based on that, you'll see what is the change in the storage. This is how you have to analyze the things. If you use this basic concept, all your problems will be solved without much of an issue. Okay, now let's solve the question. The first question that is given to you is, a regional hydrological cycle is shown in the figure. A hydrological cycle is shown in the figure. There is a precipitation like this, and this is R1 is inflow, R2 is outflow, this is groundwater inflow, this is groundwater outflow, Sg is the storage, change in the storage, you can say that, and there is this evaporation, evapotranspiration. T represents transpiration or evapotranspiration. Transpiration means water that is evaporated from the leaves of trees, that is transpiration. Evaporation means directly water that is evaporating from the ground or ocean, fine. So the correct hydrological budget equation, correct hydrological budget equation, he is asking. What would be your answer? Please give me your answer. What would be your answer? What would be your answer? Only 5 people are watching. Please do like, share, subscribe with as many people as possible. 4 people are watching, yeah. So the number of views are not increasing. This is GATE Academy Global, where people who are comfortable in English can attend. GATE Academy for CEME channel is there for mainly for the Hindi students. Here it is for global people throughout the India, mainly South Indian guys who are more comfortable in English. For North Indian guys also, whoever that is comfortable in English can go for it. Anyway, right now if you are having any doubts, you can ask me. This is just a revision class, right? What could be the answer? So here some things are not very clear, I know that, but anyway, it is P, precipitation is coming, inflow is precipitation, fine. P is an inflow, so you can write like P plus R1 plus G1 minus R2 minus G2 minus evaporation, right? Evaporation should be minus transpiration, that is equals to D means indirectly that is delta. Delta is change in the storage. Fine. Sg minus of minus Ss. Minus of minus Ss. So that's approximately you will get Sg plus Ss. Change in the storage. Fine. So this can be written as P minus of R2 minus R1 minus G2 minus G1, and Evaporation would be, you can write simply ES and EG. EG and ES both mean same, okay, don't worry about it. From the surface, from the ground, that is the meaning of it. S represents surface, G represents ground. So minus of ES plus EG and minus of TS plus TG. Fine. So this is how you'll try to write down the water budget equation. This is from the surface, from the ground, and from surface, from the ground. Robertino, you are from Meghalaya? Hey, hi. I heard Meghalaya is a nice place, but I was never been to Meghalaya. So these are the things that you have to generally. This is how you will be using water budget equation. Fine. When I was studying my masters, there was a person, professor from Meghalaya. I think he's from Meghalaya only. From I can say from that northeastern state. To be more frank, I don't know exactly, but from northeastern state. So there, he used to teach water resource engineering like anything. I am like geotechnical professional. My master's is in geotechnical only, but he was from water resource background, and I have attended his interview. I cleared it, but anyway, I attended his class, 1 or 2 classes. He was very interesting type of guy. Anyway, so this is how you'll try to solve this type of questions. TS means transpiration from surface, transpiration from ground, transpiration from below the ground, transpiration from the surface. R2 minus R1, G2 minus G1. That's it. Okay. So don't worry much. You can just by looking at the question, you can answer this. Next, try to solve this question. The average surface area of a reservoir in the month of June is 20 kilometers square. The average surface area of reservoir in the month of June is 20 kilometers square. In the same month, the average rate of inflow is 10 meter cube per second and outflow is 15 meter cube per second. And monthly rainfall is 10 centimeters. Monthly seepage loss is 18 centimeters. The storage changes 16 million cubic meter. The evaporation in that month is. What is the evaporation in that month? Please give me the answer. The average surface area of reservoir is 20 kilometers square. In the same month, average rate of inflow is 10 meter cube per second and average rate of outflow is 15 meter cube per second. Monthly rainfall is 10 centimeters. Monthly seepage loss is 1.8 centimeters and storage change is 16 million meter cube. The evaporation in that month is. Please give me the answer. What is the evaporation in that month? This is your gate question only. Use water budget equation and give me the answer. It's okay, Prachi, it happens, not a bigger issue. Anyway, you asked for it, so I hope you will be there for whole class. What is the answer, guys? Answer, please. Try to change everything into centimeters. Your answer will become simpler. Try to change everything into centimeters. Try to change everything to the centimeters. So area is 20 kilometers square, reservoir area is 20 kilometers square, inflow is 10 meter cube per second, outflow rate is 15 meter cube per second, monthly rainfall is 10 centimeters, seepage loss is 1.8 centimeters and change in the storage is 16 million meter cube. The evaporation in that month is, what is the evaporation in that month he is asking. Please give me the answer. 22.89. Option is not there. Soumya, option is not there. The nearest option is 23.4. Maybe your option might be D. So, how exactly you are going to solve this? Fine. Just use water budget equation. Water budget equation. Water budget equation. Fine. Inflow minus outflow. Inflow minus outflow equals to change in storage. Change in storage. Fine. Inflow minus outflow equals to change in storage. What is inflow here? 10 meter cube per second. Fine. And he said monthly rainfall this is. So that means in a month what would be the value? And if you want that in terms of centimeters, then try to convert 15 meter cube per second, right? So 15 in a month means in month how many seconds will be there? 30 multiplied with 24 multiplied with 60 multiplied with 60, whole thing upon area. Volume upon area, that is 20 kilometer square, 20 into 10 to the power of 6. This you will get this in meters, multiplied with 10 square will be centimeters. Similarly this one, inflow, if you want to convert this into in a month, what would be the inflow? So that is 10 multiplied with 30 multiplied with 24 multiplied with 60 multiplied with 60, whole thing upon 20 multiplied with 10 to the power of 6, and whole thing multiplied with 10 square centimeters. So idea is convert everything into centimeters. He said in a month. In a year if he says, then you have to multiply this within in a year. In that month, precipitation P equals to 10 centimeters, and evaporation you have to calculate. Seepage loss is given to you, and change in the storage. Change in the storage is given as change in storage, and we don't know whether it decreases or increases. He just said change. We don't know whether it is positive or negative. Fine. So change in storage, he said 16 million meter cube, 16 into 10 to the power of 6 meter cube, upon area is 20 square, 20 into 10 to the power of 6 meter square. So this is 0.8 into 10 square centimeters, 80 centimeters. See, this is volume. He said volume. Volume upon area will give you in terms of depth. Million meter cube, that is volume. If they are saying 16 million meter cube, see the units. That means volume is given to you. You have to convert that into centimeters, depth. So this is 80 centimeters. Fine. So what is this value in terms of centimeters? What is this value? And what is this value in terms of centimeters? Please let me know. Ten to the power of 4, 10 square, what is the value in terms of centimeters, and what is this value in terms of centimeters? Please let me know. So now inflow, what you can write over here is inflow, whatever the value that is, plus 10, or I'll first write precipitation. Precipitation is 10 plus inflow minus whatever that outflow minus 1.8 centimeters minus E equals to change in storage. We don't know whether it is positive or negative. We'll just keep it some 80. I don't know positive or negative. Fine. So what is the value of inflow? What is the value of inflow? What is the value of inflow? How much is this value? 129.6 centimeters. This is 129.6. And what is this value, outflow? What is the outflow? 194.4 centimeters. 194.4. So this is 129.6 minus 194.4. And E value, remember, it will be always positive. It will be always positive. So this is 139.6 minus 196.2 minus E equals to Now, if you see, this is more. E will also be positive. So totally negative value will be more. So finally you will get here negative value. So this is minus 80. That means storage will be decreased. If not, storage will be increased. So please be clear with that. Whether it is positive or negative, it actually depends upon if if outflow is more compared to that of inflow, storage will be decreased. You will be taking it as negative. If inflow is more compared to that of outflow, storage will be increased. Okay, that is the idea. So finally, E value would be equals to 80 minus 196.2 plus 139.6. So this value would be approximately 23.4 centimeters, right? Yeah, 23.4 centimeters. Any doubts in this? Any doubts in this? Any doubts in this? Please do like, share, subscribe. Any doubts in this? And if possible, comment. Evaporation is 23.4 centimeters. Any doubts in this? So this is how, very simply, you just have to analyze the things. If inflow is more than outflow, storage will increase. If inflow is less than outflow, storage will decrease. That is the reason you will get 23.4 centimeters. Fine? No doubts? Okay. And you can solve these type of questions, many questions, but anyway, this is enough. Next point in the hydrology will be majorly dealing with precipitation. The next chapter would be, so here each and every point in hydrology means what we'll be discussing majorly is precipitation, evaporation, infiltration, runoff, evapotranspiration, and flood discharge. In the runoff itself you'll get the flood discharge, stream flow measurement, and all those things. Okay, that is the major hydrology that we generally see. Now in precipitation, what are different types of what is precipitation? If water reaches to the ground surface in various forms, whatever the form, if the water reaches to the ground surface, it can be of different forms, then it is called as precipitation. The water that is reaching to the ground surface in different forms, that is considered as precipitation. So the different types of precipitations would be rainfall. The major mode of precipitation is rainfall. So this is the major mode of precipitation where size of water droplet is in the range of 0.5 mm to 6 mm. 0.5 mm to 6 mm. If water droplet of size is in the range of 0.5 mm to 6 mm, then it is considered as rainfall. So this is rainfall, and the intensity of, based on intensity of the rainfall is classified as 3 types. That is, if it is from 0 to 2.5 mm per hour intensity of rainfall, based on intensity of rainfall, then it is called as light rainfall, and 2.5 mm per hour to 7.5 mm per hour, that is called as moderate rainfall, and if it is more than 7.5 mm per hour, then it is called as heavy rainfall. These are the major things. Generally in India, every day morning at 8:30 we are going to measure the rainfall. Every day at morning 8:30. You will go at the rain gauges, you will measure the rainfall, and then you will say this is the rainfall at this position. Fine. So this is the intensity of the rainfalls. Next, if this is the intensity of the rainfall, and based on intensity of the rainfall, if rainfall is more than or equal to 2.5 mm per day, then that day is called as rainy day. Then that day is called as rainy day. Fine. Then day is called as rainy day. And different types of rainfalls. How the rainfall will occur. Conventional rainfall. Different types of rainfalls. The first one is conventional rainfall. Conventional rainfall. So what is conventional rainfall? Conventional rainfall. So first, conventional rainfall means from any lakes or oceans, evaporation takes place. Evaporation. Condensation, that means that vapors is formed into the form of clouds, and then precipitation. Evaporation, condensation, and precipitation. This is conventional rainfall. Fine. Evaporation, because of the sun, water gets evaporated. Evaporation, condensation, and precipitation. Conventional rainfall. Next, orographic rainfall, or first I will say frontal rainfall. I will use frontal rainfall. Frontal rainfall. Fine. So in frontal rainfall, what happens is, if warm air comes in contact with cold air, if warm air comes in contact with cold air, let us say this is cold air and this is warm air. So warm air is lighter compared to that of cold air. So what happens is, it rises. That means cold air is coming like this, warm air goes and hits the cold air, and it goes like this. This region is called as front. Fine. So warm air hits the cold air and it reaches to the topmost, it rises. Once it rises, there will be formation of clouds. Condensation takes place, there will be formation of clouds, and from clouds there will be precipitation. Precipitation, condensation. This is frontal rainfall. Front means that is the region between warm air and cold air. This is frontal rainfall. Next one is cyclonic rainfall. Cyclonic rainfall. Cyclonic rainfall. So what happens in the cyclonic rainfall is, generally what happens, air moves from high pressure region to the low pressure region, right? Air moves from high pressure region to the low pressure region. Air moves from high pressure region to the low pressure region, and since, see, air is moving from, let us say this is the high pressure region and this is low pressure region. Okay. Air moves from high pressure region to low pressure region, and earth keeps on rotating, right? So since earth keeps on rotating, that air also will keep on rotating. Once it keeps on rotating, it reaches to the topmost surface. Once it reaches to the topmost surface, there will be condensation and there will be precipitation. Precipitation or rainfall. There will be rainfall. Fine. So the rainfall that is created in low pressure region, rainfall that is created in low pressure region is called as cyclones. Cyclones. And rainfall that is created in high pressure region, see here, this air is going off. This air is going off, right? So that means here, if it rotates like this, here the air keeps on rotating like anti-clockwise. That means, see how exactly this goes over here is, this is high pressure region. From high pressure region, let us say air goes like this, wind goes like this, and in the low pressure region it rotates like this. In high pressure region it rotates in clockwise direction, and it goes in the low pressure region, it rotates in the anti-clockwise direction, right? So here, since air is moving like this, it reaches to the top surface and condensation, precipitation will occur. Condensation, precipitation. Fine. So this is anticyclones. Anticyclones. I'm just giving a basic idea. Fine. This is anticyclones. So anticyclones are created at high pressure region, whereas cyclones are created at low pressure region. Okay. So generally northern hemisphere, wind for cyclones, wind will rotate in anti-clockwise direction. For anticyclones, wind will rotate in clockwise direction, and in southern hemisphere it will be different. In cyclones, wind will rotate in clockwise direction, and anticyclones, wind will rotate in anti-clockwise direction. Fine. So this is cyclonic rainfall. Cyclonic rainfall, generally hurricanes, cyclones, which occurs is because of this. It is a rare criteria, but it occurs when air moves from high pressure region to the low pressure region. You can see that butterfly effect and all those things here. Fine. So these are the points, cyclonic rainfall. And the major mode of rainfall in India is orographic rainfall. Orographic rainfall. So orographic rainfall means what exactly it is if let us say there are mountains and winds goes and hits the mountains. If it hits the mountains, it raises to the top surface and there will be formation of clouds. If there is formation of clouds, and there will be precipitation. This is wind. This goes and hits mountain and water raises to the top surface. Wind raises to the top surface, condensation, precipitation. This is called as windward side, and this is called as leeward side. So there will be precipitation, there will be rainfall on windward side, and there won't be any rainfall on leeward side. Okay, so this is how generally you see in the orographic rainfall. Orographic rainfall, it is a major mode of rainfall in India. Major mode of rainfall in India. Okay, in India the major mode of rainfall is orographic rainfall. Okay, so this is different types of rainfalls. We have seen different types of rainfalls, and always remember 96.5% or 97.5% of water is available in the fresh water or salt water. Only 2.5% of fresh water is available for us. Okay, only 2.5% of fresh water is available for us. I just wanted to say this. Why? Because the rainfall is the one which gives you the sweetest water. From oceans there will be salt water. So 2.5% of the water that you are getting is from this one only. For drinking purpose, for drinking and for usage purpose, only 2.5% of water is available, and earth is covered by 3/4 of earth is covered by water only. Fine. So anyway, this is the different types of rainfalls. Next, if you see different types of precipitation, the first one I said is rainfall. Next one, it can be drizzle. Drizzle, size of droplet is less than 0.5 mm. Size of droplet is less than 0.5 mm. Intensity of rainfall is less than 1 mm per hour. Drizzle is something like this. Next, snow. Snow is made up of ice crystals. Snow is made up of ice crystals with size, with density 0.1 gram per cc. 0.1 gram per cc means if snow can float on the water. What is the density of water? 1 gram per cc. Snow can float on the water. Fine. So this is drizzle, snow, and there are different things, glaze, sleet, hail, and all those things. Anyway, I am not discussing that. So these are the different types of precipitations that we generally see. Fine. Major modes of precipitation or different types of precipitation that we generally see. Okay. So next one would be, if a curve is drawn between anyway, measurement of rainfall. Next we will see measurement of rainfall. Fine. So rainfall is measured by an instrument called as rain gauges. Rainfall is measured by an instrument called as rain gauges, right? And how rainfall is measured? Rainfall is not measured in terms of volume, it is measured in terms of depth. It is measured in terms of depth. Fine. So rainfall is measured in terms of depth. Always remember, rainfall is measured in terms of depth. That means if this whole water, let us say if I said the rainfall for the given area is some 10 centimeters, that means if all the area is filled by the water, the depth would be 10 centimeters depth. There will be 10 centimeters depth. Fine. So that is the idea. So rainfall is generally measured in the 10 centimeters depth. For a given area, if I am saying rainfall is 10 centimeters, means if whole water is kept on that area, the rainfall, the depth would be 10 centimeters. If you want the volume, volume would be equals to area multiplied with that depth, will give you the volume. Fine. And rain gauges, there are two types of rain gauges: recording type, non-recording type. Non-recording type. Recording type and non-recording type. Non-recording means it doesn't mean it will not give you the value, it will not constantly develop the graph. So non-recording types of main rain gauges, the best rain gauge is Simon's rain gauge. Simon's rain gauge, Simpson's or Simon's, whatever that is, Simon's rain gauge. Fine. So Simon's rain gauge, which will be consisting of generally a cylindrical vessel. It will be having a cylindrical vessel with a funnel. Cylindrical vessel with a funnel. There will be gradations on it. So cylindrical vessel with the funnel, water comes, generally the diameter is 127 mm. Fine. So diameter is 127 mm. Water comes, flows through this funnel, and there will be uniform distribution of water, and from here you will measure the depth. Let us say if this is small d and the area of the cylinder is small a, and you know the area of the catchment. So if let us say area of catchment is a and this is d, d would be equals to a into d upon a. This is how you will get depth of the water in centimeters. Fine. So this is the area of the catchment, where A is the area of the catchment for a given area. For a given catchment area, A is the area of the catchment. Catchment means what happens is, let us say if these are two mountains and this is the ridge point, topmost point, whatever the rainfall that occurs, it will go and it will be collected in this area. Fine. This is called as catchment area. Catchment area. So that means whatever the rainfall that occurs over here will be collected in this whole area. So for this area, if they ask what is the rainfall, then this is the rainfall. This is non-recording type of rain gauges. It will just give you, like everyday morning you'll go, you'll measure this depth. Based on this depth, you'll calculate the actual depth of rainfall at that region. Fine. So this is how you can see catchment depth of rainfall. You'll get that from non-recording type of rain gauges. In recording type of rain gauges, there are different things. There is tipping bucket, weighing bucket, tipping bucket, weighing bucket, and float type of rain gauges. Fine. So recording means it will give you the constant variation of rainfall with respect to time. Constant variation of rainfall with respect to time. Variation of rainfall with respect to time it will give you. That is called as mass curve. Variation of rainfall with respect to time. Fine. So this is called as mass curve. This is called as mass curve. Fine. So rainfall with respect to time is called as mass curve. Okay. And then variation of rainfall intensity with respect to time. Variation of rainfall intensity with respect to time is called as hydrograph. This will be called as hydrograph. The names should be very much clear to you. What is hydrograph, what is mass curve, and all those things. Rainfall intensity with respect to time is called as hydrograph, and rainfall with respect to time is called as mass curve. Rainfall intensity, centimeters per hour or per hour, anything, per day, anything, okay, with respect to time. This is called as hydrograph. This is called as hydrograph. So directly this mass curve can be obtained from the recording type of rain gauges. Mass curve can be directly obtained from the recording type of rain gauges. You will directly get that curve. Fine. Different methods, weighing bucket. I am not discussing the methods over here. Anyway, so this is how you will try to get the intensities of the rainfall. This is rainfall intensity. That means the slope. This is centimeters. You can see the units over here, centimeter, anything. The slope of this one will give you the intensity. Fine. So this is rainfall intensity, and something called ISO heights. These are the line joining. These are the line joining points of equal rainfall depth. These are the lines joining points of equal rainfall depth. This is equal rainfall depth or equal rainfall intensity, both mean same, that is ISO heights. Fine. ISO heights. That means along that line rainfall would be uniform. Along that line, that means if let us say for a given area I am giving some ISO heights. If let us say these are ISO heights, I will say this is 100 centimeters, this is 90 centimeters, this is some 80 centimeters. Fine. Along this line rainfall is uniform. Along this line the rainfall would be 100 centimeters. These are ISO heights. So line joining points of equal rainfall depth. Fine. So measurement of rainfall would be something like that. Okay, by using recording type of rain gauges and non-recording type of rain gauges. Now, number of rain gauges that will be kept. It depends on what? Number of rain gauges generally depends on what? It depends upon magnitude of rainfall, right? Number of rain gauges for a given location. It depends upon magnitude of rainfall. It depends upon magnitude of rainfall. Fine. So and what else? It depends upon topography of the area. That means topography of area. In hilly terrains, you will provide more number of rain gauges compared to that of plain terrains, because plain terrains you can easily, if one rain gauge will be enough, it will give you the area. In hilly terrains, it keeps on changing, so you have to keep one here, you have to keep another one here, you have to keep another one here. So the density is more in hilly terrains compared to that of plain terrains, and then it depends upon magnitude of accuracy or desired level of accuracy. If higher accuracy is required, you will keep more rain gauges. If lesser accuracy is required, you will keep less rain gauges. Fine. This is rain gauge density or something like this. Generally one station per 520 kilometer square is what we prefer. For every 520 kilometer square area, you will just keep one station, which will give you the better results as per ISA standard. This is for plain regions. For mountainous regions, it would be one station for 130 kilometer square, and up to some elevations it is one station per 200 kilometer square. Up to elevation above 1000 meters, it would be something like this. Anyway, if remembrance is not asked in gate, that's the reason I am not discussing those things here. Fine. So this is the idea. Okay. Now optimum number of rain gauges. In the question, if they ask how you are going to find out optimum number of rain gauges, optimum number of rain gauges, optimum number of rain gauges, n, optimum number of rain gauges is generally given as CV upon E whole square, where E equals to allowed error, allowed error allowed, E equals to error allowed, E equals to error allowed, and CV equals to is generally given as sigma upon x, sigma upon x, which is also given as coefficient of variation. It is also called as coefficient of variation. CV is also called as coefficient of variation, and this is, let us say, x bar. Sigma is standard deviation. Standard deviation is generally obtained from under root of sigma x bar minus xi whole square upon n minus 1, upon n minus 1, where x bar equals to mean precipitation, x1 plus x2 plus x3 plus so on up to xn whole thing upon n, right? This is the mean of precipitation, and this is standard deviation. Mean of precipitation, mean of precipitation, and this is standard deviation, standard deviation, standard deviation. Fine. This is standard deviation. Number of optimum number of rain gauges is obtained something like this. Fine. Optimum number of rain gauges is obtained something like this. Good morning, Chaitanya. Fine. So how you are going to solve these questions? Any questions based on it? Yeah. So a question that is given to you is the coefficient of variation, the coefficient of variation, the coefficient of variation of a rainfall for 6 rain gauge stations in the catchment was found to be 29.54 percentage. Coefficient of variation for 6 rain gauge stations is found to be 29.54 percentage. The optimum number of stations in the catchment for an admissible 10% error in the estimation of mean rainfall will be. Robertino, at what time I'll end this session? Once hydrology is completed, your sessions will be ended. I think till evening it will go. Hopefully it goes till evening. I don't know the rest. Anyway, what is the answer for this? He is asking what is the optimum number of stations. What is the optimum number of stations? Please give me the answer. Make it fast. 3. Great. So read the question, see the question properly. What is CV that is given to you? 29.54 percentage. Allowable error is 10%. So this is 29.54 upon 10 whole square. So that is approximately 3 square. That is 9 stations you will provide. Simple. So I don't know what is your problem. You will be providing 9 stations. You will be providing 9 stations. Direct application of formula. And why Chaitanya also has given A? Why you are saying 3? Why you are saying A? CV upon E whole square, right? 9 stations. A basic application of formula R. Simple. 9 stations. So if a question is asked based on optimum number of rain gauge stations, sir, if 6 rain gauge stations are used, the variation is this much, and if 10% allow, if 10% is admissible error, then what you are going, how you are going to find out? 29.54 upon 10 square, 3 square, that is 9. Simple. It's not extra required. He is asking optimum number that is required. Optimum number that is required is 9. Fine. Okay. Next, try to solve this question. The intensity of rainfall and time interval of a typical storm, are given to you. Time interval of a typical storm are given to you. This is time interval and intensity of rainfall. The maximum intensity of rainfall for 20 minutes duration. He is asking what is the maximum intensity of rainfall for 20 minutes duration. He has given for 10 minutes duration. He is asking what is the maximum intensity of rainfall for 20 minutes duration. Please give me the answer. S. Chaitanya, I will complete whole hydrology by today. Kumar has given the answer 1.85 mm per minute. Huh? Oh, Chaitanya is saying 3.7. 3.7. Read the question properly. He is asking mm per minute. Maximum intensity of rainfall for 20 minutes duration. Prachi has given 1.85. Fine. So how exactly you will solve this question? Generally, I am explaining you by drawing the figure, but in the examination, it's up to you how you are going to solve. Okay. So if I have to draw this figure, rainfall intensity with respect to time. Rainfall intensity with respect to time. Fine. So rainfall intensity with respect to time, 0 to 10 to 70, right? So this would be 10, 20, 30, 40, 50, 60, 70, 80. For 0 to 10 it is 0.7. For 10 to 20 it is 0.1. And for 20 to 30 it is 2.2. And from 30 to 40 it is 1.5. From 40 to 50, 1.2. And this is 1.3. 1.3, 0.9, 0.4. This is 0.7, 1.1, 2.2, 1.7, 1.5, 1.5, 1.2, 1.2, 1.3, 0.9, 0.4, 0.9, 0.4. So 0, 10, 20, 30, 40, 50, 60, 70, 80. Right? So if this is the thing that we generally see, this is the hydrograph that is being drawn. He is asking maximum 20 minutes. Here it is given 10 minutes. 20 minutes means you have to add any two that is maximum. So these two things looks like maximum, right? So if I add these two things, that is equals to 2.2 plus 1.5. So actually you can't directly add the slopes, you should add the rainfall value. So for maximum 20 minutes rainfall is equals to, you should not add slopes, you should add the quantity. This is 2.2 mm per hour or centimeter mm per minute, right? So this is mm per minute, 2.2 mm per minute. 2.2 multiplied with 10 minutes plus 1.5 multiplied with 10 minutes. Fine. So this would be equals to 37 mm is your rainfall for maximum 20 minutes rainfall, and he is asking intensity. If intensity is asked, then it is rainfall upon duration. So that is equals to 1.85 mm per minute. Fine. You don't have to draw this. You don't have to draw this, but just for your idea I am saying. So you just have to see what is the maximum, and he has asked you the intensity. So you have to divide that by the duration. So answer is 1.85. Okay. Any doubts? सर वॉइस थोड़ी सी इंक्रीज कर लीजिए. Fine. 1.85 mm per minute. This is how you'll try to. Now I hope the voice is clear, and happy Basant Paurnami, Basant Panchami, sorry. So this is how you'll try to find out these type of questions. Okay. Next, a tropical cyclone in in a northern hemisphere is a wind stream with. A tropical cyclone in a northern hemisphere is a wind stream with. What is the tropical cyclone in a northern hemisphere with? Sir, please don't make the session private. I am not making it Shivam. Okay, a tropical cyclone in northern hemisphere is a wind stream with. He is asking. See, for that, just like it now. I think you can see the session later, right? So, what is the answer? A tropical cyclone in northern hemisphere is a wind stream with. उल्टा और लो हो गया. Hello, am I not audible? Other guys, please respond. Am I not audible? Is audibility is less? Please let me know. Is the audibility less? Other guys, please let me know whether you are getting voice or not. Everything is okay? Fine, thank you. Soumya is saying D. See, just now I have explained to you. Audible but comparatively less. Comparatively less. Why, Ray? Mic is with me only. I am not even using button mic. I am using this type of mic. You can see that. Anyway, so a tropical cyclone in northern hemisphere is a wind stream with tropical cyclone. He is saying cyclone. Cyclone in northern hemisphere is a wind stream. The wind stream for that would be what? Wind stream for that would be anti-clockwise. For a cyclone, wind stream is anti-clockwise. For anticyclone, wind stream would be clockwise. And cyclones occur at low pressure region. Anticyclones will occur at high pressure region. So it will be a low pressure region with anti-clockwise rotation. Low pressure region with anti-clockwise rotation. Your option would be C. Low pressure region with anti-clockwise rotation. Fine. Any doubts in this? Any doubts in this? Any doubts in this? Please do like, share, subscribe. Any doubts in this? You can ask me. Any doubts? No doubts? Fine? Yeah. Next one. Next type of questions would be, anyway, we have seen this concept, right? we have seen this concept of how to find out optimum number of rain gauges, and the density it depends on what type of density on all those things. Next, how to find out the missing values. How to find out the missing values. That means, let us say at a in a given month at a given station, let us say that is station X, you don't know the rainfall. You don't know the rainfall. Now you have to find out what is the rainfall at that location. Finding out missing data. Okay. Finding out missing data. Finding out missing data. So at a given location for a given time period, let us say month or year or day, today at this location you don't know the rainfall. How you are going to find out at this location? The rain gauge at this location. You have n number of rain gauges in an area. Fine. So then what you will be doing is, you will just select some stations nearby. P1, P2, P3, P4, so on up to Pn. Let us say you'll select n stations nearby. Okay. And rainfall at these n stations today is P1, P2, P3, so on up to Pn. Fine. And there is something called as normal rainfall. Normal rainfall. Normal rainfall is the average rainfall. Average rainfall. Rainfall at that location. Average rainfall at that location at that point of year. At that point. At that time. At that time. At that time of month or year. At that time of month or year. So average rainfall for 30 years. For 30 years. Average rainfall for 30 years at that location. Average rainfall for 30 years at that location, at that month or year. So that means normal rainfall at this location would be for today 30 years data. That means it is 2022 February 5th, 2021 February 5th. What is the rainfall here? Like that 30 years data you will take, and you will find out the average rainfall. That is called as normal rainfall. Normal rainfall N2, N1, Nn, Nx, N5, N4, N3. N3. Fine. Okay, this is normal rainfall. P1, P2, P3 are the precipitations today in the nearby stations. You have to find out at station X what is the rainfall. What is the rainfall at station X? You have to find out. There are two methods here. If variation between nx and n1 comma n2 comma n3 so on up to nn is less than 10%. If variation between all the values and nx is less than 10%, then px would be equals to p1 plus p2 plus p3 plus so on up to pn upon n. Pn upon n. This is how you'll try to find out if variation with each and every value you have to check. Variation should be less than 10%. Next, if at least one value, if for at least one value variation is more than 10%. That means out of these n values, if at least one value with respect to nx variation is more than 10%, then we will use normal ratio method. Normal ratio method to find out the unknown value. Normal ratio method to find out the unknowns. So how exactly you are going to find out? Px would be equals to nx upon n multiplied with p1 upon n1, p2 upon n2 plus so on up to p3 pn upon nn. This is normal ratio method. This is how you'll try to find out the unknown rainfall. Fine. Any doubts in this? This is how you will try to find out the unknown rainfall. Okay. Now I'll explain the other method also. Other method would be weightages. Weightages. Let us say this is station X and another station P1, P2, P3, P4, and you know the distances D1, D2, D3, D4. Okay. So if distance is far away from here, the effect of this station will be less. Weightage would be inversely proportional to distance square. So weightage would be equals to K upon distance square. Distance, how will you calculate if this is x1 comma y1 and this is origin? So the distance would be under root of x1 square plus y1 square. Fine. So weightages for different things we will know. So P at x would be equals to P1 W1 plus P2 W2 plus so on up to Pn Wn upon W1 plus W2 plus so on up to Wn. This is a rainfall at station X. Rainfall at station X. If you want to find out if weightages are given to you, weightage is inversely proportional to d square, you will get your answers. Px. Fine. Anyway, this is one of the method and this is the method that you have to see. Okay. Normal ratio method. Based on this, we will solve the problems here. In a watershed, four rain gauges, 1, 2, 3 and 4 are installed. The depths of normal annual rainfall or normal annual rainfall both are same at these stations are 60, 75, 80 and 100 respectively. The rain gauge at station 3 went out of order during a particular year. The annual rainfall for that year recorded at the remaining stations are 90, 60 and 70 centimeters. The rainfall at station 3 can be considered as. What is the rainfall at station 3? He is asking the normal rainfalls at station 1, 2, 3, 4 is given to you. And at station 3 you don't know what is the rainfall for a year. And at the station 1 the rainfall during that year is 90, 60, 70. The rainfall at the station 3 can be considered as. So just find out rainfall at station 3. Just find out what is the rainfall at station 3. Prachi has given 80. What about the other guys? What about the other guys? Soumya Kumar has given 80. So how you are going to find this out? Station 1, 2, 3, 4. Okay. So precipitation, normal rainfall. Normal rainfalls is given as 60, 75, 80, 100. 60, 75, 80, 100. Precipitations 90, 60 and 70. 90, 60, 70. Fine. This is the case. Then P at 3, Px, that would be equals to Nx upon N. Sir, you want me to check. The difference should not be more than 10%. Here itself you can see the difference is more than 10%. 100 minus 80 is 20 upon 80 multiplied with 100. That difference is 25%. It is more than 10%. Fine. So Nx and difference between Nx and N1, N2, so on up to Nn is more than 10%. So you are going to use normal ratio method only. So Nx upon N, P1 upon N1, P2 upon N2 plus P4 upon N4. P4 upon N4. So Nx would be equals to 80 upon 3. P1 is 90 upon 60. P2 is 60 upon 75 and P3 is 70 upon 100. Right? So this is 80 upon 3, 1.5 plus 0.8 plus 0.7. So this is equals to 80 centimeters. 80 centimeters. Px equals to 80 centimeters. So simple answer. Px equals to 80 centimeters. Px equals to 80 centimeters. Fine. Any doubts in this? Any doubts in this? Any doubts in this? No doubts? If you are not having any doubts, then we will go for the next question. In a catchment, there are four rain gauge stations. In a catchment, there are four rain gauge. Sir, station check करने वाला point repeat. क्या? Variation check करना वाला point repeat. I don't understand. What is the variation? In a catchment, you're talking about weightage, the third method. You're talking, okay, you want me to check the variation. Fine. Okay. If you see the variation between these two things, what is the percentage variation? 100 minus 80 upon 80 multiplied with 100. That would be equals to 20 upon 80 multiplied with 100. That equals to 25%. Percentage variation. Percentage variation. Any one of the thing, if it is more than 10%. So you can go for normal ratio method. Okay, that is the thing. Percentage variation, just check it. Any one is enough. Even though if at least one is more than 10%, you have to use normal ratio method. You can't use that method. And this method, as I said, weightages. If distance is more, the effect of this one on this will be less. So weightage would be less. So weightage is calculated like this, and the rainfall value is calculated like this. Sir, N means in that formula? N means in that formula number of stations. Don't take it as 4 stations. Here it is 3. You are adding 3, so it would be 3, not 4. It would be this 3. That is the reason I have given separately. X and N I have given separately. See here. This is station X. And if you are adding N things, you have to divide by N. You have to divide by N. Okay. N means here it is how many that you are adding, the same thing. N means 3 here. Okay. I mean in this problem it is 3. Not 4. It is 3. Fine. Next problem, try to solve this. In a catchment there are 4 rain gauge stations P, Q, R and S. In a catchment there are 4 rain gauge stations P, Q, R and S. Normal annual precipitation values at these stations are 780. Normal annual precipitation values at these stations are 780, 850, 920, 980. 780, 850, 920, 980 mm respectively. In the year 2013, stations Q, R and S were operative, but P was not operative. Using normal ratio method, the precipitation at station P for the year 2013, the precipitation for station P for the year 2013 is 860 mm. If the observed precipitation at stations Q and R is 930 and 10 mm respectively, what is the observed precipitation at station S for that year? What is the observed precipitation for station S for that year? Okay. In a catchment, there are 4 stations. Normal values are given to you. In the year 2013, station QRS were operative, but P was not operative. So by using normal ratio method, they found out the value of P as 860 mm. And in that year, rainfall at Q and R is 930, 1010. What was the observed precipitation at station S? Please try to find out what is the observed rainfall at station S. Yeah, this is the question. Observed rainfall at station S. Please try to find out. Please do like, share, subscribe. Prachi has given the answer as 1093.4. What about the other people? What about the other guys? Make it fast. What is given to you? PQRS. QRS. PN. Normal rainfalls are 780, 850, 920, 980. 780, 850, 920, 980. 920, 980. And P values at Q and R it is 930. At Q and R it is 930 and 1010. At Q it is 930, at R it is 1010. At S we don't know. We don't know. But at P the value is given to you. That means after using normal ratio method, Px equals to Nx upon 3 PQ upon NQ plus PP PR upon NR plus PS upon NS. The value we know. That value, that is PP, right? PP is what? That is unknown. PP. That PP value is given to you as something called 860 mm. This is given as 860. So 860 equals to 780 upon 3 plus 930 upon 850 plus 1010 upon 920 plus PS is what you have to calculate upon NS is 980. Fine. From this, what is the value of PS? This is how you will calculate. You will not use PS here. He has given in the question PS is the unknown. Sorry, PP is the unknown. Okay. And it is calculated by normal ratio method. So you will be solving like this. Your option is 1093.45. 1093.45. 1093.45. So I don't know why other people are not giving the answers. Please give me the answer. Okay, 1093.45. Any doubts in this? Any doubts in this? Any doubts in this? Can I go to the next concept? Fine. Okay. Next, average rainfall. Average rainfall. Next concept is average rainfall. Okay. And anyway, if they are saying annual average rainfall at a station, annual average rainfall, that would be equals to in an year. That means you will be adding from 1 to 365 days and you will be taking the average. Annual average rainfall at a station would be generally given as some P. That what exactly it means is annual average rainfall means from first day to 365 days. Whatever that is rainfall, 10, 12, so on up to 20, let us say. You will add everything and you will divide by 365. That would be the annual average rainfall. Okay, or divide by 365 times, right? So that is the annual average rainfall. You will calculate at this one. Okay. Now, average rainfall data. How you are going to find out average rainfall data in a catchment? Let us say there is a catchment and there are n rain gauges. N rain gauges, P2, P3, P4, so on up to Pn. Fine. The average rainfall, if they ask, the simplest value to find out the average rainfall for this catchment area, for this whole catchment area, these are the rain gauge stations. Fine. These are rain gauge stations. Rain gauge stations. These are rain gauge stations. So if they ask average, how you are going to find out average is P1 plus P2 plus so on up to Pn upon n. This is one way. This is one way. This is done if generally if accuracy required is less, if accuracy required is less, if accuracy required is less, or stations are very close. If stations are very close, then you can use this. If not, generally you won't find the average like this. This is just a basic way of doing it. Just add everything and divide that by n. That is how you are going to find out average rainfall. Okay. Next method is what, which is an important method, that is called as thesis polygon method. Thesis polygon method. Thesis polygon method. Fine. So in Thiessen polygon method, so what exactly you'll be doing is, if a catchment is given to you, if a catchment is given to you, if a catchment is given to you, and there are stations P1, P2, P3 plus so on up to Pn. Fine. Now what you so on up to Pn, let us say. So for what you'll be doing is, you'll draw a Thiessen polygon so that you'll try to find out what is the effect of the areas. What is the effect of the areas for different rain gauge stations, right? That means the for this rain gauge station, the effective area would be A1. This would be A2. This is A3. That means what we assume is, throughout this area the uniform rainfall is P1. In actual it won't be like that, but just an assumption. Throughout this area the rainfall is P1. Throughout this area AN, the rainfall is Pn. There is a uniform rainfall of Pn, and throughout this area we assume there is a uniform rainfall of P2. Throughout this area we assume there is a uniform rainfall of P3. So P average, if you want to find out P average, then it would be P1 A1 plus P2 A2 plus so on up to Pn An, whole thing upon A1 plus A2 plus A3 plus so on up to An, plus so on up to An. So if areas are directly given to you, you can calculate average something like this. So this will be this is like indirectly P1 multiplied with A1 upon A, P2 multiplied with A2 upon A, where A is the total area, plus Pn multiplied with An upon A. This is also called as weightage factor. Weightage factor. Fine. So this is how you'll try to find out P average. But the important thing over here is how you are going to draw that Thiessen polygon. How you are going to draw that Thiessen polygon. Suppose if I take any circle, this is just an example, P1, P2, P3, P4, P5. Fine. So if this is the 5 stations, let us say, the first step in drawing Thiessen polygon method is, you have to join everything. You have to join all the stations by straight lines so that it forms non-intersecting triangles. Non-intersecting means it should not cut with each other. Fine. It is touching but it is not cutting. Fine. Okay. Clear. So first step is you have to join all the rain gauge stations. First step is join all rain gauge stations. Join all rain gauge stations. Join all rain gauge stations so that it forms non-intersecting triangles. So that it forms non-intersecting triangles. Okay. So first you will join all the rain gauge stations. Then what you will be doing is, you have to draw the perpendicular bisectors for each line so that it forms non-intersecting triangles. Fine. So perpendicular bisector for this one would be something like this. Perpendicular bisector for this one would be something like this for this line. Perpendicular bisector for this one would be something like this, and perpendicular bisector for this one would be something like this. For these 4 lines I have drawn the perpendicular bisectors. Next, you have for this line perpendicular bisector will be like this. You should not extend it. If you extend it, it will cut it. It will cut this box. That means it will be intersecting. Okay, it should not cut it. It should what I am saying, draw the perpendicular bisectors. Draw the perpendicular bisectors for the lines, so that it forms non-intersecting triangle. It forms non-intersecting triangles. That means one should not cut other thing. One should not break the other thing. Okay, that is one thing. You will just extend the line like this. Next, for this one also, you will just extend the line like this. This is the perpendicular bisector for this. This is the perpendicular bisector for this line. You will not enter it into it. Fine. Now, so now if you see the areas for P5, this square area is A5. This is A5 for P5. Fine. And this is A1. This whole thing is A1. And this is A4. This is A3. And this one is A2. This one is A2. Fine. Suppose if the radius is A. If radius is A. If radius of this one is A, what would be this distance? This is A by 2. This will also be A by 2, right? Because this is perpendicular bisector. This is A by 2. This will be A by 2. A by 2, A by 2. And here also this is A by 2. This one will also be A upon 2. A upon 2, A upon 2. So what would be A5? Area 5 would be a square area. That is A multiplied with A square. A multiplied with, this is A square. And if you want other areas, if you see everything is symmetrical. So A1 equals to A2 equals to A3 equals to A4. Right? So A1 equals to A2 equals to A3, that equals to A4, that equals to total area pi A square minus area of square upon 4. Because these are 4 parts, so each part would be 4. This is A1, A2, A3, A4. So finally, if you want to find out P average, that would be equals to P1 A1 plus P2 A2 plus P3 A3 plus so on up to Pn An upon Pn An upon A1 plus A2 plus A3 plus so on up to An. This is P average. This is how you will calculate P average. Fine. So the first step is join every station. Second step is draw the perpendicular bisectors. That is an important thing. Always worry about the center one. Get the center one properly and then draw the perpendicular bisectors for other thing. Then whatever the areas, you can use your mathematical concepts to find out the areas. Just use your mathematical concepts to find out the areas. This is how you try to draw Thiessen polygon method. Thiessen polygon method, right? Fine. Any doubts in this? Any doubts in this? You can ask me. Any doubts? Any doubts in this? If you are not having any doubts, so just what is the answer for this question? A Thiessen polygon is polygon obtained by joining adjoining rain gauge stations. A representative area used for weighing the observed station precipitation. An area used in construction for the depth area curves. The descriptive term for the shape of hydrograph. Descriptive term for shape hydrograph. So what is the answer for this? A Thiessen polygon is so here a polygon obtained by joining adjoining rain gauge stations. You feel like this is correct. It is not by joining that only. You have to draw the bisectors also, all those things. See the option B also, a representative area used for weighing the observed station precipitation. So Thiessen polygon will give you the area. What we are finding here indirectly we are trying to find out what is the representative area. That means in this area A2 we assume an uniform precipitation of P2. So the better option, not by joining the adjoining stations you will get that, you have to draw bisectors and everything, but a Thiessen polygon is an representative area. In that area you assume that rainfall is uniform. Fine. So that is the meaning of it, a representative area used for weighing the observed station precipitation. So the better option is B. Better option is B, not A. That is how you solve this. Better option is B. Fine. Next question. A catchment is idealized as 25 by 25 kilometers square. It has 5 rain gauges. We'll solve this later. First solve this. Rainfall depth. Rainfall depth over a watershed is monitored through 6 number of well distributed rain gauges. This is rain gauge, rainfall depth and area of Thiessen polygon. The Thiessen mean value. See, rainfall depth, average rainfall depth can also be called as mean value. It can also be called as equivalent uniform depth. EUD, equivalent uniform depth. Equivalent uniform depth, that equals to P average. Everything means same. EUD, everything means same. Anyway, he is asking what is the Thiessen mean value. What is the Thiessen mean value? So please give me the answer. What is the Thiessen mean value? So rainfall depth, area of Thiessen polygon is given to you. What is the Thiessen mean value? Please give me the answer. Prachi has given the answer as 479.09. What about the other people? Four 479.09, 474.8. What is, why different values you are getting? So direct application of formula, P average equals to P1A1 plus P2A2, P1A1 plus P2A2 plus P3A3 plus so on up to Pn AN upon Pn An upon A1 plus A2 plus A3 plus so on up to An, right? So what is P1 is 470 95, 470 multiplied with 95 plus 465 multiplied with 100, 465 multiplied with 100 plus 435 multiplied with 98, 435 multiplied with 98 plus 525 multiplied with 80, 525 multiplied with 80 plus 480 multiplied with 85, 480 multiplied with 85 plus 510 multiplied with 92. Whole thing upon 95 plus 100 plus 98 plus 80 plus 85 plus 92. So what is the value of P average? What is the value of P average? Everyone is saying 479.09. So let's keep it that way, 479.09 centimeters. 479.09 centimeters. Okay, that is in mm, not centimeters. Everything is in mm, so this will also be mm. 479 mm. He said 1 decimal place, so you will be writing what? 479.1 mm. You will not write 09 in the examination. When he said 1 decimal place, you have to write answer in 1 decimal place only, 479.1. Fine. So your option is, answer is that. Okay. Next, a catchment is idealized as 25 kilometers by 25 kilometers square. It has 5 rain gauges, one at each corner, one and one at the center as shown in the figure. During a month, the precipitation at these gauges are measured as G1 is 300 mm, G1 is 300, precipitation at this one G1 is 300 and G2 is 285, G3 is 272, G4 is 290 and G5 is 288 mm. Fine. You just have to calculate what is the average value. What is the average precipitation over the catchment during this month by Thiessen polygon method? What is the average precipitation? Just find out what is the average precipitation value. During that month, what is the average precipitation value for that? Please do like, share, subscribe. Prachi has given some answer, 286.75. Kumar also given 287.375. So the first thing comes first. What you have to do, you have to join all the rain gauge stations. Anyway, G1, G2, G3, G4, everything is joined. You just have to join G1 with G5, G2 with G5, G4 with G5, and G3 with G5. Okay, so just join all these things. Once you join all these things, then what you have to do is, draw the perpendicular bisectors. So first concentrate for G5, draw the perpendicular bisectors. Okay, so that means you draw the perpendicular bisector for this line. For this line it would be like this, for this line it would be like this, for this line it would be like this. For this line this is the perpendicular bisector, for this line this is the perpendicular bisector, right? For this line this is the perpendicular bisector. Now for this line just extend outside. This is the perpendicular bisector, this will be the perpendicular bisector, this is the perpendicular bisector, this is the perpendicular bisector. Okay, always concentrate about the center one. Okay, so that is the reason I have drawn perpendicular bisector for this first. Okay, so this area is A5, this area is A5, this area is A5. So what would be that area? 25 kilometers by 25 kilometers, that means this is 25 by 2, this is also 25 upon 2, this is 25 by 2, this is also 25 upon 2. This area is A3, this area is A2, this area is A1, this area is A4. Fine. So if you have to calculate A5 would be equals to total area minus 4 times A1 or A2 or A3, A4, everything will be same. So this is 25 multiplied with 25 minus 4 times A1 equals to A2, that equals to A3, that equals to A4. That is a triangle area, right? This is a simple triangle area, half multiplied with base multiplied with height, right? So half multiplied with 25 by 2 multiplied with 25 upon 2, that is 625 upon 8. So this would be 625 upon 8, 625 upon 8. So that is equals to 625 upon 2. This is A5. So finally P average would be equals to P1A1 plus P2A2 plus P3A3 plus P4A4 plus P5A5. P5A5 whole thing upon A1 plus A2 plus A3 plus A4 plus A5. A1 plus A2 plus A3 plus A4 plus A5. Fine. So what is P1? Every value is given to you, that is 300, right? So 300, A1, A2, A3, A4 is same. So I'll directly add 300 plus 285, 272, 290. 285, 272, 290 whole multiplied with 625 upon 8 plus this is 288. 288 multiplied with 625 upon 2 upon whole area. Whole area is 625. So what is this value you are getting? Everyone got somewhere around 287, 286. Why Chaitanya is getting 281? I don't know. 287, whatever the value that is, I don't know, please check it. 287 or 286 that you are getting, I don't know, but this is how you will solve this. Any doubts? Any doubts in this? Any doubts in this? This is how you will solve that question. Any doubts? Any doubts? And please check it. Two people got 287.3 and one person got 286 and one other person got 281. Don't do calculation mistakes, okay? पॉलीगन बनाना एक बार फिर से बता दे. Fine. See how you are going to do the polygon. First thing comes first. G1, G2, G3, G4, and there is this G5. Okay. Fine. First you have to join all the things. All the rain gauge stations you have to join. Anyway, we have joined all these things. The next one is you have to join G1 with G5 and G3 with G5. And next one is G2 with G5 and G4 with G5. Okay. Let us say this is G5. So you have to join G1 G5, G3 G5, G2 G5, G4 G5. Okay. Now I am saying once again, always worry about if there is something at the center, worry about this one. Okay. So you can draw the perpendicular bisectors directly like this, or I'll draw the perpendicular bisector like this. One perpendicular bisector, another perpendicular bisector, another perpendicular bisector, another perpendicular bisector. I'll draw like it. Fine. And then I'll draw a perpendicular bisector like this. Fine. You can't do that. Why? Why sir? Why I can't do that? If you do it something like this, then what happens is, this, for this we know this is, let us say this is area G1. This is G1, and this triangle, what is the area? I mean, what is the rainfall in this triangle? We don't know, right? There is no rain gauge station here. We don't know exactly. So that is the reason it should form non-intersecting triangles. Means if here it should not cut this. It should not cut this. One bisector should not pass through another bisector. It can touch here, but it should not pass through this. Fine. So the best way to do is remove all those things. Don't worry about that. So first worry about G5. That is the one which is at the center. Draw perpendicular bisector for this. Perpendicular bisector for this line will be something like this. Perpendicular bisector for this line will be something like this. And perpendicular bisector for this line will be something like this. Perpendicular bisectors. It should be exactly at the center and perpendicular to it. So this will be the area for G5. Now draw for this line, the perpendicular bisector will be something like this. It should not go inside. If it goes, it will cut this. It will cut this, so we will not get the proper area for G5. Okay, it should not cut it. It can touch, but it should not cut. It goes like this. This one will go like this. This one will go like this. The bisectors also should be non-intersecting. It can touch, but it should not pass through this. It should not cut. Okay, now is it clear? 287.375. Okay, fine. It should not cut it. Always remember, it should not cut. It can touch, but it should not cut. First, always worry about the center one. Once if you get the triangle for area for the center one, automatically you will get the areas for the other thing. Basic idea. Fine. Next problems, if you see, uh, we missed a question here. If you want, you can solve this. This is based on this type of question. What is that? Normal ratio question. The following rainfall data refers to the station A and B which are equidistant from station X. Normal rainfall at A, X, B is given. Annual rainfall at A and B is given. He is asking to find out what is the rainfall at B. How will you calculate that? How will you calculate this? Simple. Give me the answer for this. This is based on previous concept. We missed the question. Try to solve it. Give the answer for this. So Prachi has given answer as 200. What about the other people? 20, 200, yeah. So how will you calculate? P. Px would be equals to, simple, Px would be equals to Nx upon N, Pa upon Na, Pa upon Na plus Pb upon Nb. Pa upon Na plus Pb upon Nb. Nx value is 250. 250 upon 2 Pa, that is 200 upon 140. 200 upon 140 plus 300 upon 270. 300 upon 270. No, 270 upon 300. 140 upon 200 plus 270 upon 300. So this is 250 by 2 multiplied with 0.7 plus 0.9. So that is 250 by 2 multiplied with 1.6, 25 multiplied with 8. 200 mm. Simple. Okay. We have already done that. Anyway, just since I have missed that, we have doing it. Next question. A catchment may idealized as, next question, a catchment may idealize as rectangle. A catchment may idealize as rectangle. There are 3 rain gauge stations located inside the catchment at arbitrary locations. A catchment may be idealized as a rectangle. A catchment may be idealized as rectangle. There are 3 rain gauges located inside the catchment at arbitrary locations. The average precipitation over the catchment is estimated by 2 methods. The average precipitation over the catchment is estimated by 2 methods: arithmetic mean, Thiessen polygon. Which of the following statement is correct? PA is always smaller than PT. PA is always greater than PT. PA is always equals to PT. There is no definite relationship between PA and PT. What is the answer? What is the answer? Please do like, share, subscribe. Chaitanya has given D. What about the other people? Prachi also has given answer as D. What happened to Soumya? Kumar, aren't you there? What about the other people? Two people has commented the answer. What about the other people? Shivam Gupta has given answer as B. So answer as B. You know what? There is no relationship between PA and PT. How can you say there is a relationship? How can you say there is a relationship? What we can say is from here you'll get more accurate answer compared to that of here. That is the only thing that you can say. You can't say anything. You can't say anything whether PA is more, PA is equal to, PA is less than. There is no relationship. There is no relationship. So people were asking, sir, you haven't said this. What is there to say? Is there, if there is some relationship, I would have already told you. There is no relationship between PA and PT. Okay, your answer is D. So there is no definite relationship. You can't say which one is more, which one is less. Fine. A hydrograph is a graph representing what? A hydrograph is a graph representing rainfall volume with time, rainfall volume with time, rainfall intensity with time, rainfall volume with duration, duration or time both is same, rainfall intensity over the area. A hydrograph is a graph representing what? Rainfall intensity with respect to time. Rainfall volume with respect to time is called as mass curve. Rainfall volume with respect to time is called as mass curve. Okay, rainfall volume with respect to time is called as mass curve. Fine. Next, iso height. Iso height is a line joining points of what? Iso height is a line joining points of. Iso height is a line joining points of. Iso height is a line joining points of. Iso height is a line joining points of what? Iso height is a line joining points of equal rainfall depth. So line joining points of equal rainfall depth is called as iso height. Simple question. Now see another method of finding average rainfall. We have seen two methods of finding average rainfall, right? That is arithmetic method and Thesin polygon method. Fine. And another method of finding average rainfall is isohydral method, one of the best method to find out the average rainfall. Let us say there are different iso heights. P1 iso heights means line joining points of equal rainfall, right? So let us say the rainfall, this is P1, P2, P3, P4, Pn. Rainfall, this represents what? Rainfall. Iso height means line joining points of equal rainfall. And let us say area is A1, A2, A3, A4 and so on up to, if I say this as Pn minus 1, this would be An minus 1, this is An. If it is something like this, then P average would be, in the area of A1 we assume the rainfall as P1 only. So A1 P1 would be extra. In area A2, in this area A2, we'll assume an average rainfall of P1 plus P2 by 2. Right? Here, in this place it is P1, in this place it is P2. So in area A2, the rainfall will be in this range only. So that would be equals to P1 plus P2 by 2. And in A3, it would be, in this area it is A2 plus A3 upon 2. I mean, in the area A3 it is P2 plus P3 upon 2. Rainfall. See, let us say this is 100 centimeters, this is 90 centimeters. So in this region, the average rainfall would be 95 centimeters. You can say that. That is the meaning of it. This is A4. In area A4, it is P3 plus P4 upon 2. P3 plus P4 upon 2. So plus so on up to, in this area An minus 1, this is Pn minus 1 plus Pn upon 2. And in this area An, it would be Pn An. Whole thing upon P1 plus P2 plus P3 plus so on up to not P1 plus P2, A1 plus A2 plus A3 plus so on up to AN. This is called as isohydral method. This is called as isohydral method. Isohydral method. This is called as isohydral method. So here we'll assume a precipitation of P1. Here we'll assume an average precipitation of P1 plus P2 by 2. Here it is P2 plus P3 by 2, P3 plus P4 by 2. You'll take the average precipitation values. And if A1 and A0 is not there, if A1 and AN is not there, if A1 and AN is not there, then what will be your answer? If let us say AN and A1 is not there, then you will remove these things. You will remove these things. Fine. You will directly, in this area it is P1 plus P2 by 2. In this area it is P2 plus P3 by 2. That is how you will try to find out. Okay. Or if they say this is A1, I don't want you to get confused. Let us say this is A1, this is A2, this is A3 plus so on up to this is AN. Pn minus 1 AN. Then it would be simply A1 A1 A2 A3 AN. Okay. Whatever way that is, if extra areas are given, you have to add extra. If not, you can leave it something like this. Fine. So intensity should be, how ISO height? Intensity should be there, sir. But equal rainfall depth point called as an isopluvial. See, it should be equal rainfall intensity, but better option is what? Equal rainfall depth only. Here, what is the better option? Equal rainfall depth. See, rain gauges can also be called as pluviometer. It can be also be called as odometer. It can also be called as hytometer. Fine. That is the reason sometimes it is said as isopluvial. It has to be line joining points of equal intensities. But the method is said something like this. Since the better option here, it would be equal rainfall depth only. There is no rainfall intensity. There is rainfall depth. So go with rainfall depth only. That is the idea. In isohydral method also, these are considered as isoheights, where rainfall depth is uniform. Fine. So generally, this is how you will be solving this. Now, try to solve this question. The area between two isoheights, the area between two isoheights, 45 centimeters and 55 centimeters is 100 kilometers square, and between 55 and 65 is 150 kilometers square. What is the average depth of precipitation over the depth of 250 kilometers square? What is the average depth of precipitation over the depth of 250 kilometer square? line joining points of equal evaporation. For that I'll tell you another line. Okay, what is that called as? Line joining points of equal evapotranspiration. So evaporation and precipitation cannot be correlated. Precipitation is an inflow, evaporation is an outflow. So don't think very too much into it. Pluvial or hydro both mean same. Okay. If you go in depth of it, that I'll go with equal evaporation mm per day, it cannot be collaborated. No, evaporation and intensity cannot never be collaborated. Thinking is wrong. And evaporation also, he's not said evaporation rate, he said equal evaporation. That will be in mm only. Evaporation rate would be per day. So Prachi has given me the answer as 56. You are thinking too much, Chaitanya. Equal evaporation, this is also in This is not evaporation rate, to be said as evaporation per day. Fine. Pluvial, I already told you, pluvial, hydro, udo, everything is same. Fine. So how you are going to solve this? There is 45 centimeters and 55 centimeters iso height and 65 centimeters iso height. So 45, 55, 65, and this is 100 kilometers square, and this one is 150 kilometers square. 150 kilometers square, 100 kilometers square. Fine. How you are going to find out average? P average would be equals to, for this area, the average rainfall is 45 plus 55 by 2. 45 plus 55 by 2, and 150, this would be 55 plus 65 by 2. So whole upon whole area of 250. So this is equals to 100 multiplied with 50 plus 150 multiplied with 60 upon 250. Upon 250. Fine. So this is 20. 5 5s. 100 multiplied with 50 upon 250, 1 by 5, plus 3 by 5 multiplied with 60, 12, 36, 20. So that equals to 56 centimeters. No, if you challenge also, you will not be getting answer, because they'll simply say there is a method called isohydral method. Haven't you studied isohydral method? In isohydral method, we have clearly said line joining points of equal precipitation is also considered as isoheights. So if an isoheight is given to you, why can't you go for rainfall of equal depth or equal rainfall depth? This is an isohydral method. In isohydral method, we are talking about isoheights. Isoheights, we are considering the line joining points of equal rainfall depth. So you can consider that also. Pulviometer is for rainfall depth. Obviously, then rain gauge is also called as pulviometer. From that you can get rainfall intensity also. So if you challenge also, I don't think so you'll be getting it. It's like you have to understand it. If they ask question like isopulvial or isopulvial and isoheight in depth, like if they go and ask, then you can say the difference. But if in the examination they say isoheight, you have to go with it. You don't have to be worried about it. Okay, fine. What is the answer for this question? Anyway, next one is consistency of the data. 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 If data is inconsistent, inconsistent means what? Let us say at the station every year you will be saying rainfall of 100 centimeters, 80, 90, or it will be like 85, 95. It will be in the range of 85 to 100 only. Suddenly you have seen the rainfall in that station as 500 centimeters. Why there is 500 centimeters? So if there is sudden inconsistency in the data in an year, if there is sudden inconsistency in the data, the inconsistency can be because of various things. Inconsistency can be because of various things. Can be because of various things. First one, station is being shifted. If station is shifted, there can be inconsistency. If station is shifted from one point to other point, the like nearby only, there can be some inconsistency. Or if nearby stations undergoing any change, if nearby stations undergoing any change, if nearby stations undergoing any change, then if undergoing any change, that effect will also be seen in the present station. So there can be inconsistency. Or it can be because of natural calamities. Due to natural calamities, it can be due to natural calamities, like if there is earthquakes, forest fires, everything, tsunami, suddenly there can be change in the values. Or it can be because of manual error. Fine. It can be because of manual error. So inconsistency in the data can be because of all these things. Inconsistency in the rainfall value can be because of all these things, and it can be found out by a method called as double mass curve method. Here you'll be drawing a graph between accumulated rainfall at station X, accumulated mean of accumulated rainfall of n nearby stations near X. Fine. So here the graph would be, let us say it can be something like this. You'll be drawing in a reverse chronological order. That means 2022, 2021, 2020, 2010, 2009, 2008. This is called as double mass curve, because on the both sides it is mass. Double mass curve. Fine. Accumulated rainfall at station X. What is the rainfall at station X in the year 2022? And you'll select n nearby stations and you'll take the average of it and that value. You'll draw a graph. And if you see, in the year 2020, there is inconsistency that is occurred. The value that is taken today is taken as better value compared to that of previous thing, because today you can go and check. So you'll be drawing this in reverse chronological order. And if you want the correct value, how you are going to get it? If I take this slope theta 1 and this slope as theta 2, this is B, I'll call this as C, and I'll call this as A. Call this as C, call this as A. PCX, corrected value would be equals to Px multiplied with tan theta 1 upon tan theta 2. So that would be equals to Px multiplied with C by B upon A by B, that is equals to Px multiplied with C upon A. So this is the correction factor. This is the correction factor. Fine. So PCX is, this is the corrected value of rainfall at station X would be equals to given value multiplied with correction factor. This will be your C, this will be your A. So this is how you'll try to find out what is that consistency data, corrected value. Fine. So consistency or inconsistency is found out using double mass curve technique. Fine. So double mass curve technique, if you see problem, the inconsistency of rainfall data can be checked by which one of the following? It can be checked by double mass curve method. Inconsistency can be checked by double mass curve method. Next there is a match the following: rainfall intensity, rainfall excess, rainfall averaging, mass curve. So how you are going to find out? Let us say we'll go from the ending. Mass curve equals to cumulative rainfall with respect to time. Okay. Rainfall averaging. Rainfall averaging can be obtained from ISO heights. Fine. Rainfall intensity. Rainfall intensity can be obtained by hydrograph. This is 3. And this is rainfall averaging is 1. Mass curve is 2. So the thing is 4. So 3, 4, 1, 2. Your option would be B. Fine. So any doubts in this? You can ask me. Any doubts in this? Prachi said something. Sir, 1 week में exam है. Questions जो आता होगा वो भी भूल जाएंगे. You know what? This girl Prachi, she is one of the tensed girl that I have ever seen. Why you are tense that much? Don't worry, life is not going to stop. Be cool. Okay? Don't get tense. Don't think that in 1 week there is an examination, big thing that is occurring. No, it is just simple examination where you have to go coolly and give it like that. If you really feel like it is just a normal examination like any other day, then you'll score better. Okay? Don't think too much that in 1 week you have to do that, you have to constantly do what you can do. Put all your efforts, your 100%. Then results is not in our hand. Okay, like Krishna said in Mahabharata, put all your efforts and don't expect the results. So results are not in our hands, but efforts are in our hands. Even MS Dhoni said the same thing. Many people keep on saying the same thing. Process and efforts is in our hands. Results are not in our hands. Okay, fine. So let's take a break. We have done the precipitation. Let's take a break for 10 to 15 minutes, and after that we'll go for what? We'll go for the rest of the concepts. Okay? Yeah. Fine. Bye. We'll meet after 15 minutes. Hi friends, anyone there? आ जाएगी सर. Okay. आ जाइए. अच्छा. I came. Prachi, are you there? If anyone is there, please do comment. Yeah, I took some 8 minutes extra of the break. Sorry for it. Anyone there? Please do comment. Hi. Hello. Everyone came back. Prachi is there. I don't know other people. Please do comment. You're there. What about the other people? Comment guys if you're there. I'll go for next thing, that is evaporation. We have seen precipitation and losses of the precipitation. First thing, one of the losses would be evaporation. Evaporation and evapotranspiration. Evapotranspiration. Fine. So I'm not going to discuss much into it. It is just theoretical concepts. Fine. If this is just theoretical concepts. So evaporation. Evaporation is like it's like water is being evaporated into the atmosphere. It is generally cooling process. That means it takes that latent heat of vaporization from the surroundings and then it will be converted into the vapor and it reaches to the atmosphere. Fine. So good noon. I think it is not noon. Fine. So that is evaporation, and evaporation is a cooling process. It gets the heat from the surrounding and then it evaporates. Fine. So that is simply evaporation I can take, and in evaporation the factors affecting evaporation. Factors affecting evaporation. Evaporation. Fine. So the factors affecting evaporation is vapor pressure. Vapor pressure, if I say, first one would be vapor pressure. Vapor pressure. Factors affecting evaporation, vapor pressure. So if vapor pressure is more, evaporation will be more. If vapor pressure is less, evaporation would be less. Fine. If vapor pressure is less, evaporation would be less. And sorry, that means here vapor pressure would be something like this. Vapor pressure would be something like this. What is the difference between vapors and gases? All the vapors are gases, but all the gases are not vapors. Why, sir? See, vapors are the one. This, if you provide heat, water will be converted into vapor. From liquid state it will be entered into the gaseous state, and if you apply pressure to that gases, it will be converted back to liquid. So vapors are the one which can be converted back to liquid, but all gases cannot be converted to liquids. Fine. So all vapors are gases. All vapors are gases. All vapors are gases, but all gases are not vapors. But all gases are not vapors. But all gases are not vapors. Fine. Anyway, evaporation is proportional to EW minus EA. EW is the vapor pressure, EA is the atmospheric pressure. So if vapor pressure is more, then obviously evaporation will be more. So if vapor pressure is high, evaporation is directly proportional to vapor pressure. At the same time, evaporation is indirectly proportional to atmospheric pressure. Right? If atmospheric pressure is more, evaporation would be less. EA is atmospheric pressure. EA is atmospheric pressure. EA is atmospheric pressure. And EW is vapor pressure. Fine. EW is vapor pressure. So if vapor pressure is more, evaporation is more. If atmospheric pressure is more, evaporation is less. Fine. This is the factors affecting evaporation. That is, first one is vapor pressure. Next one, temperature. So evaporation is directly proportional to temperature. right? If temperature is more, evaporation would be high, obviously. Next, wind. If with increase in the wind, evaporation will be increased up to certain extent. After that, with increase in the wind, evaporation will not change, it will remain constant. Fine. This is evaporation with respect to the wind. Wind velocity or wind pressure. That means if you are taking any beaker and if there is a water on this, wind comes and removes all the atmospheric pressure on it. Wind comes, removes that, there is atmospheric pressure on this, that will be removed by the wind, and it can easily evaporate into the things. So evaporation is directly proportional to wind. Fine. And let us say a whole atmospheric pressure is removed, then evaporation will remain constant. Fine. So with increase in the wind velocity, evaporation will keep on increasing up to certain extent, and after that it will remain constant. Next one, soluble salts. Evaporation is inversely proportional to soluble salts. That means if there is salts present in the water, then evaporation would be less. If there is any salts present in the water, evaporation would be less, and if not, evaporation would be more. So evaporation would be very much high. That means that is the reason evaporation is less in ocean and compared to that of lands, compared to that of lake, compared to that of not land, compared to that of lake. Compared to that of lake, evaporation is less in oceans. In the rivers and lakes, evaporation will be very much high because salts are less. If soluble salts are present, then it takes more energy to convert that into vapors, to convert water into vapors. And remember one thing, if you are taking a land and the ocean, here evaporation is more, precipitation is less. And in the land, evaporation is less, precipitation would be more, because here the heat is very much high. Heat is high, humidity high, wind velocity is very much high, atmospheric pressure would be less, so evaporation will be very much more in the oceans. Evaporation is more, precipitation is less in the oceans, and evaporation is less, precipitation is more in the lands. This is, so evaporation is indirectly proportional to soluble salts. This is a different thing. When you compared with the lake, in ocean evaporation will be less. When you compare with land, in ocean evaporation will be more. Fine. So this is another factor that affects evaporation. Next, depth of the body. Fine. So that means shallow lakes or deep lakes. During summer, in shallow bodies, evaporation will be more, because shallow bodies means heat goes, shallow bodies means depth is less, heat goes up to the bottom. It gets intermixed. Heat goes up to the bottom. It gets intermixed properly, so that evaporation will be very much high compared to that of deep water bodies. Evaporation is more in the shallow bodies during summer. And during winter, in shallow bodies, what happens is, everything, let us say, it is converted into ice. It is very much cool, it is converted into ice. That means evaporation would be less. Whereas in deep bodies, evaporation would be more. Why? In deep bodies, if let us say, here the temperature might be reduced. Let us say there is ice formed at the top, but in the bottom, ice will not be formed. There will be water. Fine. So heat will be there in the bottom. So evaporation will be, some amount of evaporation will be there. Fine. So in deep bodies, evaporation will be more. In shallow bodies, evaporation would be less. During winter, during summer, shallow bodies evaporation would be more, deep bodies evaporation would be less. This is depth of the body. Next, surface. Surface, type of surface. Type of surface. So when you see different types of surfaces, plane surface, concave surface, and this is convex surface. Fine. So where evaporation would be more, here the evaporation would be more because surface area is more amount of area is exposed, so evaporation will be high here. Evaporation will be high, evaporation would be less because less amount of area is exposed. Surface area is more, surface area is more, and surface area is less. Surface area is less. So here it would be neutral. Neutral. This is for plane surface. It would be neutral. Okay. So this is the these are the places where generally we see factors that affects the evaporation. Simple. Fine. These are the factors that affects the evaporation. So Chaitanya asked a question. Any question from double masker? No, yeah. Already we have seen. If PCX is asked, PX multiplied with C upon A. That's it. What is if it is engineering services conventional, I would have given question. Since it is gate and that too quick revision, we are not discussing that. Okay. So any doubts here? What are the factors that is affecting evaporation? Please let me know. These are the factors that is affecting evaporation. Any doubts in this? You can ask. Go ahead and ask. Any doubts? No doubts? Fine. Well and good. So this is the factors that is affecting evaporation. Once you know the factors that is affecting evaporation, methods to reduce evaporation. Methods to reduce evaporation. Because this is a loss, you have to reduce this. Methods to reduce evaporation. So methods to reduce evaporation, if we talk about it, methods to reduce evaporation. Methods to reduce evaporation. First one is increasing the depth. Volume would be equals to area multiplied with depth. If I increase the depth, that means reduce the area. If I increase the depth, what happens if you are constructing any dam, a reservoir is formed. If I increase the depth, surface area is reduced, so automatically evaporation will be decreased. So first one is increasing the depth. Increasing the depth. Increasing the depth. Next one is providing mechanical covers. Providing mechanical covers. Providing mechanical covers. Fine. Providing mechanical covers means just by providing a big sheets of thermocoals or sometimes steel plants that can float on this. If you provide that, evaporation cannot be hacked. Generally in canals you will see that. In canals you will be trying to provide mechanical covers. Anyway, that is not that much effective in providing the in reducing because it is more costlier. Next, third one is providing invincible covers. Providing invisible chemical films. So by providing cetyl alcohol, or that is hexadecanol, and sterile alcohol, that is octadecanol, that is octadecanol. By providing these two things, if you pour this in the water, an invisible film will be formed on the top of the water. An invisible film will be formed on the top of the water. Invisible chemical film. This is a chemical film. So invisible chemical film will be formed on the water. So if let us say this is the water. Here oxygen can go and carbon dioxide can go out. CO2 can go out, but evaporation will not take place. Gases can go, but water can't evaporate. Fine. So that is the film. By providing cetyl alcohol, 60% of evaporation will be generally reduced. 60% of evaporation is generally reduced by providing cetyl alcohol. So these are the points that we generally have to remember. Conservation of the water or methods to reduce the evaporation. Fine. Methods to reduce the evaporation. Next, what are the methods to find the evaporation? Methods to calculate evaporation. Methods to calculate evaporation. So in that there are different methods. Pans. You will be using evaporation pans. Different pans is there. Fine. So pan A. There is something called pan A. So that means what you will be doing is you will be taking a pan, generally of diameter 1210 mm, and there is a depth of 255 mm. This is pan A, just giving an idea. What you will be doing is you will be filling the water and you will keeping it like this, and you will try to find out what is the evaporation per day. What is the evaporation per day that is happening over here? That is called as pan evaporation. This is called as pan evaporation. So once if you know pan evaporation, the lake evaporation equals to evaporation coefficient multiplied with pan evaporation. Pan coefficient, that is also called as pan evaporation. This K is called as pan coefficient. This K is called as pan coefficient. For different pans it would be different. Fine. So if pan evaporation is given to you, lake evaporation equals to pan coefficient multiplied with pan evaporation. So how exactly you will be finding that? And generally for different pans, pan coefficient or evaporation coefficient pan. So there will be different pans. Pan A, ISI pan, Colorado sunken pan, which is one of the best pan. So this is 0.7, this would be 0.8, this would be 0.78. So if nothing is mentioned in the question, you will assume that as Indian standards pan, and you will be taking it as 0.8. So pan coefficient or evaporation coefficient, you will be taking it as 0.8. So lake evaporation equals to pan evaporation multiplied with pan coefficient. That will give you the lake evaporation in mm per day or whatever that is. In a given day, if you calculate, you will be getting something like this. Fine. This can be K, this can be E, this can be P, anything. In different places it is given in different way. Next is you can use water budget equation. So from water budget equation also you can do that. Water budget equation. So from water budget equation also you can do that. Inflow minus outflow equals to change in storage. This is one of the equation. Other equation that you can use is Penman's equation. I'll just give you on what basis it will be dependent on. I'll not be giving you the equation, not much useful. Okay, this is based on energy balance and mass transfer method. Energy balance and mass transfer method, energy balance and mass transfer method. Fine. So that is the Penman's equation that we can generally use. It is based on this method. There are different things. I don't want you to remember that. Okay, so these are the things that we generally see. And there is an equation to find out the evaporation also. That is an empirical method. E equals to K times EW minus EA multiplied with 1 plus V9 upon 16. Fine. So where E is the evaporation in mm per day. V is the evaporation in mm per day. EW equals to vapor pressure, saturated vapor pressure in mm of Hg. You have to convert that in mm of Hg, saturated vapor pressure in mm of Hg, and EA is the atmospheric pressure in mm of Hg in mm of Hg. V9 is the wind velocity. Wind velocity at 9 meters height. And V9 is that can be obtained from 1/7 power law, Ch to the power of 1 by 7. V equals to Ch to the power of Vh equals to Ch to the power of 1 by 7. If you want V9, C into 9 to the power of 1 by 7. So this is how you'll be getting it. You'll be getting it in kilometers per hour only. Substitute in whatever way you want, you'll get your answer. Fine. K is a constant that depends upon whether it is shallow body or deep water bodies. Fine. So based on that, you'll get the evaporation. This is based on Dalton's law. This is the empirical method that is based on Dalton's law. Fine. So any doubts up to here, you can ask me. So do we need to memorize these coefficient values? Robert, it's better if you remember, but from gate point of view, they will give you. Maximum they will give you. You don't have to remember, but it would be better if you remember 0.7, 0.8, 0.78. That it's very simple. Okay. Any doubts up to here? Any doubts up to here? Any doubts up to here? No doubts? No doubts? Yeah, fine. Let's try to solve problems based on it. Consider the following chemical emulsions: methyl alcohol, cetyl alcohol, stearyl alcohol, kerosene. Which of the above chemical emulsions are used to minimize the loss of water through the process of evaporation? So what are the chemicals that is used to minimize the loss of water during the process of evaporation? That is cetyl alcohol and stearyl alcohol. Your option is D. Simple. Your option is D. Yeah. Next. A standard ground based evaporation pan corresponding to Indian standards is installed at the banks of the surface reservoir. The water surface area on a particular day is 100 hectares. The recorded evaporation loss from the pan on a certain day is nearly 4 centimeters. What is the anticipated evaporation loss from the reservoir for that day? Please give me the answer. What is the anticipated reservoir loss? What is the anticipated evaporation loss from the reservoir for that day? What is the anticipated evaporation loss from the reservoir from that day? What is the answer, guys? Chaitanya is saying C. What about the other guys? Please do like, share, subscribe. So how you are going to calculate this? What he is saying, area in hectares is given as 100 hectares. 100 hectares, right? So 1 hectare is 1 into 10 to the power of 4 meter square. Always remember that. 1 hectare is 1 into 10 to the power of 4 meter square. And recorded evaporation from the pan evaporation is 4 centimeters. Pan evaporation is 4 centimeters. Now he is asking what is the lake or reservoir evaporation. Lake evaporation or reservoir evaporation, and he said what is this? Indian standard span. So lake evaporation equals to pan coefficient multiplied with pan evaporation. For Indian standards pan, what is the value of K? For ISI, Indian standards, it is equals to 0.8, right? So this is 0.8 multiplied with 4 centimeters. 4 into 10 to the power of minus 2 meters. If you want the volume, multiply that with area into 10 square or 10 to the power of 4. So this is equals to 3.2 into 10 to the power of 4 meter cube. 3.2 into 10 to the power of 4 meter cube per day only, because this is recorded for a day. So your answer should be 3.2. 3.2 is in with this range. It is in option C. So it is equals to 3 into 10 to the power of 4 meter cube per day. Fine. 3.2. So your option is C. Why it is B? It is C. C is correct. Why you are saying B? I don't know. Option is C. 3.2. Okay. Fine. Next, the plain area of reservoir is 1 kilometer square. The water level in the reservoir is observed to be declined by 20 centimeters in a certain period. During the period, the reservoir receives an inflow of 10 hectare meters and 20 hectare meters are abstracted from the reservoir for the irrigation and power. The pan evaporation and rainfall recorded during the same period at a nearby meteorological stations are 12 centimeters and 3 centimeters respectively. The collaborated pan factor is 0.7. The seepage loss from the reservoir during this period in hectare meter. What is the seepage loss from the reservoir during this period in the hectare meter? Please give the answer. The plain area of a reservoir is 1 kilometer square. The water level in the reservoir is observed to be declined by 20 centimeters in a certain period. During the period, the reservoir receives an inflow of 10 hectare meter and there is an outflow of 20 hectare meters. He is given pan evaporation and he has given pan evaporation and rainfall recorded. Precipitation is, pan evaporation is 12 centimeters, precipitation is 3 centimeters, pan factor is 0.7. He is asking what is the seepage loss. Please give me the answer properly. Make it fast. Use that water budget equation and give me the answer. Questions दिखा दे. plain area 1 kilometer square declined by 20 centimeters during the period of reservoir 10 hectare meter, 20 hectare meter, and there is evaporation of 12 centimeters, 3 centimeters of rainfall. Colorado calibrated pan factor is 0.7. Fine, I'll draw it for you. There is a reservoir of area 1 kilometer square. Fine. Reservoir area equals to 1 kilometer square. Area equals to 1 kilometer square. So it will decline by an amount of 20 centimeters. There is 20 centimeters decline in the storage. Inflow is 10 hectare meter and outflow is 20 hectare meter. 20 hectare meter, and there is a pan evaporation. Nearby there is a pan, and pan evaporation is 12 centimeters. Pan coefficient is 0.7, and there is a rainfall of 3 centimeters. What is the seepage loss? He is asking what is the seepage loss. We have solved this type of question, but once again here it is asked, please try to solve. Just a minute, guys. .6 hectare meter. Really? .6 hectare meter. Yeah, that option is there. So any other person who is getting the answer? Any other person who is getting the answer? Why everyone left? The views are being decreased. Anyway, see, he is asking answer in hectare meters, so try to convert everything in hectare meters only. So precipitation is 3 centimeters. So 3 centimeters means in hectare meter. The idea is simple. You have to use water budget equation. Inflow minus outflow. Inflow minus outflow equals to change in storage. Change in storage. Fine. So inflow is 10 hectare meters, outflow is 20 hectare meters. This is 10, and precipitation is 3 centimeters. So 3 into 10 to the power of minus 2 multiplied with area is 1 kilometer square. 1 into 10 to the power of 6. We'll try to convert this in hectare meter. So 3 centimeters precipitation is equals to 3 into 10 to the power of minus 2 meters multiplied with 1 into 10 to the power of 6 meters square. Fine. So this is 3 into 10 to the power of 4 meter cube. This is meters, that is meter square, meter cube. And if you want this in hectare meters, 3 hectare meters. Simply you can write 3 hectare meter. Similarly, what is evaporation? 0.7 times 12. That equals to 8.4 centimeters. 8.4 centimeters, if you multiply this with 1, you will get 8.4 hectare meter directly. 8.4 hectare meter. So 20 centimeters means 20 hectare meters. Same. 20 hectare meters. So inflow minus outflow. This is 3 plus 10 minus 20 minus 8.4 minus seepage loss that you have to calculate, that equals to minus 20. So seepage loss would be equals to 20 plus 13 minus 20 minus 8.4. 13 minus 8.4, 4.6 hectare meter. 4.6 hectare meter. Okay. Any doubts? The idea is, maybe you got confused how to convert. 1 hectare is 10 to the power of 4 meter square. That is the meaning of it. So 4.6 hectare meter. Any doubts in this, guys? Unit conversion should be very much important. So any doubts? Any doubts? Any doubts? No doubt in this question. Only one person commenting. What happened to the other guys? No doubts. Anyway, so there is this question. You can see, over the oceans there is more evaporation than precipitation. On land it is more precipitation than evapotranspiration or evaporation. Both are correct. This question is correct. So apart from evaporation, here there is another concept called evapotranspiration. In depth of that will be discussed in your, might have been discussed in your irrigation engineering. I am not discussing that, but I'll be giving you answers for some questions. That's it. Okay. So Bowen's ratio is from the energy method actually. So Bowen's ratio is the ratio of heat to vapor diffusivities. Bowen's ratio is the ratio of heat to vapor diffusivities. That is, you'll be using that ratio in big equation, not a bigger thing. I'm not discussing that over here. In your evapotranspiration concept, in your irrigation it might have been discussed, but anyway the problem is given over here. That's why I'm seeing this. Okay. Next, evapotranspiration. If we are talking about evapotranspiration is the amount of water that is evaporated from the leaves. Fine. So that is also indirectly called as consumptive use concept. That consumptive use, frequency upon consumptive use, we can get number of days it has to be irrigated and all those things will be seen there. But anyway, so evapotranspiration can be measured by two things, that is AET, actual evapotranspiration, and PET, potential evapotranspiration. Potential evapotranspiration. potential evapotranspiration. Fine. Actual evapotranspiration and potential evapotranspiration. Actual evapotranspiration means first I'll say potential evapotranspiration. If sufficient amount of water is present, let us say for rice 120 centimeters of water is required. So sufficient amount of water is present, and plants take that sufficient amount of water, and it will during that period some amount of evapotranspiration takes place, right? Some amount of evapotranspiration takes place. That evaporation is called as potential evapotranspiration. This is also called as consumptive use. Consumptive use. So when sufficient amount of water is present, whatever the evapotranspiration that takes place, that is called as potential evapotranspiration. And actual evapotranspiration, that means you can't provide that water that is required for the crop. For crop you can't provide water that is required. So during that period, instead of 120 centimeters, if you are providing only 80 centimeters, then how much amount of evapotranspiration takes place? That is called as actual evapotranspiration. Fine. That is called as actual evapotranspiration. So actual evapotranspiration actual evapotranspiration upon potential evapotranspiration, it can vary from 0 to 1. 0 to 1. That means if there is no water, actual evapotranspiration is 0. If there is full water, if there is full amount of water, then actual evapotranspiration equals to potential evapotranspiration. This is evapotranspiration concept is totally for growth of crops. Fine. So if whether sufficient amount of water is present, or if it is present or not, we are going to check that. If sufficient amount of water is present, plants take some amount of water from the roots. There will be water in the leaves, and there will be evaporation from the leaves, right? That is called as evapotranspiration. If sufficient water is present, whatever the evapotranspiration that takes place is called as potential evapotranspiration. If sufficient water is not present, in the actual conditions, whatever the evapotranspiration takes place, that is called as actual evapotranspiration. Fine. The ratio of evapotranspiration to potential transpiration generally varies from 0 to 1. There is an index that is called as aridity index. Aridity index. Aridity index. So aridity index, that is difference between potential evapotranspiration upon PET multiplied with 100. Fine. So this is aridity index. Potential evapotranspiration minus actual evapotranspiration upon potential evapotranspiration multiplied with 100. It says how much amount of agricultural drought is there. Aridity index indicates agricultural drought. If it is 25%, 0 to 25%, it is drought. If it is 25 to 50%, it is severe drought, or I will say moderate drought. And if it is more than 50%, it is severe drought. Severe drought case. Fine. So these are the points. Aridity index from 0 to 25%, it will be considered as drought. Drought. 25 to 50, moderate drought. Moderate drought. And if it is more than 50%, then it is called as severe drought. Severe drought. Okay. These are different points that we generally see in the aridity index, evapotranspiration case. Generally, evapotranspiration is obtained by an instrument called as lysimeter. Lysimeter. Evapotranspiration is obtained by an instrument called as lysimeter. What exactly you will be doing in the lysimeter is, you will grow the crop. You will keep a crop. What are the crop you want to grow? You will keep that crop, and there will be slotted plate that is present at the bottom, and everything will be kept in soil. There will be a soil, and at the bottom of the soil plate there will be perforated plate that is kept at the bottom. So there is a perforated plate. This is soil. In the soil, plants will be kept. there is perforated plate at the bottom, perforated plate at the bottom, and this is plants, and this one is soil. Okay, there is a perforated plate, soil, and there are plants. Fine. So then what you will be doing is you will be providing the water, and some amount of water will be removed, and some amount of water, the rest of the amount of water will be absorbed by the plants. That is taken as evapotranspiration values. Fine. So that is how amount of water entering and amount of water leaving. You don't consider any evaporation here. You will be just seeing the water that is absorbed by the plants is taken as evapotranspiration. So lysimeter is the instrument which is used to measure evapotranspiration. Evapotranspiration. Fine. I am just giving you the basic idea, not in-depth knowledge in this. Fine. And there are other equations also, Blaney-Criddle equations and all those things. Anyway, that I am not discussing here. This is some of the basic idea regarding evapotranspiration. So in this same thing only, there will be heat diffusivities. So that ratio is given as Bowen's ratio. As I said, Bowen's ratio here. Bowen's ratio is defined as ratio of heat and vapor diffusivities. How much amount of heat is there? Due to that heat, how much amount of vapor comes out? That is the ratio. Fine. Anyway, if you want to remember, you can remember that. And the ratio of actual evapotranspiration to potential evapotranspiration, it is in the range of, the ratio of actual evapotranspiration to potential evapotranspiration, it is in the range of 0 to 1. A lysimeter is used to measure evapotranspiration. Lysimeter is used to measure evapotranspiration. Okay. Next, lysimeter and tensiometer are used to measure respectively which one of the following things. Lysimeter is used to measure evaporation, and tensiometer, the name itself says you will get surface tension that is indirectly related to capillary potential. So lysimeter is used to measure evapotranspiration. From that only you can answer this. Lysimeter is used to measure evapotranspiration. Tensiometer, surface tension thing, that is used to measure what is the capillary potential of that crop. Okay. Capillary potential of that crop. Next, isoplates. Isoplates are the one line joining points of equal depths of evapotranspiration. Isoplates. Isoheights are line joining points of equal rainfall depth, whereas isoplates is the line joining points of equal evapotranspiration. Fine. So these are the points. Any doubts in this? You can ask me. Any doubts? Any doubts? See, I am not saying that I have discussed everything. I have just given some basic thing that will be required from your exam point of view. Okay. Any doubts in this? Isoplates. Sir, you have not said that just now. You can remember now. In the examination, if they ask, you can directly tick it off. Isoplates is evapotranspiration. Isoheights is rainfall depth. Okay. So I have just given told you what is evapotranspiration, what is potential evapotranspiration, actual evapotranspiration, the ratio of that, and all those things. I have not given Penman's equation, but I told you Penman's equation is based on energy balance and mass transfer approach. Horton's equation will be seen in the infiltration concept. So why you are talking about Horton's equations here? I am talking about evapotranspiration and evaporation. And Mayer's equation, I have discussed that equation, right? Evaporation, I have discussed that equation. So what are you worried about? I am just talking about whatever I have tried to explain, whether you are able to solve it or not. Mayer's equation and Horton's equation. Just now I have given Mayer's equation, right? I told you this equation is based on Dalton's law, but this is the Mayer's equation, right? This is Mayer's equation only. This equation is based on Dalton's law. This is Mayer's equation only. Harton's equation will be seen in the infiltration concept. So what are you asking? Penman equation is not required. Obviously it is not required. There is some bigger heat diffusivities and all those things. You can't think much about it. Yeah, exactly. The K value I told you that will be given to you in the examination. That is 0.36 for small shallow water bodies. It is 0.5 for deep water bodies. V9 you have to calculate. Penman equation is not required. That is a bigger thing. That's the reason I have not discussed Penman equation. Blaney-Criddle equation in your engineering, in your irrigation engineering, you have to see that. Okay, in hydrology, I am not discussing that. Fine. So, this is the idea. This is evaporation and evapotranspiration, some of the important concepts in that. Next comes infiltration. Next comes what? Infiltration. Next thing, infiltration. Fine. So, whenever there is rainfall, precipitation, right, there will be rainfall. Some amount of precipitation will be going as infiltration and some amount will be going as runoff. This is infiltration. This is infiltration. So if water is going through the soil, that is considered as infiltration. If that water reaches the groundwater table, then it is called as percolation. Fine. So don't get confused. And from here there will be evapotranspiration, and here there will be from evaporation. This is precipitation, right? So there will be some initial losses. That whenever rainfall occurs, there is a possibility that instead of going into the ground, it gets in your top portion of your building, some amount of water can be held over there, and some amount of the water can be held in the storage, that is called as depression storage. These are called as interception losses, and this is depression storage. This is called as depression storage. So instead of going into the ground, it can be some amount of losses will be there. This losses can be as high as 20%. These losses can be as high as 20%. So these are called as initial losses. So initial losses, there are two things: interception losses, and depression storage. Interception losses and depression storage. Fine. So interception losses and depression storage. The rest thing will be infiltration. So what happens is, interception losses means it will be intercepted and once again it gets evaporated back into the atmosphere. Here also depression storage, here it gets stocked and it can go back into the atmosphere. As it gets back as into the atmosphere. It can be as high as 20%. So these are the initial losses that you have to generally consider. Fine. Now, if you take any soil, let us say it is very hot. Okay. Now, groundwater table would be at very deeper depths. So initially when rainfall is there, what happens? There will be huge amount of infiltration. And there will be less amount of runoff. Runoff would be less, infiltration will be more, right? When there is precipitation, infiltration will be more, runoff would be less initially. Then what happens? Groundwater table will go. So then it gets completely saturated. The soil, when it gets completely saturated, that means initially infiltration rate would be high. Over a period of time, infiltration rate will keep on decrease, and once it gets completely saturated, that means all voids are filled with the water, then infiltration rate will remain constant, right? The groundwater table, finally it will reach to the ocean. Okay, finally it will reach to the oceans. Fine. So it will increase, and finally it will that means infiltration rate will decrease, groundwater table will increase. Fine. Initially groundwater table is here, so whatever you go, precipitation, huge amount of infiltration, less amount of runoff. Over a period of time, if groundwater table keeps on increasing, infiltration rate will decrease and runoff will increase. Fine. So and once it gets completely saturated, then infiltration rate will remain constant. So if you draw a graph between infiltration rate with respect to time, initially infiltration rate will be very much high. Over a period of time it keeps on decreasing, and after that it will remain constant. Generally, if you see in sandy soil, infiltration rate will be more compared to that of clayey soil. Why? Because clay is impermeable. So in clayey soil, infiltration rate will be less compared to that of sandy soil. So this is how infiltration rate, this is not infiltration, this is infiltration rate in mm per hour. This is time t in seconds. Fine. Infiltration rate, time. So Horton has developed an equation for this. That equation is called as Horton's equation, which is used to find out the infiltration rate. It is used to find out what? Infiltration rate. This is initial infiltration, and let us say this is final infiltration, FF. This is infiltration rate in mm per hour, whatever mm per hour, mm per anything. This is time in hours or seconds, whatever that is. Fine. So if this is the infiltration rate, now Horton's equation, if you try to write the Horton's equation, which is used to find the infiltration rate at any time t. If let us say this is time t, infiltration rate at any time t is given as FF plus FF minus FT, FF minus FI minus FF, initial infiltration rate minus final infiltration rate, e power minus KT. K is a constant which depends upon type of the soil. So Fi is initial infiltration rate, and FF equals to final infiltration rate, and K is the constant, depends on various things, generally it depends upon type of soil. It will give you infiltration rate, mm per hour, mm per day, centimeters per hour, centimeters per day. Fine. So so this is the idea. This is infiltration rate from see, K is not permeability. It actually depends on type of soil, but it depends on various other things also. This is not, the unit is not meters per second. This is per second. See the unit is per second. not meters per second. This is a constant, that is. Okay, fine. So this is Horton's equation. If you want amount of infiltration for a given time period, what is the total infiltration quantity? Infiltration quantity would be equals to integral 0 to t f of t dt. Integral 0 to t f of t dt. If from 0 to t, if they ask from t1 to t2, then it is t1 to t2 f of t dt. So whatever they have asked, from that you have to find out infiltration quantity. Just this here, you will get this in mm. Horton's equation will give you infiltration rate. It will give you infiltration rate. And if you want to find out infiltration quantity, you have to integrate that. That means area under the curve. Area under the curve will give you infiltration. Fine, infiltration quantity. Okay, and always remember, precipitation minus infiltration will give you what? Runoff. In the examination, if they ask runoff, you can say, if you know precipitation, infiltration, you can find out runoff. Or if they ask infiltration, precipitation minus runoff equals to infiltration. Precipitation minus runoff equals to infiltration. And how can you get precipitation? Let us say the problems can be of this type also. Where a hydrograph is given to you. And the infiltration rate curve would be something like this. Then what would be your runoff? Runoff would be this. This would be your runoff. If they ask infiltration, let us say this is 0, 10, 20, 30, 40, 50 time, and this is, for this one it is, here it is, you can say infiltration rate. At the same time, intensity of rainfall. Both the things will be there. Intensity of rainfall. Fine. Both the things will be there. This whole thing, if they ask infiltration rate, this area, A1, this whole thing will be infiltrated only. It has up to this capacity, but this is the only rainfall. So whatever the rainfall that is occurring will be entering into the ground as water. So this whole thing will be infiltration. And let us say time is T1 here, time is T2 here. If they ask infiltration quantity, that would be equals to this area. This is the precipitation. Whole precipitation will go as infiltration. There is no runoff. Runoff equals to 0. A1 plus T1 to T2 f of t dt, or T2 to T1 to T2 f of t dt. You will get the infiltration quantity. This is the infiltration quantity. Okay. This is the infiltration quantity. Fine. So this is the infiltration quantity. Total precipitation means total area under the hydrograph will give you the precipitation, minus infiltration would be the runoff. If they ask you to find out runoff, total precipitation minus infiltration will be runoff. Precipitation would be this area, total area, minus infiltration would be runoff. Fine. So this is how you'll try to find out infiltration quantities. Runoff or infiltration, this is how you'll try to find out. Any doubts in this? You can ask me. Any doubts? Please do like, share, subscribe. So two people said they don't have any doubts. What about the other guys? Fine, no doubts. Let's solve problems on this. So the first problem is Harton's infiltration equation. Harton's infiltration equation was fitted to the data from an infiltration test. It was found that initial infiltration capacity was 20 mm per hour, final infiltration capacity was 5 mm per hour, and the decay constant is 0.5 hour inverse. If the infiltration was at the capacity rates, the total infiltration depth for a uniform storm of 10 hours duration is. Total infiltration depth for a uniform storm of 10 hours duration is. What is the total infiltration depth for a uniform storm of 10 hours duration is? So please give me what is the total what is it? Total infiltration depth. One person has given answer as A. What about the other people? Chaitanya also given answer as A. So how we are going to solve this? Initial infiltration capacity is 20 mm per hour, right? Initial infiltration capacity is 20 mm per hour, and final infiltration capacity is 5 mm per hour, right? Final infiltration capacity is 5 mm per hour. Decay constant is 0.5 hour inverse. 0.5 hour inverse. So Ft would be equals to Ff plus Fi minus Ff e to the power of minus kt. So Ff is how much? 5. This is 20 minus 5 e to the power of minus 0.5 times t. So 5 plus 15 times e to the power of minus 0.5 times t. For 0.5 times. This is Ft. And he is asked for 10 hours duration. What is the, for 10 hours duration, what is the infiltration capacity? So infiltration, not infiltration, amount of infiltration they are asking, 0 to t f of t dt, right? So 0 to 10, this is 5 plus 15 e power minus 0.5 times t, right? So this is 5 times 5t, right? 5t plus 15 times e to the power of minus 0.5 times t, minus 0.5 times t upon minus 0.5, 0 to 10. So this is 5 multiplied with 10 minus 0 minus 150 by 5, that is 30 e power minus 0.5 into 10 minus e power minus 0.5 into 0. Fine. So this is 50 minus 30 multiplied with 1 upon e to the power of 5 minus 1, right? Anyway, this is Since this is an engineering services question, so 1 upon e to the power of 5 can approximately taken as 0. So this is 50 minus of 30 minus 1. So that equals to 80 mm. In the gate, if they ask, you just have to calculate this, since this is ESE question, I think, right? This is ESE question. Answer is 80 mm. Approximately it is 80 mm. So can you please spend some more time on hydrograph and flood hydrograph portion? I am weak in that part. Of course, throughout the afternoon I will be doing that only, not a big issue. Now concentrate more on this. Concentrate more on this. Any doubts on this? So Chaitanya and Prachi are giving me the answer. What happened to you, Soumya? What happened to you, Robertino? And Kumar, I think he left in the morning only. Where are the other people? Any doubts? See, don't worry what other people's think. Whatever, sorry, not people's, what other people think. So whatever the doubt you're having, you can express your doubt. I don't know. What is your doubt? Fine. The next point. Next question. The parameters in the the parameters in Horton's equation are given. FO, FC, that means initial, this is final. Sorry, this is final, this is initial. K value is given to you for the assumed conditions. Continuous ponding, the cumulative infiltration at the end of 2 hours. What is the cumulative infiltration at the end of 2 hours? Please give me the answer. Let me complete hydrology today, then we'll discuss. Whatever the subjects you ask, I'll be doing that. Fine. So what is the answer? Please solve this question and let me know the answer. Robert, once we complete hydrology, if it is over at the end of the day, whatever the subject you want me to say, I'll discuss that. So let's see. Hopefully we'll complete hydrology by evening, then we'll talk about it. What is the answer for this? Please do like, share, subscribe, share with your friends. If you feel like this is useful, share with your friends, ask them to attend. I think Soumya also left. So people are decreasing instead of increasing, people are decreasing. Prachi has given D, answer as D, 4.18. What about the other people? D, okay, fine. So the parameters in the Horton's equation that is given to you. So he is asking at the end of 2 hours, what is the infiltration, right? Infiltration, directly I am doing it. Infiltration at the end of 2 hours. If infiltration is being asked, integral 0 to t f of t dt, right? So that is integral 0 to 2. What is f of t? Fc plus FO minus FC to e to the power of minus KT. FO is 7.62 and FC is 1.34, right? So 1.34 plus 7.62 minus 1.34 e power minus KT. K value is also given to you. So just substitute 1.34, 2 minus 0 plus what is this value? 12 minus 4, 8, 5 minus 3, 2, 7 minus 1, 6, 6.28 e power minus KT upon minus K and 0 to 2. So just substitute everything. 2.68 minus 6.28 upon K value. K value is how much? 4.182. 4.182 e power minus 4.182 multiplied with 2 minus e power minus 4.182 multiplied with 0. So what is the answer you are getting? Infiltration quantity, what is the answer you are getting? 4.18. 4.18, whatever the quantity that is, mm or centimeters, centimeters. It is centimeters. Simple. Fine. Next. Next question. The infiltration of a soil follows a Horton's exponential model C1 plus C2 e power minus KT. During the experiment, the initial infiltration capacity was observed to be 200 mm per hour. After a long time, infiltration capacity was reduced to 25 mm per hour. If the infiltration capacity after 1 hour was 90 mm per hour, what is the value of the decay constant? Infiltration capacity after 1 hour is 90 mm per hour. What is the value of decay constant? Fluid mechanics and OCF. See, I am always like a person who likes to be in present. Fine, we'll discuss what we have to do at the end of hydrology. Once hydrology is completed in the evening, just before the completion, I'll ask you, I'll give you some time, then we'll discuss and we'll come back which subject to be done, because don't get deviated from now on what is tomorrow. Present, do what is present. This is a major mistake. What people do is, even for writing the examination, they will not be worried about writing the examination, they'll be worried about what to do after examination. Who cares what to do after examination? The idea is you have to perform well in the examination. The thing is, at that point of time, concentrate more on that problem, that thing, because after examination you can do whatever you want to do. Stop thinking about future, start doing present. Okay, just focus on present. This is a major thing, that the person who gets better rank is the one who is present right now at the situation. Write your examination properly. You have to think like, okay, I'll write my examination properly, then we'll think about the other things. Fine. So write really properly. If you write your, so that is one thing you have to train your brain. Right now we are discussing hydrology, let it be hydrology. At the end of the day, once hydrology is completed, then we'll think about what to do tomorrow. Okay. And try to tune your brain, because many students, the major problem with them is they'll be thinking like, after examination tomorrow what to do, let's discuss this question. There is no use. After examination, once examination is completed, there is no meaning of discussing it. There is really no meaning of discussing anything. Of course we do discuss problems, we provide key, so that there are many people who are anxious whether they know whether they have done right or not. That is the reason we provide key, that's it. And to challenge the things, we will provide key, but we are not at all worried about other things. We are not at all worried. You should not be worried. After examination, it is done. Your 1 year of hard work is done. It is finished. After examination, like India-Pakistan match, you can do anything before the exam, before the match or during the match. Once you lost match, you lost. That's it. It doesn't matter. You can just analyze the things where you went wrong, and you can correct it for the next game. Right? So figure it out now only. What is the answer for this? 0.99. Soumya is saying 0.99. What about the other people? Break will be given by 2 o'clock. 2:15 at that point of time I'll be giving you the break. Point 0.99. Prachi, I think she left. So how you are going to find this out? Ft equals to C1 plus C2 e power minus kT. What is C1? C1 is FF and C2 is Fi minus FF e to the power of minus kT. Ft, infiltration at any time t, right? So infiltration at any time t is something like this. Infiltration capacity was reduced to this much. If the infiltration capacity after 1 hour was, after 1 hour the infiltration capacity is how much? 90 mm per hour. So this is 90 after 1 hour. Final infiltration capacity was 25. Initial it is 200. 200 minus 25 e to the power of minus k. You have to find out the value of k. So 90 minus 25 equals to 200 minus 25 is 175 e to the power of minus k. So this is 65 equals to 175 e to the power of minus k, or e power k equals to 175 upon 65. So how you will be finding out k? K ln e. K ln e equals to, apply ln on both the sides, ln 175 upon 65. Log or ln, it doesn't matter. So ln 175 upon 65. That will be your answer. So what is the value of k you are getting? What is the value of k? 0.99. Fine, many people are saying 0.99. I'll keep it as 0.99 only. Don't write it as 1. He has asked to correct to 2 decimal places. So you have to write 0.99. During a 3-hour storm event, it was observed that all abstractions other than infiltration are negligible. The rainfall was idealized as 3 1-hour storms of intensity 10 mm per hour, 20 mm per hour and 10 mm per hour respectively. And the infiltration was idealized as an Horton's equation 6.8 plus 8.7 e to the power of minus t. What is the effective rainfall? Effective rainfall means inertly what is the runoff he is asking. Please give me the answer. This is a 3-hour storm. Okay. During a 3-hour storm, it was observed that all the obstructions other than infiltration are negligible. The rainfall was idealized as 3 1-hour storms of intensity 10 mm per hour, 20 mm per hour, and 10 mm per hour respectively. And infiltration curve, infiltration was idealized as the Horton's equation. What is the effective rainfall, he is asking. Please give me the answer. What is the answer? Make it fast. What is the need of options? Tell me the value. You are asking, show me the options. Give me the answer. 12.1 plus value h. What is h? And Chaitanya is saying 10.9. 'Expect nahi pata'. Exact nahi pata, not H sir. It means hai. Okay, WhatsApp language. Oh, this is not WhatsApp. Anup Maurya sir, आपने और कौन सा subject complete किया है? Please tell. I think I have completed transportation steel. You can go through that. So there is a 3-hour storm. He is saying there is a 3-hour storm. There is a 3-hour storm of 10 mm per hour, 20 mm per hour, and 10 mm per hour. 10 mm per hour, 20 mm per hour, and 10 mm per hour. And once again it is 10 mm per hour. Fine. So this is 10 and this one is 20. There is 3 astrom. 1, 2, 3. Okay. Now the same rainfall intensity is also drawn here. Rainfall intensity is also drawn here, and infiltration rate is also drawn here only. Okay, infiltration rate, that also is being drawn here only. So he said 6.8 plus 8.7 e to the power of minus t. F of t equals to 6.8 plus 8.7 e to the power of minus t. That means k equals to 1, f equals to 6.8, fi minus ff equals to 8.7, fi minus ff equals to 8.7. So fi would be equals to 8.7 plus 6.8. So what is this value? 15.5, right? 15.5. So 15.5 means it would be somewhere here, and then it will keep on decreasing, something like this. This is 15.5. It will be keeping on decreasing somewhere like this, something like this, right? So this is ft. Now if you see, sir, why you are saying it cuts like this only? It can go like this also, you can say. It can go something like this also. So if you are having any doubt, just at t equals to 1, try to find out what is the value of ft. Ft would be equals to 6.8 plus 8.7 upon e. At t equals to 1, what is f of 1? What is this value? 6.8 plus 8.7 upon e. At t equals to 1, what is the value? At t equals to 0, you know, it is this one. At t equals to 1, what is the value? At t equals to 1, what is the value? 6.8 plus 8.7 upon e. What is the value? 10. So at t equals to 1, it is 10. At t equals to 1, it is 10. At t equals to 1, it is 10. And it is 15.5 here. So it tries to decrease something like this. And he is asking what? Effective rainfall. That means runoff. This value he is asking. So this whole thing will be infiltration quantity only. That whole thing will be infiltration quantity. And here if you want to find out infiltration quantity, you have to integrate it from 1 to 3. So the total infiltration would be equals to A1 plus integral 1 to 3 f of t dt. Right? A1 is how much? 10 multiplied with 1, right? So this is equals to 10 multiplied with 1 plus 1 to 3 f of t, 6.8 plus 8.7 times e to the power of minus t dt. So that is equals to 10 plus 6.8 multiplied with 3 minus 1 plus 8.7 upon minus 1 e to the power of minus 3 minus e to the power of 0. So what is this value? 10 plus 3 8s are 24, 2, this is 18, 20.4 minus 8.7, 1 by e cube minus 1. So what is this value? What is the amount of infiltration you are getting? I value. Please tell me the value of infiltration. What is the value of infiltration? What is the value of infiltration? What is the value of infiltration? Please tell me. Precipitation. Total precipitation value would be 10 multiplied with 1, 20 multiplied with 1 and 10 multiplied with 1. Right? So 10 multiplied with 1 plus 20 multiplied with 1 plus 10 multiplied with 1. So that equals to 10 plus 30, that equals to 40. So this is precipitation is 40 mm. And what is the infiltration you are getting? Infiltration value is 39.1 mm. 39.1 mm. So runoff would be equals to precipitation minus infiltration, 40 minus 39.1, that equals to 10.9 mm. And I don't know from where you got 12.1 mm, it is 10.9 mm. Is the option there? Option is not there. So I think there is some calculation mistakes. Please tell me what is the calculation mistake. This is e power minus 1. This is the calculation mistake. E power minus 1, not e power 0. This is the calculation mistake. So this is equals to 1 upon e cube minus 1 upon e. 1 to 3 we are integrating, not 0 to 3. So what is this value, I value? What is the I value? Please do the calculations properly. What is the I value? What is the I value? It is e to the power of minus 1, not e to the power of 0. What is the I value? Only 4 people are watching. What is the I value? 32.6 or 33.6. 33.6. Even then option is not there, I think. 40 minus 33.6. 33.6. Forty minus 33.6 is how much? 6.4. 6.4 mm. Option is not there. So this is 6.8 multiplied with 2, not 3. I am doing calculation mistakes. You don't do calculation mistakes. Yeah, 2 8s are 16, 13.6, 23.6 plus something. See, this is total rainfall. This is total infiltration. If you are not considering I value, then remove this. Then just do this. 20 plus 10, 30 minus this value. Anything would have been same. So what is this value? What is this value? 23.6 plus something. What is this? $26.8. At least now is it correct? What is this value? 26.8. 26.8. If I take 26.8, 40 minus 26.8, 40 minus 26.8, that would be equals to 13.2 mm. Option 13.2 is there. 13.63 is there. 13.2 is not there. I want to know what exactly is this value. Please tell me. What is this value? 26.37. 26.37. So if this is 26.37, then it is 3, 9 minus 3, 6, 13.63 mm. Option is there. 13.63 mm. So don't do calculation mistakes. Please don't do calculation mistakes. So the major calculation mistakes is 3 minus 1. E power minus 1, not e power 0. So 3 minus 1, 13.6. Fine. You'll get the answer perfectly. 26.37. 26.8 also it creates problem. Sometimes you have to be very much clear with the calculations. 13.63 mm. Fine. So any doubts in this? You can ask me. Any doubts? Any doubts? Can we move to the next question? I consider just shaded area and done, sir. Yeah, if you have considered just shaded area and if you do also, you have to get the same area, madam. It's like, you don't consider 10 here. You won't consider 10 here. Here also you won't consider 10. That's it. Don't consider 10 here. So that means this would be 16.37. 16.37 and this is how much? 30. This is 30. 13 minus 16.37. 13.63. Either way you can do that. Both the things you will get the same answer. That's it. Don't think that, sir, I have not considered this, I am getting this answer. No, that is wrong. This is how you will try to do it. Fine. Next question. The infiltration rate F in a basin under ponding condition is given by something like this. F is in mm per hour and T is time in hour. Total depth of infiltration during last 20 minutes of storm of a 30 minutes duration is. Total depth of infiltration during last 20 minutes of the storm for a 30 minutes duration storm. What is the total depth of infiltration in last 20 minutes? Please try to find out. What if direct integrate? If you direct integrate, what happens is you'll get this extra area. But there is no rainfall only. If there is no rainfall, there will not be that infiltration. You will get this infiltration also. If you totally integrate, what happens? You will get this quantity also. But rainfall itself is this much. Whatever the rainfall that is occurring, that is infiltrating. So there is no runoff. If rainfall is less, where come this value? This will be an extra value of no value, no meaning. Okay. So that means only this much amount of rainfall is occurring. So there will be this much amount of infiltration. If you totally integrate, you will get an extra value which is of no use. Okay. Prachi is saying 11.76. What about the other guys? What about the other guys? Please give me the answer. Why? What is your problem in this? The infiltration rate for a basin under ponding condition is given by what? Is given by F equals to? Is given by F equals to how much? 30 plus 30 plus 10 times e to the power of minus 2t. 30 plus 10 times e to the power of minus 2t. Next, the storm is lasting for a duration of how many minutes? Storm is for a duration of 30 minutes. So there is a storm that is for a duration of 30 minutes. In last 20 minutes he is asking what is the infiltration depth. That means in last 20 minutes, 10 minutes to 30 minutes, what is the infiltration depth? Fine. And he is saying what? Basin is in ponding condition. Ponding condition means there is a basin. Ponding condition means whatever the water that comes, it keeps on getting ponded. That is the meaning of it. Fine. So infiltration depth, if he is asking last 20 minutes, that means you have to integrate it from 10 to 30. In last 20 minutes he is asking. Fine. So that means you have to integrate it from 10 to 30. So infiltration equals to infiltration equals to integral 10 to 30 f of t dt. Integral 10 to 30 f of t dt. So 10 to 30 f of t is how much? 30 plus 10 times e to the power of minus 2t dt. So that equals to 30. F is in mm per hour. See the units. So last 20 minutes means this is 10 by 60, 30 by 60. Okay, per hour. Units are important. 30 by 60 minus 10 by 60 plus 10 upon minus 2 e to the power of minus 2 into 30 by 60 minus e to the power of minus 2 multiplied with 10 by 60. Fine. So this is equals to 30 multiplied with 1 by 2 minus 1 by 6 minus 5 multiplied with e to the power of minus 1, right, minus e to the power of minus 1 by 3. So what is this value? In mm. You'll get this in mm only. So what is the value? Units are important. 10 minutes. 10 minutes means 10 by 60 hours. 30 by 60 hours. What is the answer? .73, 11.74. Sir, limit hours में रख के k value mm per hour. What is that you are trying to say? I don't understand. Anyway, so what is the answer you are getting? 11.7 mm. Everyone got the same answer? 11.7? I don't know. Please tell me, is it the answer 11.7? Everyone, are they getting 11.7 or not? Please let me know. .76? Fine. So this is how you'll try to solve these type of questions. During a 6-hour storm, the rainfall intensity was 0.8 centimeters per hour on a catchment of area 8.6 kilometers square. The measured runoff volume during this period was 2,56,000 meter cube. The total rainfall that was lost due to infiltration, evaporation and precipitation in centimeters per hour. Very basic question. What is the answer? During a 6-hour storm, the rainfall intensity is given, runoff he has calculated, the total the everything lost due to infiltration, evaporation and transpiration. What is the answer? What is the answer? Please give me the answer. Make it fast. After that we have to discuss phi index, W index. Point 304. 0.304. So how you can calculate this? Rainfall intensity 0.8 centimeters per hour. So the total rainfall intensity is 0.8 centimeters per hour, and measured runoff volume during this period, 6-hour storm, right? So it is 6-hour storm. So total rainfall would be equals to 0.8 centimeters per hour multiplied with 6, 4.8 centimeters into 10 to the power of minus 2 multiplied with 8.6 kilometers square into 10 to the power of 6. That is meters. Runoff is equals to how much? 2,56,000 meter cube. 25600 meter cube. So the losses, that would be equals to P minus R upon T, 6 hours. So this minus this divided by 8.6, or you can write this 4.8 centimeters, 4.8 centimeters, and runoff would be 256,000 meter cube upon 8.6 into 10 to the power of 6 meters square multiplied with 10 square centimeters, right? So P minus R value how much you are getting? R value, what is the value? 256. 8.6 kilometers square. What is the value of R? I don't know. Tell me in terms of centimeters. So 256 upon 86. 256 upon 86. That would be somewhere around 3 point something. 3 6 are 18. 258, approximately 3 centimeters. 1.6, 1.8 upon 6, approximately 0.3 centimeters per hour. Is that what you are getting? Approximately 0.3. Option is B. Option is B. That's it. Simple. Fine. Now, with this is done. Now comes infiltration indices. Just I am asking you, you want to go for a break or you can sit for another half an hour? You want to go for a break, sit for another half an hour. After half an hour, we'll complete infiltration indices and then we'll go for a break. Is it okay with you? Is it okay with you if we complete infiltration indices and we go for a break? Is it okay with you? Yes, sir? Yeah, fine. Okay. Uh, okay. We'll try to see infiltration indices. So in infiltration indices, there are two things. Infiltration indices. So in infiltration indices, there are two things: phi index and W index, right? Phi index and W index. Phi index and W index, right? So phi index is the average infiltration rate above which rainfall volume is also considered as runoff volume. Average infiltration rate above which rainfall volume is considered as runoff volume, and here initial losses is not considered. Here initial losses is not considered, whereas here initial losses is considered. Initial losses, like interception losses is considered, and total time period is taken over here. So that means what exactly is the difference? What exactly is the difference would be, if you take any hydrograph. Let us say you are taking an hydrograph. Let us say you are taking an hydrograph. Fine. So if you are taking an hydrograph, rainfall intensity with respect to time. Rainfall intensity with respect to time. So phi index is the one. Phi index is the one. If I say this is the phi index is the average infiltration rate. Actually, Horton's equation is perfect example, but anyway, phi index will be using so that many problems can be solved in a easier way. So if this is the phi index, average infiltration rate, above which, if this is the rainfall, whatever this volume, above which the rainfall volume is called as runoff volume. Rainfall volume is called as runoff volume. Fine, all these things is runoff. Fine. So all these things you will be going to consider that as runoff. If you want to find out phi index, that would be if I take A1, A2, A3, A4, and let us say this is T1, T2, T3, T4, T5, and this is A5. So if you want to find out phi index, how will you calculate is, this is called period of effective rainfall. This is called period of effective rainfall. Period of effective rainfall, period of effective rainfall, or excess rainfall. Period of effective rainfall or excess, period of effective rainfall or excess rainfall. Okay, because during this period there is runoff. So what you can write is A1 plus A2 plus A3 plus A4 upon T1 plus T2 plus T3 plus T4. You will be considering only this period. W index, if you want to find out W index, then that would be equals to A1 plus A2 plus A3 plus A4 plus A5 whole thing upon T1 plus T2 plus T3 plus T4 plus T5. Okay, T1 in the sense, okay, don't get confused in a different way. Time period means I'll say this as T1, T2, T3, T4, T5, time periods. Okay, and this duration is called period of excess rainfall. Period of excess rainfall or effective rainfall. Fine, effective rainfall means there will be only runoff. There is something called effective rainfall hydrograph. If they say effective rainfall hydrograph, effective rainfall hydrograph, effective rainfall hydrograph, effective rainfall hydrograph means, sometimes we will be using this wording also, effective rainfall hydrograph. That exactly means that is developed from here. Total rainfall minus phi index, remove the phi index. That means you will be drawing only this. You will be drawing only this. So that means it would be something like this. So here, if I say this as rainfall intensity, and this is time, the area under this will give you runoff. Area under this will give you what? Runoff. Area under this will give you runoff. So out of the whole thing, if you remove the phi index separately, whatever that is left over here, that is called as effective rainfall hydrograph. Effective rainfall hydrograph will give you what? Area under effective rainfall hydrograph will give you runoff. This is called ERH, effective rainfall hydrograph. Hydrograph, not hydrograph. Effective rainfall hydrograph will give you runoff. Okay. So this is the idea. This is the idea that we generally see. So phi index, W index is what we'll be seeing. So if phi index is asked, this is how you'll try to find out. Generally, first we will assume phi index equals to W index. We will assume phi index equals to W index, or generally phi index is greater than or equal to W index. Okay, W index. And initially we assume first what you will try to do is assume phi index equals to W index, and then you'll solve the problem. Assume phi index equals to W index, and then you'll try to solve the questions. Fine. Then after that you'll repeat this step. Once again you'll repeat this step and you'll get your answers. Initially, first in the initial step, and then you'll keep on doing the problems. So how? Let me solve a problem, then we'll go for it. The rainfall on 5 successive days, of a catchment were measured as 3, 8, 12, 6, 2 centimeters. If the total runoff at the outlet from the catchment is 15 centimeters, the value of phi index is, what is the value of phi index is? So the rainfall for 5 consecutive days, 3, 8, 12, 6, 2. 5 consecutive days. So let us say initially 5 consecutive days, 1, 2, 3, 4, 5, 5 consecutive days. So it is 3 centimeters means 3 centimeters per day, 8 centimeters per day, 12 centimeters per day. Intensity will be for one day, it will be same. It is 6 centimeters per day, and it is 2 centimeters per day because only one day. Fine. So initially his runoff is given as how much? 15 centimeters. Runoff is 15 centimeters. R value is given to you as 15 centimeters. Fine. So initially the first step what you will be doing is phi index equals to P minus R upon T. You will take total time. That means phi equals to W, that equals to P minus R upon T. So what is the total precipitation? 3 plus 8 11 plus 12 23 plus 6 29 plus 3 31. Right? So this is 31 minus 15 upon 5. Right? Am I correct? 8, 20, 11, 31. 31 minus 15 upon 5. 5 days. So that will be equals to 16 upon 5. 16 upon 5. 3.2 centimeters per day. It is 3.2 centimeters per day. 5 days, right? 3.2 centimeters per day. So now draw the curve. So what you are getting this? You are getting it as 3.2 centimeters per day this will be your phi index now, right? So initial step, you write phi index equals to this much, phi index 3.2 centimeters per day. Centimeters or meters? 3.2 centimeters per day. Fine. So this is 3.2 centimeters per day. If you draw the curve, you will see like this. Now, so you'll neglect these values. You won't consider this. You won't consider this. This will be your period of effective rainfall. For the second iteration, this will be your period of effective rainfall. So how will you calculate? Now if you calculate phi index that equals precipitation. What is the precipitation now? 8 plus 12 plus 6. You will neglect this. You won't consider these two things. So 12 plus 6, 18. 18 plus 8, 26. Right? So 26 minus runoff upon effective time period is 3 hours, 3 days only. This 3 days only. You won't consider these two things. So 26 minus 15, that is 11 upon 3. 3.33. 33 is 9, 23.67 centimeters per day. And if you want this in mm per hour, 36.7, 1 day is 24 hours. So that is 36.7 upon mm per hour. So if you see, this is 3.67. So in the next iteration, if you see 3.2, and this is just above this, 3.67. 3.67 centimeters per day. Now once again you have to check. If you check, these 3 days is the effective time period only. Now there is no change. So this will be your final phi index. This will be your final phi index. Fine. So that's what I said. You have to repeat this step. First, you have to find out initial phi index. Initial phi index is calculated by taking phi equals to W, 3.2 centimeters per day. Next, so you have drawn the line 3.2 centimeters per day. Fine. Now you have to see what are the things that has to be removed. These two things has to be removed because the values is less than phi index. So this will go into the infiltration. Fine. Now you have to find out effective time period, effective rainfall. This is the time period of effective rainfall. So this is the time period of effective rainfall. So this is phi index. Now phi index is calculated during this period. 8 plus the rainfall minus runoff upon time period. You got some value. So the value is 3.67 centimeters per day. Once again draw this 3.67 centimeters per day. If you draw like this, now also the period of effective rainfall is the same thing. So you don't have to change. So your phi index is 3.67 centimeters per day. That is 36.7 upon 24. What is the value? 1.525 mm per hour. I don't know, whatever the value that you say. .525. Option is not there. Option is not there. See if there is any calculation mistakes. Okay. Any calculation mistakes is there? I hope there is no calculation mistakes. If at all there is any calculation mistake, try to correct it. Okay. This is how you'll try to solve these type of questions. Any doubts in this? Any doubts in this? Try to solve this question. Try to solve this question. The rainfalls during 3 successive 2-hour period are 0.5, 2.8, 1.6. The surface runoff resulting from this storm is 3.2 centimeters. What is the phi index value of this storm? What is the phi index value of this storm? Option is not there. It's okay. Leave that. Try to solve this question. So option, he is saying B. Chaitanya is saying B. What about the other people? I think you left for lunch. Prachi is saying C. Chaitanya is saying B. Prachi is saying C. See, first phi index should be equals to W index. I mean, based on that, calculate it. Next, cross check it. And it's always better to draw hydrograph. If you draw hydrograph, you'll get the answer. What is the answer, guys? So, the rainfall during 3 successive 2-hour period. Rainfall during 3 successive 2-hour periods is 0.5, 2.8, 1.6. 0.5, 2.8, 1.6. Rainfall is given. Rainfall intensity would be 0.5 upon 2, 2.8 upon 2, 1.6 upon 2. This is 2-hour periods, 3 consecutive 2-hour periods. This is time period. Why? Because he has given 0.5 centimeters. So you have to find out rainfall intensity. Rainfall intensity. Fine. So these are the points. Once if you have seen this, and the runoff resulting from this is 3.2 centimeters. Runoff resulting from this is 3.2 centimeters. Fine. So initially phi index, how will you calculate? Phi index equals to W index, that is P minus R upon T. What is P? 0.5 plus 2.8 plus 1.6. 1.6 plus 0.5. 2.1 plus 2.8, that is 4.9. 4.9 minus 3.2 upon 6. 4.9 minus 3.2 is 1.7 upon 6, approximately 0.260, 0.299. Fine. So this is what you'll get. 4.9, 2.8 plus 2.1, right? 2.8, 3.3, 4.9, 4.9 minus 3.2, 1.7 upon 6. That is 0.299 centimeters per hour. Centimeters per hour. So 0.299 centimeters per hour means the line would be somewhere here, right? Because this is 0.25 centimeters per hour. Now what is the effective duration of excess rainfall? Duration of effective rainfall would be this one. So now how will you calculate? That equals to 2.8 plus 1.6. The original phi index now would be equals to 2.8 plus 1.6. 2.8 plus 1.6, that is 4.4 minus 3.2 upon 4. Upon 4. Right? 4.4 minus 3.2 is 1.2 upon 4. That is 0.3 centimeters per hour. So 0.3 centimeters per hour, the value would be here only. So this is your final value. Now duration of effective rainfall does not change. So phi equals to 0.3 centimeters per hour. I don't know how you got 0.28. 0.3 centimeters per hour will be your phi. C, 0.3 centimeters per hour. I think Soumya went for lunch. It's okay. Today I have delayed. My mistake. 2:09 p.m. Okay. So it's always better to draw the hydrograph and get the answers. Next, a storm with 14 centimeters precipitation produces a direct runoff of 8 centimeters. The time distribution of the storm is shown in the table below. Time from the starting, incremental rainfall in centimeters is given to you. What is the value of phi index of this storm? What is the value of phi index of this storm? Okay. If you are here, why you are not giving the answers? Sleeping? Chaitanya, first we'll complete phi index. Once phi index is completed, we'll go for the lunch. After the lunch, we'll do hydrographs and flood routing. Why? I told you that I'll discuss that in the afternoon afternoon period, right? Solve this question. Try to solve this question. A storm with 14 centimeters precipitation produced a direct runoff of 8 centimeters. The time distribution of this storm is shown in the table below. 1, 2, 3, 4, 5, 6, 7. Incremental rainfall is given to you. What is the value of phi index of this storm? This might be after noon, but it would be after lunch. Okay? Now please solve this question. Please solve this question. Please solve this question. Incremental rainfall 1, 2, 2.8, 3.3, 2.5, 1.8, 0.6. You first solve these questions, then we'll go for that. Everything you have to go by step by step. Step by step. One, 2, 2.8, 3.3, 2.5. One point 8, 0.6. 2.5, 3.3, 2, 2.8, 2.5, 1.8, 0.6. So P is 14 centimeters, R is 8 centimeters. So first W would be equals to P minus R, or phi equals to W would be equals to P minus R upon T, 14 minus 8 upon 7, right? 7. So that would be equals to 6 upon 7. 6 upon 7. So 6 upon 7 means approximately it would be something like this. Yeah. It would be something like this. Now, if you want to find out phi index, what you will be doing is phi would be equals to 14 minus 6. Now precipitation is 14 minus 0.6 minus 8 upon 6 hours only. So that is equals to 14 minus 8, 6 minus 3, this is 5.4 upon 6. That equals to 0.9 centimeters per hour, right? Point 0.9 would be somewhere more than this, just somewhat more than this. Just somewhat more than this. This is your phi. So phi equals to 0.9 centimeters per hour. So directly, now also the effective, period of effective rainfall is this one only. So 0.9 centimeters per hour. Sir, इसमें shortcut कर सकते हैं कि whatever the way you want to do, you can solve it. Whatever the way if you are getting W index as something like this, phi index should be more than W index. The only option available is 0.9. So we can go from the options. You can go from the options. In engineering services, you can go from the options. In the gate, you have to solve. That would be better. You can do this. Fine. Next, try to solve this question. Try to solve this question. Fine. An isolated 4-hour storm occurred during a catchment is as follows. First hour, second hour, third hour, 4 hour. The phi index of the catchment is 10 mm per hour. The estimated runoff depth from the catchment due to the above storm. What is the estimated runoff depth from the catchment due to the above storm? Please solve it faster rate. Make it fast. If you are having any doubts or if you want me to repeat, let me know, I'll repeat it. Soumya is not giving answers. What happened to you? Aren't you comfortable with this concept? You haven't understood this concept, or what is the problem? If you want me to repeat, I'll repeat it. Let me know. First, you just have to find out W index, that is phi index equals to W index. Calculate that, draw the line and see which one can be eliminated. You can eliminate this. Fine. Once you can eliminate this, you have to see this is the rest of the time period where effective rainfall or runoff occurs. So that would be equals to something like this, 5.4 upon 6, 0.9 centimeters per hour. So that means for this time period, you will try to find out what is the infiltration rate. Okay. Now the question is directly given to you, isolated 4-hour storm. He is asking what is the runoff depth. Runoff depth. So phi would be equals to, so phi, if phi is 10 mm per hour, phi is 10 mm per hour means you can neglect these two things. You can neglect that two things. So phi would be equals to P minus R by T. You can say this, you can neglect this because this is less than 10. First hour 9 mm, intensity is 9 mm per hour. You can neglect that. You can neglect this. Directly by seeing the question, if you want to solve, you can neglect these two things. The rest of the amount is 40. So 40 minus R upon duration is 2 hours equals to 20. So R equals to, duration equals to 10. Phi is 10, right? Phi is 10. So R equals to 20 mm. Directly you can solve. Without much usage, you can solve this. Or sir, if you want to draw hydrograph, you can draw the hydrograph. If you want to draw hydrograph, you can draw the hydrograph. It goes something like this. In first R, rainfall is 9 mm. In second R, rainfall is 28, 12, 7. So this is 28, 12, 7. Okay, and this would be 10 mm per hour. Phi index is directly given to you, that is 10 mm per hour. 10 mm per hour. So this is where runoff occurs. This is the runoff. Because this will be infiltration, this will also be infiltration. He is asking what is this value. This is 28, this is 12. Everything is 1 hour only. First hour, second hour, third hour, fourth hour, everything is 1 hour only. So phi would be equals to P minus R upon 2. Phi is 10. Time is 2 hours. Okay. Time is 2 hours T. So precipitation is 40 minus R upon 2. So R would be equals to 20 mm. Runoff is 20 mm. Or you can take from here 28 minus 10, this is 18. 12 minus 10, that is 2. So 18 multiplied with 1, 2 multiplied with 1, 20. You lose signals? Okay, fine. Yeah. Fine. So this is one of the thing. Next point. Next question. Try to solve this question. Storm 1 duration of 5 hours. Storm 1 of duration 5 hours gives a direct runoff of 4 centimeters and has an average intensity of 2 centimeters per hour. Storm 2 of 8 hours duration gives a runoff of 8.4 centimeters. Assuming phi index is same for both the storms, what is the value of phi index and intensity of storm 2 in centimeters per hour? Please give me the answer. Make it fast. There are two storms, different durations and different runoffs. Sir, now please skip this. No, I won't skip. You have to solve this. In 8 minutes, we'll complete the problem. We'll take break by 2:30, and then after the break, we'll start our hydrograph and routings concepts. You have to be patient, Chaitanya. Don't be in a hurry. For learning the concepts, applying the concepts, you have to be very much patient. Eight minutes time, solve it at faster rate. Storm 2 की intensity given नहीं है. You have to find out. Intensity of storm 2 you have to find out. That is asked in the question. This is common data question. Make it fast. Storm 1 of duration 5 hours. There is a storm 1 of duration 5 hours. Right? So there is a storm 1 of duration 5 hours. storm 1 of duration 5 hours gives a direct runoff of 4 centimeters and has an average intensity of 2 centimeters per hour. So he is saying there is an average intensity of 2 centimeters per hour. 2 centimeters, 2 centimeters, 2 centimeters, 2 centimeters, 2 centimeters. 1, 2, 3, 4, 5. 5 hours. So average intensity of 2 centimeters per hour. And what is the runoff value? Runoff is 4 centimeters. So runoff equals to 4 centimeters, whereas rainfall intensity would be 2 multiplied with 5, 10 centimeters. Then what is the value of 5? 5 would be equals to 10 minus 4 upon 5. That equals to 6 upon 5, 1.2 centimeters per hour. That would be phi index. Phi index equals to 1.2 centimeters per hour. Fine, well and good. Option is there. 1.2 centimeters per hour it is there. Storm 2 duration is 8 hours. Storm 2 duration is 8 hours. Duration is 8 hours. R value. R value is how much? 8.4 centimeters. And phi value, he said assume phi value is same for both the cases, that is 1.2 centimeters per hour. He is asking what is intensity of rainfall. For that, first find out what is the value of P. Phi equals to P minus R by T. So that is 1.2 times 8 equals to P minus R. P equals to 9.6 plus 8.4, 18 centimeters. And intensity, if you want to find out, P upon T, that is 18 upon 8, 9 by 4, 4 2's 8, 2.25 centimeters per hour. Intensity is 2.25 centimeters per hour. What is bigger issue in this? A and D, simple, that's it. A and D. Try to solve this question. During a storm event in a certain period, the rainfall intensity is 3.5 centimeters per hour and phi index is 1.5 centimeters per hour. The intensity of effective rainfall for this period is. Intensity of effective rainfall. He is asking what is the intensity of effective rainfall for this period. So during a storm event, rainfall intensity is 3.5, phi index is 1.5 centimeters. The intensity of effective rainfall. What is the intensity of effective rainfall? What is the intensity of effective rainfall? What is the intensity of effective rainfall? Prachi has given 2. What about the other people? Centimeters per hour. So intensity of effective rainfall he is asking. Intensity of effective rainfall means indirectly that is what? Indirectly what he is asking? Phi equals to P minus R by T. Okay, fine. Intensity effective rainfall means indirectly that is equals to runoff. Effective rainfall equals to runoff. Fine. Intensity means intensity would be intensity equals to runoff by time period, right? Since time period is not mentioned, assume T equals to 1. Assume T equals to 1. So phi value is 1.5 and then period P is 3.5. 1.5 equals to 3.5 minus R upon 1. So R equals to 2 centimeters. So intensity would be 2 centimeters by 1 hour, that is 2 centimeters per hour. Effective rainfall intensity is 2 centimeters per hour. Simple. Next question is something like this. The hydrograph of a storm event of duration 140 minutes is shown in the figure. Hydrograph for a duration of 140 minutes is shown in the figure. This is the hydrograph. The infiltration capacity at the start of this event is 17 mm per hour, which linearly decreases to 10 mm per hour. Okay, which linearly decreases to 10 mm per hour after 40 minutes. As the event progresses, the infiltration rate further drops down linearly to attain a value of 4 mm per hour at T equals to 100 units and remains constant thereafter till the end of the storm event. The value of infiltration index is. So what is the value of infiltration index? This is the thing that is given to you. He is asking what is the value of infiltration index. Please try to find out the value of infiltration index. Initially it is 17. It falls and reaches up to 100 and reaches up to 4. After that it remains constant. Here it is 10. Okay. Here it is 10. After that it remains constant. It reaches up to 4. After that it remains constant. He is asking what is the value of infiltration index, phi. At T equals to 100 minutes, it would be 4 mm per hour. So he is asking what is the value of infiltration index. Please give me the answer. Chaitanya is saying 7.3. What about the other people? Chaitanya has given me the answer. What about the other people? He is asking what is the phi index. Phi index. So it is a mixture of question, mixture of Hartman's equation and this one question. So how exactly you are going to attempt this? If you want phi index, what do you want? If you want phi index, if you need phi index, P minus R by T, P minus R upon T. You need runoff. You need what? You need runoff, right? So if you want phi index, you need runoff. Generally you can say this is the duration of effective rainfall, right? Because only here runoff is coming up, right? Only here you are getting runoff. So idea is to find out the runoff. If you know the runoff, this rainfall minus runoff by time period will give you the phi index, right? So here Fi. This is the Horton's equation. Fi equals to 17 and F final it is equals to how much? 4 mm per hour. 4 mm per hour. Fine. So now what is the infiltration during the time period? During this time period, just try to find out the infiltration. 40 to 100. That would be enough. Rainfall minus infiltration will give you the runoff. Right? So 40 to 100. 40 to 100. You just have to integrate 40 upon 60 to 100 upon 60. Horton's equation would be how much? 4 plus 13 into e power minus kt. What is the value of k? Value of k, is it given to you? Fine. Anyway, so how you are going to find out k value at t equals to 40 minutes, right? At t equals to 40, f of t would be equals to 10. Ft equals to 10. So 10 equals to 4 plus 13 into e power minus k, 40 upon 60. From this you will get k value. Once you get the k value, substitute it over here. 14 plus e power minus kt. What is the value of infiltration? You can calculate the value of infiltration from here. I. Value of infiltration you can calculate from here. Once you know value of the infiltration, so runoff equals to P minus I. P minus I, and phi index equals to P minus I, P minus of P minus I upon T. P minus of P minus I upon T. Indirectly it is I upon T. So if you calculate this value and time period is how much? I upon time period is, this is the period of excess rainfall, so that would be equals to 60 minutes. 60 minutes, so that would be 1 hour. 60 upon 60, 1 hour. So what is this value you are getting? So k equals to 1.164. K equals to 1.164. And once you get the k value, what is the value of I you are getting? What is the value of I? What is the value of I? What is the value of I? I you are getting 7. I you are getting 7. What is the value of I you are getting? What is the value of I? I you are getting 7.01. So this is 7.01. So 7.01 upon 1. Mm, or what is the value? This is mm only, right? So this is mm. 7.01 upon 1. So 7.01 mm per hour. Fine. This is how you will try to find this out. Okay. Fine. So with this, I am closing the session. Closing the session means we'll take a break. We'll take break for another 45 minutes to 1 hour. After that we'll meet and as Chaitanya wants, we'll discuss runoff, hydrographs, flood routing, and then stream flow measurement. Okay, thank you. Hi friends, welcome back. Now it's over 50 minutes. Chaitanya, I think you are even more tensed party than Prachi. Obviously, yaar, break the 1 hour lenge na. We'll take break for 1 hour, right? See, when you are reading for 8 to 9 hours continuously, obviously 2 hours will be gone for break, 1.5 hours to 2 hours. Read in a simplest way, cool way. What is the urgency or emergency? Like a span, like if you're reading for 10 to 15 hours a day, let us say if you're reading for 10 to 12 hours of a day also, the major thing is taking breaks in between is very much important. Why, sir? Why breaks are important? Continuously I'll read for 5 hours, 6 hours, something like that. That is not effective reading. Everything will not go into your brain. Don't stress yourself. You have to take a break, clear it off, change your mind into something, then come back and once again read. It's not told by me. It's something like, people like Bill Gates, who achieved a lot, has told that. uh, like, what he said is, initially they used to work like, whole night for 6 hours, 8 hours. They'll get everything onto the desk and they'll keep on working, and when they see the final product, it won't be that much effective. And um, they were like, okay, you have to work effectively. Like, whatever, if you're giving 2 hours, you have to be totally giving 2 hours for this, and your brain should be constantly working on this, and after that you have to take a break. Brain has to work on something else, then work. If you do that, automatically the results were very much good. So taking a break and taking thinking something other than studies and then coming back to it will help you a lot. Obviously you have to be very much smart. You should not pressurize yourself always. That is just my suggestion, not a thing that you have to follow, okay? It's become a habit. No, I'm not saying tensed in the sense you're like in a hurry that, sir, read this, read that. So you have to eat properly, be cool, and then once again we have to start the study. That's how things goes. Fine. So except for Chaitanya, any other people who are there? Prachi, Soumya, that guy from Meghalaya, Robertino, are you there? Anyone else is there? Made myself like a robot. You're not a robot. You're a handsome guy, a handsome, beautiful guy who is having a emotions like human being. You're not a robot. Always remember, don't work like a robot. Be human. Always be human. Anyway, right now you're in full working mode and you want to do it. It's okay, but always make sure that you take care of yourself. Health is wealth. At the same time, mental stability is also important. Okay. So anyone else is there? Robotino said you are here. Chaitanya, Robotino, Karthik is there. What about the other two girls? You guys there? If you are there, please let me know. Sir, truly saying, my emotions are about to end. Since you are dead, your emotions will keep on continue. Anyway, you learn this. In future, not a big issue. Right now you're focusing on it. Chaitanya, Robotino, Karthik, we three are here. And who is the other person? And if people comes at the faster rate, we can start class. Yesterday and day before yesterday also I took half an hour break in the afternoon and 1 hour break in the afternoon and half an hour breaks in between. Yeah. Four people are there. If you people come, we can start hydrographs. क्लास कब स्टार्ट हुआ, कितना पढ़ा था? बहुत ज़्यादा पढ़ा प्राची. Everything is done, everything is completed. It's like I'm going to close the class right now. What are you doing this much amount of time? You have to be here, right? How much time you will eat? Huh? Can't you come early? Class is finished. See, class is finished. I'm leaving now. Okay? Okay guys, everyone will leave. Huh? This is not right, Prachi. So the next thing is hydrograph. Hydrograph. So hydrograph, hydrograph, when we try to draw hydrographs, hydrograph is the variation of discharge with respect to time. Variation of discharge or flow. Variation of discharge, discharge, that is in meter cube per second, generally discharge with respect to time. That is hydrograph. Hydrograph, variation of discharge with respect to time. That means from here we are going to find out a runoff. So there are two types of runoff. There will be direct runoff and there will be something called base flow. This is base flow. This is base flow and this would be direct runoff. Direct. This is direct runoff and this one is base flow. This is direct runoff and this one is base flow. Joby Prachi. And Soumya, are you there? You're not there? Is it possible to study by heart instead of brain? Oh, you're asking about the emotions. Wow, great. For education, you need brain, but for survival, you need heart. Without heart, you can't survive. So, I don't know whether Soumya is there or not, but anyway, it's already 1 hour. Okay, fine. So, let's start this. Hydrograph. For hydrograph, this is called as flood hydrograph. Flood hydrograph. Okay, this is called as flood hydrograph. Flood hydrograph. That means what happens? There is a land. There is a land, and for certain duration rainfall occurs. Let us say for 2 hours rainfall occurs. Once the rainfall occurs, there will be some amount of infiltration. There will be some amount of infiltration, and there will be some amount of runoff. Runoff. So this can be runoff. This is base flow. This can be said as direct runoff. This can be said as direct runoff, and this is said as base flow. This is said as base flow. And once, let us say, there can be a river or ocean here. There can be a river or ocean here. So this base flow and this direct runoff will go over there. Generally, the base flow will be a constant thing that will keep on going on, whereas direct runoff, because of the direct runoff, there can be generation of flood over here. Fine. So that is the flood hydrograph that we generally see. So this is a rising limb. This is called, AB is called as rising limb. AB is called as rising limb, and CD is called as falling limb. AB is called as rising limb, and CD is called as falling limb. And this is direct runoff. This is base flow. Fine. And rising limb, it depends upon two things. First one, it depends upon storm characteristics and catchment characteristics. It depends upon storm characteristics and catchment characteristics. Okay, that means if catchment, whether it is sandy soil, clay soil, if clay soil is there, runoff will be more. If sandy soil is there, runoff will be less. Whereas this is falling limb. Falling limb depends only upon catchment characteristics, because by that time rainfall will not be there. Rainfall will be for 2 hours, but this is base time. This can be for n number. This can be for very high minutes. Fine. This can be for very high amount of hour. Fine. These are called as points of inflection, and generally point C is the where you will get maximum storage. Point C is the where you will get maximum storage. Okay. So this is how you generally try to see. And TR is the duration of rainfall. TR equals to duration of rainfall. TR is given as duration of rainfall, and TL is the time lag. TL is the time lag. TL is the time lag, lag time or time lag. It is the distance or time difference between centroid of this duration, centroid of this one to centroid of this. The lag time, that is called as lag time. Lag time is the time difference between the centroid of the duration of rainfall to the centroid of the flood hydrograph. This whole thing is called as flood hydrograph. Okay. So the flood that is generated at any of the point. Fine. Initially it will keep on increasing. It reaches to the peak point. Once the rainfall is stopped, after some time the rainfall is stopped, it reaches to the peak point, and after that it keeps on falling and reaches to the minimum value. Fine. So this is base flow, where TB is called as base time. TB equals to base time. TB equals to base time, and this formula is applicable only if rainfall duration is more than time of concentration. Time of concentration. What is time of concentration? If I take any catchment area, if you are taking any catchment area, and let us say there is an outlet here, this is the farthest point. Time taken by the water to reach from the farthest point to the nearby outlet. Outlet means any drainage, everything. This is the catchment area. If you take this as the catchment area, time taken by the water from the farthest point to the nearby outlet is called as time of concentration. That is called as time of concentration. Time of concentration. Fine. And generally this is applicable. Only if time of rainfall is greater than or equal to time of concentration. Fine. Then only this curve, that is hydrograph curve, is applicable. Now from this, if you want to generate direct runoff hydrograph, if you have to generate, then it would be just flood hydrograph minus base flow. Flood hydrograph minus base flow will give you direct runoff hydrograph, DRH. Direct runoff hydrograph. This is TR. Fine. This is DRH. Direct runoff hydrograph. Direct runoff hydrograph. Direct runoff hydrograph. Fine. If let us say this is T, and this is time period, base time. Generally base time, this is time is generally will be in hours. Okay. And this Q will be in seconds. Fine. So direct runoff hydrograph with a uniform depth. If you want to find out what is the depth, that would be equals to volume upon area. So if you want to find out volume, indirectly you can take the area of the curve under this. Fine. So either you can take the area or you can multiply the coordinates. That equals to sigma q times t upon area. This is equals to sigma q times t upon area. Right? Sigma q times t upon area. Generally sigma q times t, if I take, q is in meter cube per second, t is in hours. Convert this into seconds. So this would be sigma q into t multiplied with 60. A is generally substitute in kilometer square, so that would be meter square, and this is 100 centimeters. So n would be equals to 0.36 sigma qt upon A. Here q you will substitute in meter cube per second, t you will substitute in area, and A you will substitute in kilometer square. So a flood hydrograph will create a direct runoff hydrograph of this much depth. N is the depth of the runoff. Fine. So direct runoff hydrograph would be equals to flood hydrograph minus base flow. Either you can take this or area under the curve. Area under DRH. Upon area of catchment area. Capital A is area of catchment. area of catchment, area of catchment in kilometer square. So direct runoff depth would be equals to generally 0.36 sigma qt upon a in terms of centimeters. Fine, you will substitute q in meter cube per second, t you will substitute in hours, and a you will substitute in kilometers. From here you can get what is the runoff depth. So a rainfall of this much duration will create a direct runoff of this much. Fine, so this is direct runoff hydrograph. Now once this is the direct runoff hydrograph, from this if you have to generate unit hydrograph, unit hydrograph is a hydrograph with a runoff depth of with runoff depth of 1 centimeters, with one runoff depth of n equals to 1 centimeters, with runoff depth of n equals to 1 centimeters. That means the direct runoff, in order to convert direct runoff hydrograph to unit hydrograph, what you have to do is you have to divide all the coordinates by n. If you divide all the coordinates by n, then n by n, that means you will be dividing everything by n upon n. So direct runoff would be 1 centimeter. Fine, so you have to divide everything by n. Let us say the duration of rainfall can be given as something like this: d hours. If I take duration of rainfall, same anyway, I'll take this as tr only, and then the direction unit hydrograph is obtained by dividing the direct runoff hydrograph. The ordinates can be obtained by dividing direct runoff hydrograph upon n. Fine, this would be the discharge, and this is duration of rainfall, tr is the duration of rainfall, and this is the time, base time. So n equals to sigma qt upon a, that equals to 1 centimeter. So if at all they are saying unit hydrograph, that means n equals to 1 centimeter. Fine, so this is the property of the unit hydrograph. Generally unit hydrograph, the major properties of unit hydrograph is time invariance and linear response. Time invariance. If I say that as 2-hour unit hydrograph, suppose if I am saying 2-hour unit hydrograph, that means duration of rainfall is 2 hours. Tr equals to 2 hours. Duration of rainfall is 2 hours. And if I say 2-hour unit hydrograph, whether the 2 hours occurs in the morning, the rainfall occurs in the morning, or it occurs in the afternoon, or occurs in the evening, or any time period, we don't care. For whatever the time period it is, we will be using same hydrograph. This is one of the assumption. The assumption of hydrograph would be, first one is time invariance. That means whatever the time it is, whatever the time the rainfall occurs, the unit hydrograph will not change. We will be using that 2-hour unit hydrograph only. If it is occurring in the morning, afternoon, any time in the day, if they are saying 2-hour unit rainfall duration is 2 hours, then we will use 2-hour unit hydrograph for our analysis. That means for a catchment area, the unit hydrograph will be there in the field. That means in the booklet you will be having that. Based on that, you will try to calculate the flood. How? That is from linear response. Linear response. Fine. So that means from here you will try to generate from unit hydrograph multiplied with n will give you direct runoff hydrograph. Direct runoff hydrograph plus base flow will give you flood hydrograph. Right? Very basic thing. Unit hydrograph multiplied with n will give you direct runoff hydrograph. Direct runoff hydrograph plus base flow will give you flood hydrograph. So if you have one hydrograph, you can generate n number of hydrographs. You can generate n number of hydrographs. You can generate direct runoff hydrograph. You can generate flood hydrographs. Anything that you want to generate, you can generate from here. Okay, so let's keep up to here. Any doubts up to here, you can ask me. I will try. If you want me to repeat also, I'll repeat. Any doubts up to here? Of course, it's not joke, Chaitanya, but anyway, sir, which will affect more, peak of flood hydrograph or intensity of rainfall? Uh, can you be more precise in your question? Peak of flood hydrograph or intensity of rainfall means, if intensity of rainfall is more, the peak of flood hydrograph will change, obviously. Confusion in base time. This is the base time. What is your confusion in base time? See, just don't think that duration of rainfall should be equals to base time. No, it is not like that. Your rainfall has occurred for 2 hours. 2 hours your rainfall has occurred. Okay? After that what happens is, from all the catchment area, if let us say rainfall has occurred here, rainfall will be occurring at different places, and all the things, it has to go slowly, it will take its time, and then it will reach the outlet. That means, let us say if rainfall is occurring for 2 hours, but after 2 hours also you will see drainage on your streets, right? That means for 2 days you will see drainage on your streets. That means runoff will be constantly going on. So base time is different. Base time means this is the time period during which runoff keeps on occurring. Runoff keeps on occurring, okay? Runoff keeps on occurring. That is the idea. Fine. So don't think that TR should be equals to TB. Rainfall is occurring for 2 hours, but runoff will occur for 2 days also. Both will occur at different point. That's what I am saying. Intensity will be occurring at different point. Peak will be occurring at different point. But if there is huge amount of rainfall, automatically peak will rise or peak will fall. If there is tsunami, that means intensity of rainfall is very high. At the same time, peak will also be very high. So you can't say which one will affect more. That is, the question is not good, first of all. But anyway, since you are asking, both the things will affect. Both the things will get affected. Fine. Next, concentration time. Concentration time समझ में नहीं आया. Fine. In your environmental engineering, you might have studied this. But anyway, concentration time. Time of concentration means, this is the catchment area, let us say. Catchment area. And see, suppose just take your street only. At the end of the street, there is drainage. Fine. Rainfall is occurring at different locations. There will be farthest point from the drainage. In your location, there will be farthest point from the drainage, right? From that point, water takes some time to travel to the drainage, right? So that time is called as time of concentration. Fine. That is called as time of concentration. Time taken by the water from the farthest point to the nearby outlet is called as time of concentration. Sir, which will affect more? Affect what? No. Tsunami will occur after occurring heavy rainfall in ocean. So peak of hydrograph is more dangerous. Can say that. So peak of hydro, okay, you are asking which will affect us more. How can you say that? Yeah, it depends upon an individual. Like an individual staying at the home, let us say he is staying at somewhere where he doesn't have a home, and if it can affect him a lot. It can affect him a lot. Because of rainfall, it can affect him a lot. And tsunami is the person who near to the ocean, he will be getting affected a lot. You can't correlate both the things. You can't correlate both the things. How can you correlate both the things? can you correlate both the things here? You can't correlate both the things. Which one will affect more? Which one will affect more means it depends upon the situations where you are. Sometimes rainfall will affect, sometimes flood will affect. So because of rainfall in the city, where people near to the ocean might get affected, because the water from city will be collected in the ocean or any nearby river or lake. They can get affected. So you can't say. If you're taking Delhi as an example, Delhi, and finally all the water goes and reaches to Yamuna, and from Yamuna, if suddenly there is huge amount of flood because of river in the Yamuna, it goes and reaches somewhere else, and that will affect some other people. So you can't say that. You should not say that. You can't correlate intensity with peak, yeah? Correlate in the sense which one will affect more. You can't say that. It is subjective in nature, not objective. Not objective in the sense you can't say this will occur, this. It is subjective. Depends upon the situation it occurs. Anyway, let's come back to this. Fine. So try to solve this problem. A direct runoff hydrograph due to an isolated storm with an effective rainfall of 2 centimeters was trapezoidal in shape as shown in the figure. The hydrograph corresponds to a catchment area of. What is the catchment area of the hydrograph he is asking? Just try to find that out. Yeah, peak is occurring after rainfall. Peak will not occur during rainfall. Peak will occur after rainfall only. So peak will occur after rainfall, and where that peak occurs, we don't know. That occurs in the nearby river, flood, ocean, something like that. No. Peak occurs after rainfall. It will not occur. That is called time lag. Time lag is difference between the center of the rainfall and center of the, this one, centroid of the hydrograph. So peak will occur after rainfall. It will not occur during rainfall. You can't differentiate means what? We are differentiating duration, we are differentiating intensity of rainfall, we are differentiating this one. What is that? Peak discharge. Be specific in your question is, sir, which will affect more, you asked, whether rainfall or peak discharge. I said it is subjective in nature. Rainfall, if a person living in the city and he doesn't have home, if there is huge amount of rainfall, it will affect him. A flood near the ocean will not affect him. Okay, and due to this rainfall, after some days there will be flood in the ocean that affects the nearby people. That will not affect the person sitting in the city. So you can't say which one will affect more. Yeah, why we are studying hydrographs? That is one of the good question. We are studying hydrographs majorly to find out to design the drainage systems. In the cities, to design the drainage systems, we are studying the hydrographs. To find out the peak discharge. I am saying it has to be collected in the lakes. It has to be collected by nearby drainage systems. So if you know peak discharge, for that discharge you will design the drainage systems. That is the reason we are studying hydrographs. What else do you think? Just for designing the drainage systems, we are studying the hydrographs. Where to provide the drainage, how much drainage you have to provide, what is the discharge that is going to occur. To find out the stream flow measurement, to find out the discharge, this is the one of the way to find out the discharge. इंडिया में किसी को हाइड्रोलॉजी नहीं आती, ड्रेनेज सिस्टम बहुत खराब है, hydrology आता है. Tomorrow you will become a public health engineer, and let us say you are posted in city Delhi. Take Delhi. Why other thing? Let's feel like you're going to take Delhi. So once you go to Delhi, what happens? You will be asked for the drainage system is bigger problem over there, huge problem over there. So you being asked to be designing it. Give a proposal. You'll do all the study and you'll give better proposals, but you're not going to construct it. You'll give that to a contractor, and the contracts and all those things, politics, everything will be involved in it. So if you expect 100% accuracy or 100% of efficiency, maximum efficiency that you can get from at the end, when you complete that project, you'll get 10% of efficiency. That's it. 90% of efficiency will be lost in different things, so you can't get that much amount of accuracy over there. Fine. So direct runoff hydrograph is given to you. So what is the catchment area? And effective rainfall is 2 centimeters. Effective rainfall means what? Runoff and effective rainfall both are same. Runoff equals to effective rainfall. Runoff equals to effective rainfall, right? Runoff equals to effective rainfall. So 2 centimeters equals to n equals to area under the curve. Area under the curve, area under the graph upon catchment area. Area under the graph upon catchment area. So what is area under the graph? This is trapezoidal. 4 plus 70 by 2 multiplied with 90. 4 plus 70 by 2. You have to substitute this in hours. It is in hours. This is 90 upon n equals to 2 centimeters. This is area. So area equals to 74 multiplied with 90 upon 4. What is the value you are getting? What is the B? You haven't seen the question. This is the question. I have done the answer also. If you haven't seen the question, 599.4. 599.4 kilometer square. Fine. So what he has given, a direct runoff hydrograph. This is a direct runoff hydrograph. Due to an isolated storm with an effective rainfall of 2 centimeters, was trapezoidal in shape. Sir, you have drawn some curve like this. It can be like a curve, or it can be a trapezoidal, it can be triangular, it can be anything. Fine. Corresponds, the hydrograph corresponds to a catchment area of how much? 599.4 kilometer square. You got, she's saying that she got 599.4. Anyway, area under the graph. Area under the graph is trapezoidal area. 4 plus 70 by 2 multiplied with 90. A plus B by 2 into B. So from that you will get the answer. So our next question. The direct runoff hydrograph. A direct runoff hydrograph of a storm. Direct runoff hydrograph of a storm obtained from a catchment is triangular in shape and has a base period of 80 hours and peak flow rate is 30 meter cube per second, and the catchment area is 86.4 kilometer square. The rainfall excess that has resulted the above hydrograph is the rainfall excess that has resulted the above hydrograph is rainfall excess that has resulted the above hydrograph is. What is the answer? Only 4 people are watching. Please do like, share, subscribe, and I don't know why. Every day in the afternoon session people will not be there. Morning session people will be there. In the afternoon session people will not be there. And I think Soumya also left. 10 centimeters. One person is saying 5 centimeters, other person is saying 10 centimeters. Why? One person is saying A, other person is saying C. Sorry, 5. Chaitanya is now saying 5. So he is saying that as a triangle with base period as 80 hours, it is in the shape of triangle, right? It is in the shape of triangle with base of 80 hours and peak with base of 80 hours and peak of how much? With base of 80 hours and peak of 30 meter cube per second. This is 30 meter cube per second and this is 80 hours. Fine. So what you can write from here, n would be equals to area under the curve. Half area under the curve would be equals to 80 multiplied with 30. See the units, if units are there, you can directly substitute it. I think I have done something wrong. Sorry. Multiply this with 0.36. Multiply this with 0.36. N equals to 0.36 multiplied with area under the graph. Area under the graph upon total area in kilometer square. Fine. You have to multiply this with 0.36. Sorry. Fine. So this is 0.36 multiplied with area under the graph, that is half multiplied with 80 multiplied with 30 upon total catchment area. What is the catchment area? 86.4 kilometer square. Substitute this in 86 kilometer square only. So what is the value of n you are getting? You just have to find out the area. What is the value of n you are getting? 5 centimeters. Whatever that you are saying, that is the value, 5 centimeters. Multiply that with 0.36. Okay. You have to multiply this with 0.36. Fine. So yeah, 5 centimeters. Next point, triangular direct runoff hydrograph due to a storm has base time 60 hours and peak flow 30 meter cube per second occurring at 20 hours from the start. If the catchment area is 300 kilometer square, what is the rainfall excess in the storm? What is the rainfall excess in the storm? Please give me the answer. What is the excess rainfall in the storm? Same type of question where base is 60 hours and peak flow is 30 meter cube per second. His catchment area is given as 300 kilometer square. What is the rainfall excess he is asking? What is the answer? What is the answer? What is the answer? So answer will remain same. Remain same. Concept will remain same. This is 60 and this is 30. 60 hours and this is 30. And catchment area is 300 kilometer square. This is 300 and this one is 60. 1.08 centimeters. Simple, right? N would be equals to 1.08 centimeters, 10.8 mm. 10.8 mm. Simple, yeah. Now let's see these type of questions here. Now we'll go from this concept. Now the question that is given to you is The total rainfall in a catchment of area 100 km square during a 6-hour storm is 19 centimeters. The surface runoff due to this storm computed from triangular direct runoff hydrograph is 1.8 into 10 to the power of 1 into 10 to the power of 8 meter cube. The phi index of this storm. What is the phi index of this storm, he is asking. What is the answer? What is the phi index of this storm? Please give me the answer. You might be knowing that, Chaitanya, but everyone is there. So first try to calculate this. I'll be taking that type of questions. No issues. Please be patient. Be patient. Okay. The total rainfall in a catchment of area 1000 km square during a 6-hour storm is 19 centimeters. Surface runoff due to this storm computed from triangular direct runoff hydrograph is, this surface runoff is given to you, and then rainfall is given to you. He is asking what is phi index. What is phi index? What is phi index? Patience is also very much required. 1.5. So how you are going to get this? Area of the catchment is given to you. Area of the catchment equals to 1000 km square. Area of catchment equals to 1000 km square, and then during a 6-hour storm precipitation is 9 centimeters. Precipitation equals to 9 centimeters. Duration equals to 6 hours. Duration of the storm equals to 6 hours. The surface runoff due to this storm computed from the triangular direct runoff hydrograph is, there is a from direct runoff hydrograph, he already calculated it, meter cube. So 1 into 10 to the power of 8 upon, this is 10 power 3 into 10 power 6 meter square, that is 10 to the power of 9 meters. 1 by 10 into 100 centimeters, that equals to 10 centimeters. And phi index would be equals to P minus R upon T, 19 minus 10 upon 6, 9 upon 6, that equals to 1.5 centimeters per hour. Simple. Okay. So 1.5 centimeters per hour is your answer. This is how you'll try to solve this type of questions. Next, the direct runoff hydrograph. The direct runoff hydrograph is a response to, the direct runoff hydrograph is a response to 5 centimeters rainfall excess in the catchment is shown in the figure, the area of the catchment. He's asking what is the area of the catchment for this one. Please try to find out what is the area of the catchment. This is the direct runoff hydrograph. The area of catchment expressed in hectares he is asking. Please try to find out. What is the area of catchment in hectares? Area of catchment in hectares. Only Chaitanya and Prachi is there. I think Soumya is not there. Fine. The direct runoff hydrograph is response to 5 centimeters rainfall excess is shown in the figure. The area of catchment is. What is the area of the catchment? .6. In hectares he is asking. In hectares he is asking what is the area of the catchment. So n equals to 5 centimeters. n equals to 5 centimeters he is saying. So n equals to 0.36 multiplied with area under the graph. Area under the graph would be equals to half multiplied with 6 multiplied with 1, half multiplied with 6 multiplied with 1 upon total area. So A would be equals to 0.36 multiplied with 3 upon 5. So this would be equals to 0.36 multiplied with 6, 0.6, 0.6. 36 multiplied with 6, 216 into 10 to the power of minus 3 kilometer square. That is 216 into 10 to the power of minus 3 into 10 to the power of 6 meter square. So 216 into 10 to the power of 3 meter square, 21.6 into 10 to the power of 4 meter square, that is 21.6 hectares. 21.6 hectares. Fine. So option is 21.6. He has asked that in hectares. So this is how you will try to calculate it. Next question. I think you will be able to solve this question. Try to solve this question. A 6-hour unit hydrograph of a catchment. A 6-hour unit hydrograph of a catchment. A 6-hour unit hydrograph of a catchment is triangular in shape with a total base time of 36 hours and peak discharge of 18 meter cube per second. The area of catchment is. The area of catchment is. Please show the question. I have solved the question. This is the question. This is the question. I have solved the question. What is the answer for this? Please let me know. Please let me know. 10 question. What 10 question? What is the answer, guys? I asked question number 12, what is the answer? What you people are talking, I don't know. Sir, my answer is not coming. Answer is B, 117. Here 6-hour unit hydrograph, right? See, sometimes that is the reason, since you will get confused, I have directly given to you. Once again I am saying, this is 6-hour unit hydrograph. For unit hydrograph, n equals to 1 centimeters and n is equals to 0.3 times sigma qt upon A. Sigma qt upon A, right? Sigma qt upon A, or 0.36 area under hydrograph. Area under unit hydrograph upon area A. Upon area A. upon area under unit hydrograph, that is A. Fine. So here this is equals to 0.36. Q you will be substituting in meter cube per second. T you will be substituting in that in hours. A you will be substituting in kilometer square. Now what is given to you? 0.36, time basis 36 hours, peak discharges 18. Area in catchment is being asked. So this is 0.36, time basis 36, and this is 18. 36 multiplied with 18 upon A in kilometer square unit. So A equals to 0.36 multiplied with 36 multiplied with 18. So what is this value you are getting? What is this value you are getting? What is the value you are getting? 117. Are you sure? 117 kilometer square. 117 kilometer square. Ninth question. What is wrong with the ninth question? This is time in hours. This is the ninth question. Fine. In the ninth question, n equals to area under the curve. Fine. I think I have solved this. N equals to 5 centimeters, that is 0.36. Half multiplied with time is 6 hours. Maximum peak discharge is 1. Since it there might be some printing mistake, it should be meter cube per second. Fine. So half multiplied with 6 multiplied with 1 upon area. Area you will get in kilometer square, convert that in hectares. That's it. You are in ninth. What do you want? Solve through units means which units you want me to solve? Which units you want me to solve? This is a basic way of doing it. Solve through units in the sense. Fine, that question is done. Okay, this is how it is solved. We'll leave it. This is quick thing and we are taking so much amount of time. And Prachi, I have not discussed 10th question. That doesn't mean I will not discuss. I will discuss. You have to wait. Fine. Anyway, so there is an isolated 3-hour rainfall event on a small catchment, produces a hydrograph peak and point of inflection on the falling limb of the hydrograph at 7 hours and 8.5 hours respectively after the start of rainfall. Assuming no losses and no base flow contribution, the time of concentration in the hours for this catchment is approximately. So he is asking what is the time of concentration, right? What happened, Ray? 4.62. What is 4.62? Direct is there. It is there, yeah. Ninth question directly it is there. Don't worry about it. We are in 10th question right now. Fine. Fine. You just get it cleared. You got stuck over there. What is wrong with the 9th question? Please be clear. What is wrong with the 9th question? Make it fast. What is wrong in the 9th question? N is given 5 centimeters. That is 0.36 area upon total area of catchment area. Catchment area is 21.6 hectares. What is wrong with it? What is wrong with this? Please do comment. Don't use calculators. You should not use scientific calculators. Fine. 10th question that is given to you is an isolated 3-hour hydrograph, 3-hour rainfall event on a small catchment produces a hydrograph peak. Peak of hydrograph and point of inflection. Produces a peak of hydrograph and point of inflection. Peak of hydrograph is formed at 7 hours. Peak is formed at 7 hours and point of inflection and rising limb, falling limb is formed at 8.5 hours. This is 8.5 and this is 7 hours and this is 3 hours. Fine. So duration of rainfall is 3 hours. Peak is something like this. Fine. And generally lag time is from the centroid of this to the peak value. From the centroid of this to the peak. Okay. QP. From the centroid of the peak to this. Fine. Concentration, time of concentration, I told you, time taken by the last particle to reach the outlet, right? So that means generally this will be taken as your time of concentration. Time taken by the particle, that means just after the rainfall to reach the outlet. This is point of inflection. This is point of inflection. Point of inflection. This is peak discharge. Fine. Peak discharge. So here you can directly calculate from here. TC would be equals to, from here to here it is 8.5. 8.5 minus 3. 8.5 minus 3, that equals to 5.5 hours. 5.5 hours. This is time of concentration. Time taken by the particles. Time taken by the farthest particle to reach the outlet. So this will be taken as TC. Fine. So generally I told you this flood hydrograph is applicable only if time of concentration is greater than or equal to time of rainfall. Is it the same thing I said? I said in the opposite way. Sorry. So this is applicable only if time of concentration is greater than or equal to duration of rainfall. Okay. So this is how you'll calculate. Sir, I don't know this. If you don't know this, for small hydrograph, TC is taken equal to TL. For small hydrographs, TC is taken equal to TL, lag time. What is TL here? Time period 7 minus half of this. This is 1.5, right? So 7 minus 1.5, that equals to 5.5 hours. This is how you'll try to solve these type of questions. Lag time is something like this and time of concentration would be something like this. Okay. Any doubts? Any doubts? Please show the question. An isolated 3-hour rainfall event on a small catchment. This is the question. Please see the question. Fine. So this is how you try to solve the questions. Which one of the following constitute the basic assumption of unit hydrograph? What are the assumptions in the unit hydrograph? Linear response and time invariance. Time invariance and linear response, right? So that means whatever the time the rainfall occurs, the hydrograph is applicable. So it is like, there will be time invariance and then there will be linear response. Time invariance and linear response. Fine. So your option, time invariance and linear response. Option is D. Okay. You don't want to solve ESC questions, you want to solve only GATE questions. Fine. Now this is a good question. Try to solve this question. An effective rainfall of 2 hours duration, produced a flood peak of 200 meter cube per second. The flood hydrograph has a base flow of 20 meter cube per second. If the spatial average rainfall in the watershed for a duration of the storm is 2 centimeters and the average loss rate is 0.4 centimeters per hour, the peak of 2-hour unit hydrograph is. He is asking what is the peak of 2-hour unit hydrograph. Peak hour unit hydrograph. Fine, we'll solve at the end, no issues. First solve this. An effective rainfall of 2-hour duration produce a flood hydrograph peak of 200 meter cube per second. The flood hydrograph has a base flow of 20 meter cube per second. Spatial average rainfall in the watershed for the duration of storm is 2 centimeters. Average loss rate is 0.4 centimeters per hour and peak of, what is the peak of 2-hour unit hydrograph? What is the peak of 2-hour unit hydrograph? Please try to solve it. What is the answer? 150, 150. Ragam Srikant said 150. Chaitanya, what happened? You're not there? Fine. So, what he is saying, an effective rainfall of 2 hour duration. Effective rainfall means there is some runoff over here. Fine. Created a peak flood. Created a peak flood hydrograph. Created a peak flood hydrograph. Or created a peak flood of 200. What he is saying, created a peak of 200. In a flood hydrograph, it created a peak of 200 meter cube per second. Meter cube per second, and duration of rainfall is how much? 2 hours. Fine. And there is a base flow. Base flow of how much? 20 meter cube per second. 20 meter cube per second. 20 meter cube per second. So if it is 20 meter cube per second, now the spatial average rainfall, whatever he said, the rainfall is 2 centimeters. During 2 hours, what is the rainfall? Rainfall is 2 centimeters and loss rate is 0.4 centimeter per hour. Loss means infiltration loss. 0.4 centimeters per hour is the infiltration loss. So precipitation is 2 centimeters and duration is 2 hours. Loss rate, that means indirectly phi index is 0.4 centimeter per hour. Then what is a runoff? P minus R upon T. So this is 0.4 equals to P minus R upon 2. 0.8 equals to 2 minus R. R equals to 1.2 centimeters. So it creates a runoff of 1.2 centimeters. Now you have to, from flood hydrograph, you need unit hydrograph. So in order to generate direct runoff hydrograph, what you have to do? You have to subtract base flow. Subtract base flow, you will get direct runoff hydrograph. If you subtract base flow, you will get direct runoff hydrograph. That's what I said. Just subtract base flow. That means 200 minus 20, 180. This is 180 meter cube per second. 180 meter cube per second. This is direct runoff hydrograph. Discharge with respect to time. Flood hydrograph minus base flow, direct runoff hydrograph. Direct runoff hydrograph divided by N. What is the value of N here? Runoff. N equals to 1.2 centimeters. Direct runoff hydrograph divided by N will give you what? Unit hydrograph. Will give you unit hydrograph. So that means this is equals to 180 upon N, 1.2. Unit hydrograph would be equals to direct runoff hydrograph upon N. So 180 upon 1.2, 180 upon 1.2 would be equals to 150 meter cube per second. So now you got how to convert, how to get unit hydrograph from flood hydrograph. If a flood hydrograph is given to you, subtract base flow, you'll get direct runoff hydrograph. Direct runoff hydrograph upon runoff will be giving you the unit hydrograph. Fine. Any doubts in this? Now is it clear? And how you got runoff? He has given loss, means indirectly infiltration loss is given to you. P minus R upon T. R equals to N equals to R equals to 1.2 centimeters. So now, if let us say, if 2-hour unit hydrograph is given, 2-hour unit hydrograph is given, he is asking you some 4-hour, or let us say D-hour unit hydrograph is given to you. He is asking T-hour unit hydrograph. T equals to some natural number into D. That means it can be 1, 2, 3, something like this. N is the natural number. Okay, natural number. If TR unit hydrograph is given to you, fine, DR unit hydrograph is given to you and TR unit hydrograph is being asked. Suppose if 3R unit hydrograph is given and they are asking some 6R unit hydrograph. From 3R unit hydrograph, they are asking 6R unit hydrograph. Then how you are going to do this? These type of questions is done like, if this is the unit hydrograph that is given to you, unit hydrograph would be something like this. Let us say, for example, not clearly, let us say this is 3R unit hydrograph. Three hours unit hydrograph. Fine. He is asking 6R unit hydrograph. 6R unit hydrograph. That means for this 3 hours, if you add another 3 hours, then you'll get 6 hours hydrograph, right? So what I'll be doing is I'll be adding another 3 hours to this. Another 3 hours. Another 3 hours. That means for first 3 hours, this is the hydrograph. For next 3 hours, I'll lag this by 3 hours and then I'll draw. I will lag by 3 hours and I'll add. Are you getting it? I'll be lagging it by 3 hours and I'll be adding it. Fine. I'll lag this by 3 hours. I'll lag this by 3 hours. Now I will add both the things. If I add both the things, what I'll get 6 hours fine. I'll be getting 6 hours direct, 6 hours hydrograph. I'll be getting 6 hours hydrograph. Okay, but here n value would be how much? For this n equals to 1, for this n equals to 1. If I add these two things, I'll get n equals to 2 centimeters. N equals to 2 centimeters. But you need unit hydrograph. If you want unit hydrograph, what you have to do? You have to divide the whole thing by 2. You have to divide this whole thing by 2. You have to divide this curve, this curve divided by 2. Divided by 2, you will get unit hydrograph. You will get unit hydrograph. This would be 6 hours unit hydrograph. This would be 6 hours unit hydrograph. 6 hours unit hydrograph. This would be 6 hours direct runoff hydrograph with n equals to 2. Why it is called direct runoff hydrograph? Because n is not 1 here, n is 2. Whereas here 6 hours unit hydrograph, that means n equals to 1. Because you have to divide this by 2. This drh by 2 will be giving you the unit hydrograph. So this is how you generate a 6R unit hydrograph from 3R unit hydrograph. So if a 3R unit hydrograph is given, they are asking 6R unit hydrograph, you are going to lag it by 3 hours. You just have to lag it by 3 hours and add everything. You'll get the answer. Fine. So this is how generally if a 3R unit hydrograph is given and 6R is asked, this is being done. Let us say if 3R is given, 9R is asked. 3R is given and 9R unit hydrograph is asked. Suppose in the question if 3R is given and 9R is being asked, then what you will do is, let us say this is 3R unit hydrograph, you will first lag it and then you lag it by another 3 hours. Are you getting it? 0, 3, 6. First you lag by 3 hours and then you lag by another 3 hours and you will add all these things. If you add all these curves, then you will get a direct runoff hydrograph. Direct runoff hydrograph with n equals to 3 centimeters. With n equals to 3 centimeters, because you are adding it 2 times. 3 hours, 3 hours, 3 hours. Fine. Now divide this by 3. If you divide this by 3, you will get direct runoff hydrograph something like this, whose peak is lesser than individual peak. This is unit hydrograph, 9-hour unit hydrograph, n equals to 1. This is 9-hour direct runoff hydrograph, n equals to 3. So you will lag, you will add, DRH will be generated, divide by something, you will get n equals to 1. This is how you will be getting, if a 3 hours unit hydrograph is given, 6 hours unit hydrograph is generated like this, 9-hour unit hydrograph is generated like that. Fine. So once if you know unit hydrograph, if you want DRH, direct runoff hydrograph, would be equals to n times unit hydrograph, and if you want flood hydrograph, that would be equals to direct runoff hydrograph plus base flow. Direct runoff hydrograph plus base flow. Fine. So now this is the question that is given to you. Based on this, solve this. The ordinates of a 2-hour unit hydrograph for a catchment are given as 0, 1, 2, 3, 4. The ordinate for 4-hour unit hydrograph of the catchment at the time of 3 hours would be. What is the ordinate of 4-hour unit hydrograph at the time of 3 hours would be? Please give me the answer. 4-hour unit hydrograph at a time of 3 hours would be. What is the answer? Please give me the answer. Fifteen, 18.5, 15, 15. 15, 18.5, 15, 15. Chaitanya has given 18.5. So here how you are going to solve this? 2 hours unit hydrograph is given to you. 2 hours unit hydrograph 0, 1, 2, 3, 4. Time is this much. Ordinates 0, 5, 12, 25, 41. 0, 5, 12, 25, 41. Still there is, it is not given over there. Now what he is asking? He is asking 4-hour unit hydrograph. 4-hour unit hydrograph. If 4-hour unit hydrograph is being asked, then what you have to do, by how much amount you have to delay? By how much amount you have to delay? So you have to delay this by 2 hours, right? Delay means you have to lag this by 2 hours, means you have to start your hydrograph from here. You have to lag by 2 hours, so you have to start your hydrograph from 2, 0, 5, 12, 25, 41. It will go something like this. Fine. So finally you'll get 4-hour DRH with n equals to 2. That means you'll add these two things. This is 0, 5 plus 0, 5, 12 plus 0, 12, 25 plus 5, 30, 41 plus 12, 53, and something like this is 25, this is 41. It will keep on going like that. Now 4 hours unit hydrograph. 4-hour unit hydrograph. 4-hour unit hydrograph would be, what you have to do? You have to divide this by 2. 0 by 2, 2. 5.5 by 2, 2.5. 12 by 2, 6. 30 by 2, 15. 53 by 2. 25 by 2. 41.2. Fine. So at time t equals to 3, what is the ordinate for 4-hour unit hydrograph? Option is 15. Option is 15. And I don't know why Chaitanya got 18.5. What is your doubt? You should not lag by 1 hour. You should lag by 2 hours. This is 2-hour unit hydrograph. That means first 2 hours rainfall will occur, and another 2 hours another rainfall will occur. You have to lag by 2 hours. Okay? That means initially and then you will lag by another 2 hours. First there is 2 hours rainfall, and once again there is 2 hours rainfall. That is the meaning of it. 2 hour, 2 hour. Fine. There will be 4 hours of rainfall. Chaitanya, is it clear now? Next question, the ordinates of 1-hour unit hydrograph at 60-minute interval are 0, 3, 12, 8, 6, 3 and 0 meter cube per second. A 2-hour storm of 4 centimeters excess rainfall occurred in the basin for 10 am. Considering constant base flow of 20 meter cube per second, the flow of the river at 1 pm is. The flow of the river at 1 pm is. What is the flow of the river at 1 pm? So the ordinates of 1-hour unit hydrograph are given as, for 60-minute interval, 0, 3, 12, 8, 6, 0. A 2-hour storm of 4 centimeters excess rainfall. 2-hour storm of 4 centimeters excess rainfall occurred in the basin from 10 am. From 10 am it has occurred. Considering constant base flow of 20 meter cube per second, the flow of the river at 1 pm. What is the flow of the river at 1 pm he is asking. Please try to solve it. 1-hour unit hydrograph is given to you. 1-hour unit hydrograph. 1-hour unit hydrograph at 60-minute interval. Like, time Q. 0, 60, 120, 180, 240, 360. Fine. 360, 0, 3, 12, 0, 3, 12, 8, 6, 3, 0, 8, 6, 3, 0, 380, 360 plus 60, 420 minutes. Fine, this is 1-hour unit hydrograph, and 2 hours storm with an excess rainfall of 4 centimeters. 2 hours storm with an excess rainfall of 4 centimeters. So 2 hours storm has occurred with excess rainfall, that means n equals to 4 centimeters starting from 10 am. Base flow is given as 20 meter cube per second. 20 meter cube per second. What is the Q value of flood hydrograph? Flood at 1 pm. At 1 pm. Please give me the answer. Prachi has given 40. Sandeep Kumar Gautam, what are you trying to say? Your message is retraced. Try to solve the question. Make it fast, guys. Prachi has given answer as 40. What about the other guys? Chaitanya is giving 60. Anyway, 60 minutes means 1 hour. So, I'll write this as 1 hour, 2 hour, 3, 4, 5, 6. Right? So, he is asking flood for a 2 hour rainfall with n equals to 4 centimeters and base flow of something like this. So, my idea is first to generate 2 hour flood hydrograph. Fine. I have to generate 2 hour flood hydrograph. For 2 hour flood hydrograph, first I have to generate 2 hour unit hydrograph. I have to generate 2 hour unit hydrograph. That means I have to lag this by how much? How many hours? Lag by 1 hour. 1 hour unit hydrograph is there. I have to generate 2 hour unit hydrograph, right? So I have to lag by 1 hour. 0, 3, 12, 8, 6, 3, 0. Fine. Let us say this is 7. Now this will give me 2 hour DRH with n equals to 2. 2 hour DRH with n equals to 2. 0, 3 plus 0, 3, 12 plus 3, 15, 12 plus 8, 20, 6 plus 8, 14, 3 plus 6, 9, 0 plus 3, 3, and this is 0. 2 hour direct runoff hydrograph with n equals to 2. And this is 2 hour unit hydrograph with n equals to 1. What would be the value? 0. This is 3 by 2. 1.5, 15 by 2, 7.5, 20 into 2, 20 by 2, 10, 14 by 2 7, 9 by 2 4.5, 3 upon 2 1.5, 0. So this is 2-hour unit hydrograph. Fine. Now if this is 2-hour unit hydrograph, what he is saying, it resulted in a rainfall with excess rainfall of n equals to 4 centimeters, right? So excess rainfall. So 2-hour unit hydrograph equals to how much you got? 0, 1.5, 7.5, 10, 0, 1.5, 7.5, 10, 7, 4.5, 1.5, 0, 7, 4.5, 1.5, 0. Time period, if I have to write, this is Q. Time, it started from 10 a.m. let us say 10 a.m., 11 a.m., 12 a.m., 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m. because he said it started from 10 a.m. Okay. Now it starts from 10 a.m. This is Q. Now 2-hour DRH with n equals to how much? 4 centimeters. That is being said in the question. So Q value would be 0 into 4, 0, 1.5 multiplied with 4. Anyway, you need only this value, right? At 1 p.m. what is the value? 10 into 4, 40. 1.5, 3 by 2 into 4, that is how much? 2, 6, 15 by 2, 30, 7, multiplied with 4, 28, 9 by 2, 18, 3 by 2, 6, this is 0. Fine. So this is the idea. This is 2-hour DRH with n equals to 40 centimeters and base flow. Base flow is given as 20, 20, 20, 20, 20, 20, 20, 20, 20. And finally flood hydrograph. Flood hydrograph would be 0 plus 20, 20, 6 plus 20, 26, 30 plus 20, 50, 40 plus 20, 60, 28 plus 20, 48, 18 plus 20, 38, 6 plus 20, 26, 0 plus 20, 20. Fine. So at 1 p.m. what is the flood hydrograph value? At 1 p.m. flood hydrograph would be 60 meter cube per second. Oh, okay, 12 p.m. Not a.m. 12 p.m. 12 p.m. Fine. So this is how you'll try to find out. Simple question. It just feels lengthy. At the same time, directly from here also you'll get n equals to 2. Just multiply with 2. You'll get n equals to 4. From here itself you'll get the answer. You don't have to do this step. From here itself you'll get the answer. Okay. N equals to 2. If you multiply this by 2, you'll get n equals to 4. Directly you'll get the answer. Fine. This is one of the problem. Any doubts in this? Any doubts in this? If you are not, any doubts? Next question. The drainage area of watershed is 50 kilometers square. Phi index is 0.5 centimeters per hour and base flow at the outlet is 10 meter cube per second. 10 meter cube per second this is. 1 hour unit hydrograph. 1 hour unit hydrograph. 1 hour unit hydrograph of the watershed is triangle in shape with a time of base 15 hours and peak coordinate occurs at 5 hours. Peak coordinate occurs at 5 hours. So he is asking what is the peak coordinate? Peak coordinate of the unit hydrograph. What is the peak coordinate of unit hydrograph? And first try to find out this. The drainage area of watershed is 50 kilometers square. Phi index is given to you. Drainage area of watershed is given to you. Base flow is 10 meter cube per second. 1 hour unit hydrograph of the watershed is triangular in shape with a time of base 5 hours and peak coordinate occurs at 5. Time of base 15 hours. Peak coordinate occurs at 5 hours. What is the peak coordinate value? What is the peak coordinate value? Prachi is saying B. What about the other guys? Only Prachi has given the answer. What about the other people? Sir, please solve. Oh, great. Drainage area is 50 kilometer square. A equals to 50 kilometer square. A equals to 50 kilometer square. If A equals to 50 kilometer square, phi index is 0.5 centimeters per hour. Phi index equals to 0.5 centimeters per hour. Fine. And base flow at the outlet is 10 meter cube per second. Great. So a 1 hour unit hydrograph, 1 hour unit hydrograph, 1 hour unit hydrograph is triangular in shape. 1 hour unit hydrograph is triangular in shape. 1 hour unit hydrograph is triangular in shape. Is triangular in shape with base period of 15 hours. With base period of 15 hours, and peak is occurring at 5 hours. Peak is occurring at 5 hours. Fine, let us say this is QP, peak. He is asking to find out peak. How will you calculate? Go from the basics. N equals to 0.36, area under the curve, half QP multiplied with T upon total area. N equals to 1 for hydrograph. That equals to 0.36, half multiplied with QP. Base time is 15 hours and area is given to you as 50 kilometers. So from this, QP equals to how much? 100 upon 0.36 multiplied with 15. What is the value? QP in meter cube per second. 18.52 you are getting. 18.52 meter cube per second. I don't know. Whatever she is saying, I am taking it. So, sir, why phi index is given, why base flow is given? Just to confuse you, nothing else. Any doubts? Any doubts? 18.52. Yeah, the answer is something around 18.52. I hope there is no calculation mistakes in this. In the same question, for a storm of depth 5.5 centimeters and duration of 1 hour, the peak ordinate of the hydrograph is flood hydrograph. So if there is a storm of depth 5.5 centimeters if there is a storm of depth 5.5 centimeters, what is the peak ordinate of the hydrograph? What is the peak ordinate of the hydrograph? Please give me the answer. If there is a storm of depth 5.5 centimeters, what is the peak? What is the peak ordinate of the hydrograph? Flood hydrograph. Indirectly, this is flood hydrograph. What is same question? In the same question, if there is a precipitation of 5.5 centimeters, what is the QP of flood hydrograph? QP of flood hydrograph. Please give me the answer. Prachi has given the answer. It is D. It is D. Other people, please solve. One zero 1.85. How you are going to find out? First, you need to find out runoff. Fine. So how you will calculate? Phi equals to P minus R upon T. T equals to 1 hour rainfall, right? So phi is how much given to you? Phi is given as 0.5, right? So 0.5 multiplied with 1 equals to P minus R. 0.5 equals to 5.5 minus R. R equals to 5 centimeters. That means N equals to 5 centimeters. So you know Q peak for unit hydrograph is 18.52. For unit hydrograph, Q peak is 18.52. And if you want for direct runoff hydrograph, what would be Q peak? That would be equals to 18.52 multiplied with N. That is 18.52 multiplied with 5. What is this value? I don't know. And for flood hydrograph, what would be Q peak? You just have to add plus 10 base flow. 18.52 06 2 2 4 92.60, and this is 102.60 meter cube per second. Why? You just have to add base flow, right? Direct runoff hydrograph, unit hydrograph multiplied by N plus base flow will give you flood hydrograph. Answer is 102.6. And why you are getting 101.85? I don't know. Don't do these type of mistakes. We'll go from the last. Fine, solve this question. A 1 hour triangular unit hydrograph of watershed. A 1 hour triangular unit hydrograph of a watershed has the peak discharge of 60 meter cube per second at 10 hours and time base of 30 hours. Phi index is 0.4 centimeter per hour. Base flow is 15 meter cube per second. What is the catchment area of watershed? And if there is a rainfall of 5.4 centimeters, the ordinate of flood hydrograph of 15th hour is. Please try to solve it. Why will you take 5.5 as depth of runoff? Depth of runoff is phi index is given. That is the reason. Don't do that type of mistakes. Anyway, try to solve this question. C 324. Next, what is the answer for next question? If there is a rainfall of 5.4 centimeters in 1 hour, the ordinate of flood hydrograph at 15th hour is, ordinate of flood hydrograph at 15th hour is 225, 240. Great. So this is a 1 hour triangular hydrograph, right? 1 hour triangular unit hydrograph. One hour triangular unit hydrograph. Base time of 30 hours. Peak is occurring at 10 hours. Peak is occurring at 10 hours. Peak is occurring at 10 hours. This is at 30, base is 30 hours. Right? Base flow is 30 hours. And what is the Q peak value? Q peak 60 meter cube per second. 60 meter cube per second. Fine. This is 1 hour unit hydrograph. 1 hour unit hydrograph. Fine. So if this is the case, now what he is asking, first question, catchment area of watershed. Catchment area of watershed. So n equals to 0.36 area under the curve. Area under the curve is half multiplied with 30 multiplied with 60 upon A. That equals to 1. So A equals to 30, 36 multiplied with 9, 9 6 are 54, 5, 324 kilometers square. So A equals to 324 kilometers square. Directly you got this. And he's saying the rainfall is 5.4 centimeters, phi index is 0.4 centimeters per hour. Rainfall is how much? 5.4 centimeters. That means P equals to 5.4 centimeters. P equals to 5.4 centimeters. Phi index equals to 0.4 centimeters per hour. So phi equals to P minus R upon T. So 0.4 equals to 5.4 minus R upon 1. So R equals to 5 centimeters. N equals to R equals to 5 centimeters. So if you are getting R equals to 5 centimeters, right? You got R equals to 5 centimeters. Then what he is asking at 15th hour, right? At 15th hour, for flood hydrograph, what is the value, right? For flood hydrograph, ordinate of flood hydrograph at 15th hour he is asking. How you can calculate this? Just take the slope, tan theta. This is 15 and this is 20. Tan theta equals to, this is 60, let us say this is y. Tan theta equals to 60 upon 20, 60 upon 20 equals to y upon 15. So this is 3, y equals to 45 meter cube per second. Fine. So that means this value is 45 meter cube per second. For unit hydrograph, So this is unit hydrograph. For unit hydrograph, P coordinate would be 45, and for direct runoff hydrograph, coordinate would be 45 multiplied with 5, that is 225, and for flood hydrograph it would be DRH plus base flow, that equals to 225 plus base flow is 15, that is 240 meter cube per second. Fine. Forgot to add base flow, so it is 240 meter cube per second. Option is B. Simple question. Next question. The ordinates of a 1 hour unit hydrograph at 1 hour intervals starting from t equals to 0. The catchment area represented by this unit hydrograph is how much? Ordinate of 3 hour hydrograph for a catchment area at t, for the catchment at t equals to 3 hours. For the catchment at t equals to 3 hours. For the catchment at t equals to 3 hours. Please give me the answer. What is B? Ragam Srikanth. 5.4. 5.4, 5.4. And what is the answer for next question in that? What is the answer for the next question? Ordinate of 3 hour hydrograph for a catchment of t equals to 3 hours. For 1 hour unit hydrograph, 1 hour unit hydrograph is given to you at 1 hour interval starting from t equals to 0. 0264210. 0264210. 4, 2, 1, 0. Time period 0, 1, 2, 3, 4, 5, 6. This is time, this is discharge. Fine. So n value, how you are going to find out n? N equals to, 0.36 sigma qt upon a. So 0.36, time period anyway is 1 for everything, so directly add 0 plus, add everything, 2 plus 6, 8, 12, 14, 15, right? So this would be simply 15 into 1 upon area. Area is what you have to calculate. So A would be equals to 5.4 kilometer square. So area equals to 5.4 kilometer square. Next, ordinate of 3-hour hydrograph for the catchment at t equals to 3 hours. Ordinate of 3-hour hydrograph for catchment at t equals to 3 hours. 3-hour unit hydrograph only here. Okay. So how you are going to find out? 3-hour unit hydrograph means you have to lag this by how much? You have to lag this by first 1 hour, 0, 2, 6, 4, 2, 1, 0, and lag by another 1 hour, 0, 2, 6, 4, 2, 1, 0. Now add everything, 3 hours DRH with n equals to 3. If you add everything, 0, 2, 8, 10 plus 12, 12, 10 plus 2, 12, 9, sorry not 9, 7, 3, 1, 0. And if you want 3-hour unit hydrograph, then divide this by 3. 0 by 3 is, this is 2 by 3, this is 8 by 3, 12 by 3, 12 by 3, 7 by 3, 3 by 3, 1 upon 3, 0 upon 3. So the peak value is 4. Peak value is 4, right? Peak value is 4 meter cube per second. If you lag, you should not lag directly by 3 hours. Anyway, this is this one only, right? Because this is 1 hour unit hydrograph, you can't lag directly by 3 hours. That is the idea, but anyway, sometimes you can do that also, not a big issue. Not a big issue. If you lag that by 3 hours, then you have to divide that by 2. If you lag that by 3 hours, you have to divide that by 2. Okay? Then you will get your answers. Anyway, this is the best way to do it. Lag 2 times, you will get the answer. Fine? So this is equals to 4. 6 option is not there. Please be cautious. Next question. A 4-hour unit hydrograph of a catchment is triangle in shape. A 4-hour unit hydrograph for a catchment is triangle in shape with base of 80 hours and catchment area of catchment is 720 kilometer square. The base flow and phi index is 30 meter cube per second and 1 mm per hour respectively. A storm of 4 centimeters occurs uniformly in 4 hours over the catchment. Peak discharge for 4-hour unit hydrograph. Peak flow discharge due to the storm. Try to find that out. See, I think this is fine, right? You're lagging it by 1 time, you're lagging it by another time. Add everything, you'll get 3-hour unit hydrograph. What is your doubt? I have already discussed 3 hours, 9 hours also I have discussed. Fine. So this is how you will be doing it. Don't get confused. Fine. This is how you will be doing it. We can't draw a graph in the examination. So this is a better way to do. lag by 1 hour, lag by another 1 hour. You will get 3-hour unit hydrograph. 3-hour hydrograph, and this is the thing. Next, solve this question. Twenty-eight, 210, 2750. So a 4-hour unit hydrograph of a catchment is triangular in shape with base period of 80 hours. Sir, why you are making us to do these many questions? Because questions are being asked a lot. That is the reason I am making you do all the questions. Okay? Don't think that it is waste of time. It is practice. 4-hour unit hydrograph of a catchment is triangular in shape with base of 80 hours. It's triangular in shape with base of 80 hours. The area of catchment is given to you, and a storm of 4 centimeters occurs uniformly in the 4 hours. With area of catchment is 720 kilometer square, right? So area of catchment is 720 kilometer square. Area of catchment is 720 kilometer square, and base period is 80 hours. And he is asking what is QP, right? Peak discharge. This is 4-hour unit hydrograph. 4-hour unit hydrograph. Fine. So n equals to 0.36 multiplied with half multiplied with QP multiplied with T upon A. So 0.36 multiplied with half multiplied with QP multiplied with 80 equals to 720. From this, what is the value of QP you are getting? It 972, right? And 8 is 72. 9. This is 9 into 2 into 100 upon 36. So QP equals to 50 meter cube per second. QP you are getting it as 50 meter cube per second. Option is B. And peak flood discharge due to the storm. What is the peak flood discharge he is asking? So for finding out peak flood discharge, first you should know runoff. Runoff equals to P minus 5 into T. What is the value of rainfall? Rainfall is 4 centimeters. 4 centimeters minus 5. Phi index is 1 mm per hour. That is 0.1 centimeters, and it is 4 hours. 4 minus 0.4, 3.6 centimeters. So for unit hydrograph, peak discharge is how much? 50. For unit hydrograph, peak discharge is 50, and for direct runoff hydrograph, peak discharge would be 50 multiplied with 3.6, and for flood hydrograph it would be 50 multiplied with 3.6 plus base flow. What is the base flow given to you? 30. 30. So this is how much? 36 into 5. 30, 210 plus 30. That equals to 240. You are not adding base flow all the time, so please be cautious. 240. Net khatam ho gaya. Then use somebody hotspot. It is not 210, it is 240. It is 240. It is 240, guys. It is 240, not 210. Hmm? Any calculation mistakes here? 36 into 5, 5 6 are 30, sorry, this is 180. Fine, I did calculation mistakes. 180 plus 30, 210. Okay, sorry, 210. Fine, this is one of the point. Anyway, you'll be able to do that. Try to solve this question. An average rainfall of 16 centimeters, an average rainfall of 16 centimeters, an average rainfall of 16 centimeters occurs over a catchment during a period of 12 hours with an uniform intensity. The unit hydrograph for a duration of 6 hours of the catchment rises linearly from 0 to 30 qmex in 6 hours and falls linearly from 30 to 0 in next 12 hours. Phi index is known to be 0.5 centimeters. Base flow is 5 meter cube per second. Peak discharge of resulting direct runoff hydrograph shall be. First try to find out this. Peak discharge of resulting direct runoff hydrograph shall be. Now, first complete hydrograph. After hydrograph, I'll be taking the break. Then we'll do flood routing. Still, I have not discussed S-curve. S-curve is the only concept that is left over here. Once that is completed, we'll take a break. What is the answer? Make it fast. What is the answer? (230). Peak discharge of direct runoff hydrograph is 230. Fine. An average rainfall of 16 centimeters occurs over a catchment during a period of 12 hours. During a period of 12 hours. Anyway, we have an unit hydrograph. We have an unit hydrograph. We have an 6 hours unit hydrograph which varies from 6-hour unit hydrograph of depth 1 centimeters, duration 6 hours, which linearly raises from 0 to 30 in 6 hours, 0 to 30 cumex in 6 hours, and it falls from 30 to 0 in next 12 hours. Next 12 hours. He said in next 12 hours. That means if this is 6, this is 18. Fine. This is 30. 6-hour unit hydrograph. This is 6 hours unit hydrograph. Fine. Well and good. This is 6 hours unit hydrograph. Phi index is given as 0.5 centimeters per hour. Phi index equals to 0.5 centimeters per hour. And what if you see average rainfall is occurring for 16 centimeters is occurring for how much number of hours? 12 hours, not 6 hours. So rainfall of 16 centimeters is occurring for a duration of 12 hours. Right? It is occurring for a duration of 12 hours. So that means you have to generate 12 hours direct runoff hydrograph. Fine. So that can be occurred by just adding another 6 hours. That means you have to lag this by 6. This is 24. This is 12. Okay. You just have to add. If you add everything, you'll get the answer. But anyway, if this is 30, what would be this value? This value, if this is 6, this is 12, this is 30, this would be 15. Right? Just by using something, you can get this value is 15. Okay. So that value will be 15. Anyway, if I have to write that 6-hour unit hydrograph, 6-hour unit hydrograph, time period 0, 6, 12, 18, Q value would be 0, 30, 15, 0. Now you have to lag by 6 hours. 0, 30, 15, 0. Then 12 hours direct runoff hydrograph with n equals to 2. That would be equals to 0, 30, 45, 15, 0. Fine. Next 12 hours direct runoff hydrograph. Direct runoff hydrograph with n equals to, n you have to calculate from here. Phi equals to P minus R upon T. 0.5 into 12 equals to 16 minus R. R equals to 16 minus 6. That equals to 10 centimeters. So n equals to 10 centimeters. Unit with n equals to 10 centimeters, just multiply this by 5. 0, this is 150, this is 5, 175, not 175, 235, 45, 0. Fine. So this is the thing, the peak value, peak discharges 235 cumex. Peak discharges 225 cumex. B. Okay. So you are getting 225 cumex. Why 230? Why 230? It is 225. How come it is 230? And area of catchment in hectares he has asked. Try to find out the area of catchment in hectares. It is 225 only, right? Why it is 230? Base flow is not given. Base flow. But he has asked what? Direct runoff hydrograph. See the question properly. Peak discharge of direct runoff hydrograph, not flood hydrograph. Not flood hydrograph. Peak discharge of direct runoff hydrograph. See the question properly. So don't get confused. If it is flood hydrograph or hydrograph, then you'll add base flow. If not, this one. Fine. And area of catchment in hectares. How will you calculate area of catchment in hectares? It is very simple. N equals to 0.36 multiplied with half multiplied with 30 multiplied with 18 upon A. That equals to 1. So A would be equals to 9. 3.6 into 3 multiplied with 9. 10.8 multiplied with 9. 9 8 is 797.2 kilometer square. This is the area. 97.2 kilometer square. Chaitanya, done? Any doubts? So 4 people are watching. Me, Prachi, Chaitanya, and I don't know the other person. I think Soumya left totally. Why? Why did you leave? Done? Any doubts in this? Okay. Next one. The ordinates U of a 2-hour unit hydrograph. The ordinates for a 2-hour unit hydrograph. 1 centimeters effective rainfall for a catchment are shown in the table. 6-hour storm occurs over the catchment such that effective intensity is 1 centimeter per hour for first 2 hours, 0 for next 2 hours, 0.5 centimeters for the last 2 hours. If the base flow constant is 5 meter cube per second, the peak flow due to this storm would be. Try to solve this. Try to understand the question and solve it. Peak flow due to this storm would be. What is the peak flow due to this storm? What is the peak flow due to this storm? Thank you for what? So you left. Great, yeah. So you said thank you and you left. Nice. Whoever that is present, please do comment and try to solve this question as soon as possible. Make it fast. Fast, 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 fast. Make it fast. not still Esker and the other things are left. Me. Okay, fine. What you mean by me, Prachi? You left. Oh. What is the answer? 87 cumex. Prachi has given 87 cumex as the answer. So, how you are going to solve this question? The ordinates U for a 2-hour unit hydrograph for catchment are shown below. Okay. So, 2-hour unit hydrograph, time period, discharge, it's up to 12, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is not good. I'll use this. This is also not good. I'll use this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Unit hydrograph 0 to 8, 0 to 8, 18, 32, 45, 32, 45, 30, 19, 12, 7, 3, 1, 0. 12, 7, 3, 1, 0. This is coordinates of 2-hour unit hydrograph. Now, what he is saying is, there is a storm of 6 hours. There is a storm of 6 hours. There is a storm of 6 hours. In first 2 hours, the effective rainfall means indirectly runoff is given to you directly. Effective rainfall intensity is 1 centimeter per hour. Effective rainfall intensity is 1 centimeter per hour. Fine. Okay. This is 1 centimeter per hour. In next 2 hours it is 0. Fine. Well and good. In next 2 hours it is 0. In last 2 hours it is 0.5 centimeters per hour. 0.5 centimeters per hour. This is 1 centimeters per hour. This is 0 centimeters per hour. This is 0.5 centimeters per hour. Last 2 hours, 2, 4, 6. That means runoff in this duration would be how much? 0.5 into 2. That equals to 1 centimeter. Runoff in this duration equals to 1 multiplied with 2, that is 2 centimeters. Runoff in this duration would be 0 multiplied with 2, that is 0 centimeters. Fine. So if this is 0 centimeters, now 1 hour, this is 2-hour unit hydrograph, and you have to generate 6-hour unit hydrograph. So you have to lag by every 2 hours, right? So the next lag, anyway, this is first hydrograph. Now, if you want DRH for this, in the first 2 hours, what is the rainfall intensity? That equals to 2 centimeters, right? So simply what you can do over here is, this is unit hydrograph, DRH with n equals to 2, 0, 4, 16, 36, 32 into 2, 64, 90, 60, 38, 24, 14, 6, 2, 0. This is one thing. Next, this is one thing. DRH n equals to 2. Fine. If DRH n equals to 2, it's something like this. Next, lag by 2 hours. This is the first lag. You are lagging this by 2 hours. 0, 2, 8, 18, 32, 45, 30, 19, 12, 7, 3, 1, 0. We are lagging that by 2 hours. In the next 2 hours, what is the DRH? Rainfall intensity is 0. So that means this is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. This is one thing. Next, in last 2 hours, you have to lag by another 2 hours, right? You have to lag by another 2 hours. That means you have to start from 4. That is 0, 2, 8, 18, 32, 45, 30, 19, 12, 7, 3, 1, 0. And for last DRH, n equals to 1. So multiply this by 1. 0, 2, 8, 18, 32, 45, 30, 19, 12, 7, 3, 1. This is how lag by 2 hours, and this is lag by 2 hours. This is first lag and that is second lag. Okay. So here for this one the rainfall intensity is 1 centimeters. For this one rainfall intensity is 0. For this one rainfall intensity or runoff intensity is 2. So finally DRH, final direct runoff hydrograph, would be how much? It is 0, 0, add these three things, sorry, add this 16, this is 4, okay, 36 plus 0, 36, 64 plus 0, 64, 90 plus 0 plus 2, 92, fine, you have to add 90 plus 0 plus 2, so just add first and last, 60 plus 8, 68, 38 plus 18, 56, 24 plus 32, 56, 14 plus 45, 59, 6 plus 30, 36, 2 plus 19, 21, and this is 12, 7, 3, 1. Okay, fine. So if this is DRH and any base flow given to you in the question, if constant base flow is 55 meter cube per second, 90 plus 2, 92, yeah. If base flow is 5 meter cube per second, then peak flood would be equals to DRH plus base flow. That equals to 90 plus 92 plus 5, that is 97 centimeters or mm, whatever that is. 97 meter cube per second, not centimeters, 97 meter cube per second. बहुत ज़्यादा live, हाँ जी, we have solved many problems. That is the reason I think I have not taken break also, but I have solved many problems in phi index and many problems in these things. Fine. Prachi got 87, I got 97. Is there anything wrong? Please cross check. I got 97. Anyone who has solved it, let me know what is the answer you are getting. Answer, I am getting 97 meter cube per second. No, you have to add something like this. Since here R is not uniform, effective rainfall runoff is not uniform, you'll be doing like for first one n equals to 2, for second one n equals to 0, for last one n equals to 1, 97. It's 97, okay? Mistake you have done, fine, well and good. Any doubts, guys? Any doubts? No doubts? Nice. Now comes something called S curve. Now comes something called S curve. Fine. So S curve. Why? What is the need of S curve? See, if a 2 hours unit hydrograph is given, you can find out 4 hours unit hydrograph. Okay. if a 2-hour unit hydrograph is given, how to find out 3-hour unit hydrograph? 3. That means if let us say d-hour unit hydrograph is given, t-hour unit hydrograph is asked, t-hour, t equals to m times d, where m is any rational number. Any rational number. If there is m is any rational number. Let us say m is any rational number. Then what is the method that we are going to use? So the method that we are going to use is S-curve method. What exactly is S-curve? What exactly is S-curve? So what exactly is S-curve is, if let us say d-hour unit hydrograph is given, then you lag this by d-hours, you'll constantly lag this by d-hour, and finally a curve will be formed. Finally a curve will be formed. By adding all these things, a curve will be formed. That curve is called as S-curve. That curve is called as S-curve. So it will remain constant, something like this. This curve is called as S-curve. So what you will be doing is, you will be, if d hours duration, you will be assuming that rainfall is occurring for infinite amount of time. Rainfall is occurring for infinite amount of time. D-hour unit hydrograph. You will keep on constantly adding it. D, 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 D. So finally the curve that you are going to obtain over here is S-curve. This is called as S-curve. So this is S-curve is the curve that is obtained. This is the maximum discharge, peak discharge. Fine. Q max I'll write. Q max I'll write. That can be obtained by lagging. That means for every d hours, you'll keep on lagging it. Lagging means adding it. That's it. You'll keep on adding for every d hours until a final constant value is being obtained. That is called as S-curve. Fine. And generally, if you see in a unit hydrograph, what is the effective rainfall intensity or runoff intensity? If they ask what is the runoff intensity, effective rainfall intensity or runoff intensity, if they ask, how will you say is, in a duration of d hours, for duration of d hours, what is the effective rainfall? Effective rainfall or runoff? Effective rainfall or runoff is 1 centimeters. Therefore, effective rainfall intensity or runoff intensity. Effective rainfall intensity or runoff intensity is generally given as 1 centimeters upon d hours. Right? It is generally given as 1 centimeters upon d hours. So effective rainfall intensity or runoff intensity is given as 1 centimeters upon d hours. So for this one also, runoff intensity equals to 1 centimeter upon d hours. 1 centimeter upon d hours. So the equilibrium discharge or maximum discharge, or which is also called as Q equilibrium discharge, if you want to get that, that can be obtained by runoff intensity multiplied with area. Runoff intensity multiplied with area. Runoff intensity is 1 centimeter upon d hours multiplied with area. Substitute that in kilometer square. So this will be generally 1 into 10 to the power of minus 2 multiplied with A into 10 to the power of 6 meter square upon D multiplied with 60 multiplied with 60 seconds. So this would be approximately 2.78 A upon D meter cube per second. Meter cube per second. This is maximum discharge or equilibrium discharge. If they ask for S curve, what is this maximum discharge or equilibrium discharge? This can also be obtained. Q max would be equals to limit t tends to infinity Q of t. Limit t tends to infinity Q of t. That would be your maximum discharge. It can also be calculated Q max, that is also called as Q equilibrium discharge, equals to 2.78 A upon D. 2.78 A upon D, where A you will be substituting in kilometer square, D is the rainfall duration. D is what? Rainfall duration, not base flow. This is rainfall duration. D is rainfall duration. Okay, so this is S curve, and the maximum discharge or equilibrium discharge in the S curve is calculated something like this. So for T tends to infinity, whatever the discharge you will be getting, that is the maximum discharge. T tends to infinity, you will keep on lagging and adding. Fine. Now suppose, so this is S curve. If you want to find out, I'll give you the procedure. If a DR unit hydrograph is given, you have to find out TR unit hydrograph, where T equals to M times D. First, what you will be doing is, you will be writing time period Q. For DR unit hydrograph, you'll write all those things, values. Fine. Then you'll try to find out S curve. You'll try to find out what is the S curve. By lagging everything, you'll try to find out S curve. Once if you find out S curve, you lag S curve. You lag S curve by T hours. T which you have to find out, you lag S curve by T hours. And difference between these two things would be delta Y. If I say this as some A, this is B, delta Y would be equals to A minus B or B minus A. And finally, if you want the ordinates of TR unit hydrograph, TR's unit hydrograph, if you want to ordinates, delta Y multiplied with D by T, multiplied with D by T, D by T. This is how, this is the procedure to find out TR unit hydrograph if a DR unit hydrograph is given. S curve you have to find out. Fine. S curve you have to find out. Suppose, just for an example, I'll take DR unit hydrograph is given as 0, 1, 2, 3, 4, 5, 6, 7. Fine. This is some 0, 10, 20, 30, 45, 25, 15, 0. Fine. Let us say this is some DR hydrograph, or I'll call this as some 2R hydrograph. You require 3R hydrograph. Fine. You have to generate S curve. For generating S curve, you have to lag this by n number of times, or you can do some simple basic concept called S curve addition. Something called, I'll give you S curve addition. S curve addition. So here what you will be doing is, you have to lag by 2 hours, this is 0. Fine. And add this 0 plus 20, or wait, this is 2, 4, 6, 8, 10, 12, 14. Just for your understanding, I am going from with small things. So 0, you have to lag by 2 hours. So this will be 0 plus 10, 10, 20 plus 10, 30, 30 plus 30, 60, 60 plus 45, 105, 105 plus 25, 130 plus 10, 145. Okay. Now this is S curve addition. Lag by 2 hours and add. This will be the addition. Now finally S curve, if you want, add these two things. 0, 10 plus 0, 10, 20 plus 10, 30, 30 plus 30, 60, 60 plus 45, 105, 105 plus 25, 130, 130 plus 15, 145, 145 plus 0, 145, and everything will be 145. This is the S curve that you will get. This is the S curve that you will be getting. Now you have to lag this by 3 hours. There is no 3 hours here. There is no coordinate of 3 hours. I'll say this 4 only. Okay, just for your understanding, I'm taking 4. For 3 also the procedure is same. We'll solve the problem, don't worry. So let us say you have to lag by 4 hours now. Lag by 4 hours. So that means you have to be starting from 0, 10, 30. You have to lag S curve by 4 hours. Start from 4. 0, 10, 30, 60, 105, 130, 145. Now difference between these two things. This is 0, 10, 30 minus 0, 30, 60 minus 10, 50, 105 minus 30, 75, 130 minus 60, 70, this is 30, and this is 15, this is nothing. Fine. Now if you want the coordinates, delta y multiplied with 2 by 4. That means you have to divide that by 2. 0 by 2, 0, 10 by 2, 5, 15, 25, 37.5, 35, 15, 7.5, and it would be 0. So this is how you'll try to get a new hydrograph. Anyway, here 0, 2 I have taken, that is the reason it came something like this. But if you want 3, I mean if 2 is given, if you want 3, based on the coordinates, you have to lag by 3 hours. That's it. Not a big issue. Fine. So this is how you will generate S-curve hydrograph. First, for S-curve addition, for S-curve addition, lag by 2 hours. If 2 hours is given, lag by 2 hours and start the addition. 0, 0 plus 10, 10, 10 plus 20, 30, 30 plus 30, 60, 60 plus 25. Write all these things and add these two things will give you S-curve. Lag S-curve by 4 hours. If you want 4 hours, you will be lagging by 4 hours. If you want 3 hours, you will be lagging by 3 hours. Difference between these two things, delta y multiplied with d by t, you will get the answer. Fine. So any doubts in this, you can ask me. Any doubts in this? Please go ahead and ask me. This is 4-hour unit hydrograph. This curve will become 4-hour unit hydrograph. 4-hour unit hydrograph. Which S curve you are talking? There is nothing. S curve will be for infinity number of hours. See, this is one way of statistics I am showing. If you want to lag, keep on lagging it. So that means first lag this, lag by 2 hours, next lag by 2 hours, next lag by 2 hours. After lagging by 2 hours, continuously if you add, you will get this answer only. You'll get this answer only. This is how you'll be doing this. Fine. Okay. So, try to solve a question. A S-curve hydrograph has been obtained for the catchments of 270 kilometers square from a 3-hour unit hydrograph. The equilibrium discharge for the S-curve is. What is the equilibrium discharge for the S-curve? S-curve hydrograph has been obtained for catchment of 270 kilometers square for a 3-hour unit hydrograph. What is the equilibrium discharge for S-curve? What is the answer? What is the equilibrium discharge for S-curve? Prachi left. Fine. Equilibrium discharge would be direct formula 2.78 A by D. So that is 2.78 multiplied with 270 by 3, 90, 27.8 multiplied with 9. So approximately 72, 7, 250. 250 meter cube per second. Okay. The 4R unit hydrograph 4R unit hydrograph for a catchment is given in the table below. 4R unit hydrograph for the catchment is given in the table below. What should be the maximum ordinate of S curve in meter cube per second derived from this hydrograph? What is the maximum ordinate of S curve derived from this hydrograph? This is 4R unit hydrograph. What is the maximum ordinate of S curve he is asking? Why we find this discharge? You are just trying to find what is the maximum discharge. That's it. Peak discharge. That will help you to find out the peak discharge. That's it. So this is a 4R unit hydrograph. He is asking what is the maximum S ordinate of S curve he is asking. What is the maximum ordinate of S curve, right? Equilibrium discharge for the S curve he is asking. What is the maximum ordinate of S curve derived from this hydrograph? What is the maximum ordinate of S curve derived from this hydrograph? $22. Oh, great. $22. How come it is 22? Now see this properly. Zero to 4, 0 to 24, right? 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Fine. 24, 22, 20, 18, 16, 14, 12, 10, 8, 6420. This is time, this is ordinates. What is the ordinates? 0, 0.6, 3.1, 10, 13, 9, 5, 2, 0.7, 0.3, 0.2, 0.10, 0.2, 0.10. Well and good, this is given to you. Now S-curve addition. S-curve addition. For S-curve addition, what you have to do, you have to lag by, this is 4-hour unit hydrograph, not 2-hour unit hydrograph. This is 4-hour unit hydrograph. You have to lag by 4 hours. That means you have to start from here. You have to start from here. If you are starting from here, there are two values, right? Here there are two values. So here what you have to do is, you have to take these two same way, 0.6. You will take 0.6. The next value would be 0 plus 3.1, that is this is 3.1, 10 plus 0.6, 10.6. Next that 3.1 plus 13, that would be, this is 16.1, this would be 19.6. 16.1 plus 5, 21.1, 19.6 plus 1, 21.6. 21.1 plus 7, 21.8, 21.6 plus 0.3, that is 21.9. And 21.8 plus 2, 21.8 plus 0.2, 22, and this one is also 22. This is how you will find out. Now finally S-curve. If you want to find out S-curve, how will you find out? This is 0, this is 0.6, and this one is 3.1, 10.6, 16.1, 19.6, 21.1, 21.6, 21.8, 21.9, 22, 22, 22, 22. So the maximum discharge would be 22. Maximum discharge would be 22. So that is the thing. He said 4-hour unit hydrograph. You have to delay by 4 hours. You have to start from 4 hours. And in that 4 hours also, the thing is, here there are two values. So you have to totally delay this. You should not add like that. You have to delay this. So 0.2, something like that, you have to add. Finally, you will get the S-curve like this. So the maximum value is 22. Fine. Any doubts in this? Any doubts in this? This is 22. Any doubts? Any doubts? Sir, what if they ask for 5-hour hydrograph? If they ask for 5-hour hydrograph, they will give those values. Don't worry. If they ask for 5-hour hydrograph, they will give 4, 5, 6. Then you have to delay that by 5. That's it. You have to lag S-curve by 5 hours. Okay. Next, try to solve this question. Try to solve this question. The ordinates of 2-hour unit hydrograph at 1-hour interval starting from t equals to 0 is given over there. Use trapezoidal rule for numerical integration if required. What is the area of catchment? And next question is, if storm of 6.6 centimeters occurs uniformly over the catchment in 3 hours, if phi index is equals to 2 mm per hour, phi index is 2 mm per hour, and base flow is 5 meter cube per second, what is the peak flow of the storm? What is the peak flow due to storm? What is the peak flow due to storm? In the same question, leave that question. In this question you will understand, don't worry, try to solve this. In this question I'll let you know how to do that. Solve this first, try to solve if you can. Please do that also. See, मेरा 7.02 आ रहा है area. I'm not asking about the area. The second question is more important here. Huh? Fine. So the ordinates of 2-hour unit hydrograph at 1-hour interval is given to you. Fine. Ordinates of 2-hour unit hydrograph of 1-hour interval is given to you. 2-hour unit hydrograph at 1-hour interval. T 0, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Fine. What is the discharge values? 0386320. 0386320. Fine. Now lag that by. Now you have to do S curve. Fine. He has asked 3-hour unit hydrograph, right? Anyway, first question is what that is being asked. First question asked is find out the area. Area. How will you find out area? Area. So n equals to 0.36 sigma qt upon A. So that is 0.36. Sigma qt would be how much? Just add everything. 3 plus 0 plus 3 plus 8 plus 6 plus 3 plus 2 plus 0. 0 plus 3 plus 8 plus 6 plus 3 plus 2 plus 0 whole multiplied with 1 upon area A. So A would be equals to 0.36 times 14, 17, 19, 22. 22. That is equals to 3.6 multiplied with 2.2. 12. 7.92 kilometer square. So you'll get 7.92 kilometer square. So this value would be 7.92 kilometer square. Simple. Now the next problem that is given to you is a storm of 6.6 centimeters. A storm of 6.6 centimeters occurs uniformly over the catchment in 3 hours. A storm of 6.6 centimeters occurs uniformly over the catchment in 3 hours. If phi index is 2 mm per hour and base flow is 5 meter cube per second, what is the peak flow? So first try to find out what is the runoff. Runoff. So P equals to 6.6 centimeters and if P equals to 6.6 centimeters, phi index is 2 mm per hour. Phi index 2 mm is 0.2 centimeters per hour. Duration of rainfall is 3 hours. 3 hours. So phi equals to P minus R upon T. 0.2 equals to P minus R upon T is 3. 0.2 times 3, that equals to P minus, P is 6.6 minus R. 6.6 minus R equals to 6.6 minus 0.6, R equals to 6 centimeters. Fine. So you have to generate a 3-hour unit hydrograph, multiply that with 6, you will get direct runoff hydrograph plus base flow. Okay, that is what you have to do. So first you have to generate 3-hour hydrograph. 2-hour unit hydrograph is given, you have to generate 3-hour unit hydrograph. So first thing to do is S-curve addition. S-curve addition. So for S-curve addition, you have to lag by 2 hours. That means you have to lag this whole thing. 0 plus 3, 8, 9, 11, 11. Okay. 0 plus 8, 8. 3 plus 6, 9. 8 plus 3, 11. 9 plus 2, 11. Now finally, what is S-curve? S-curve would be equals to 0, 3, 8, 9, 11, 11, 11, 11. This is S-curve. You have to lag S-curve by 3 hours. You have to lag S-curve by 3 hours. Lag S-curve by 3 hours. So lag S-curve by 3 hours means you have to start from here. 0, 3, 8, 9, 11, 11. Fine. Now delta y. Difference between these two things. 0 minus 0, 0. 3 minus nothing, 0. 8 minus 0, 0. 9 minus 0, 9. 11 minus 3, 8. 11 minus 8, 3. 11 minus 9, 2. And this is 11 minus 11, 0, 0. Next, delta y multiplied with 2 by 3. 2 upon 3. So this is 0. This is 2. This would be 16 by 3. And this is 9 by 3. 3 is 9. So this will be 6. 6. This is 16 by 3. This is 2. This is 4 by 3. 0, 0. Fine. Eleven minus 9, 2. You have to lag that by 3 hours. So 0, 3, 8, 9, 11, 11. Fine. So this is the 3-hour unit hydrograph. This is the value of 3-hour unit hydrograph. And what is the peak value you are getting? Peak value equals to 6. Peak value equals to 6. So Q peak for unit hydrograph, Q peak equals to, for 3-hour unit hydrograph, Q peak equals to 6. So direct runoff hydrograph would be 6 multiplied with N is 6. That equals to 36 centimeters. Flood hydrograph would be equals to DRH plus base flow. That is equals to 36 plus base flow is how much? Base flow is given as 5. So this is 5. 36 plus 5, 41 meter cube per second. So your answer would be 41. Your answer would be 41A. So this is how you try to lag. This is how you'll try to find out if a 2-hour hydrograph is given to you, 3-hour unit hydrograph is calculated something like this. For S-curve addition, you lag by 3 hours, and for finding out unit hydrograph, you have to lag S-curve by 3 hours. S-curve by 3 hours. That means you have to start from 3. You'll get the answer. Peak is 6, and based on that, flood hydrograph is calculated. Any doubts in this? Any doubts in this? No doubts? Fine. Well and good. Other questions? Fine. So, try to solve this question. For a catchment, the S curve due to rainfall intensity. For a catchment, the S curve due to rainfall intensity 1 centimeter per hour is given by Q equals to 1 minus, this is 1 plus T I think, not 1 plus 1. Q equals to 1 minus 1 plus T into e power minus T. The equation of the S curve is given to you. Q equals to 1 minus 1 plus T into e power minus T, where T is in hours, T in hours, Q in meters cube per second, meter cube per second, right? So, due to rainfall intensity, rainfall means effective rainfall intensity 1 centimeter per hour. That is what it means. Okay. What is the area of, in this question he is asking what is the area of catchment, what is the area of catchment, and what will be the ordinate of 2-hour unit hydrograph for this catchment at T equals to 3. For 2-hour unit hydrograph for this catchment at T equals to 3. Fine. And rainfall intensity is given how much? Rainfall intensity is 1 centimeter per hour. Effective rainfall intensity, that means 1 upon D is 1 centimeter per hour. So from this D is 1 centimeter per, D is equals to 1 hour. Duration of rainfall would be 1 hour. Duration of rainfall would be 1 hour. That is the meaning of it. So try to find out what is the catchment area. What is the catchment area? I asked you to solve this question and you are looking into this question. What is the answer? Solve 37 and 38. 492. You can integrate or you can use the limits to get the answer. Limit t tends to infinity, you can get the answer, right? Try to solve that. Limit t tends to infinity, f of t dt, q of t dt, right? So how you are going to solve this? Q equilibrium or Q max would be equals to limit t tends to infinity, q of t. So what would be this? 1 minus 1 plus infinity e to the power of minus infinity. So approximately this would be equals to 1. 1 upon infinity, 1 upon e to the power of infinity is 0. So you can take this as 1 meter cube per second. So q equals to 2.78 a by d. D is also 1. So a equals to 1 upon 2.78, that equals to 0.36 kilometer square. As simple as that. A equals to 0.36 kilometer square. Fine. Now this is 1 hour S curve for 1 hour hydrograph. He is asking what will be the ordinate for 2 hour unit hydrograph for this catchment at t equals to 3 hours, right? So directly S curve is given to you. Let us say this is 1 hour unit hydrograph. Anyway, S curve is given to you, right? S curve at t equals to 0, what is the value? 1 minus of 1 plus 0 into e to the power of 0. At t equals to 1, 1 minus 2 into e to the power of minus 1. At t equals to 2, 1 minus 3 into e to the power of minus 2. At t equals to 3, 1 minus 4 into e to the power of minus 3. At t equals to 4, 1 minus 5 into e to the power of minus 4. This is S curve. You have to lag S curve by 2 hours. S curve lag by 2 hours. So if you lag S curve by 2 hours, you have to start from here. This is 1 minus 1, that is 0, right? So this will be 0 only. You have to lag by 2 hours, that means this is 0, 0. Start from here, 0, and this is 1 minus 2 e to the power of minus 1, and this is 1 minus 3 e square, e power minus 2, 1 minus 4 e power minus 3, 1 minus 5 e power minus 4, right? You have to lag by 2 hours and find out delta y. Delta y 0, delta y 1 minus 2 e to the power of minus 1, 1 minus 3 e to the power of minus 2, and this one is 1 minus 4 e to the power of minus 3 minus 1 minus 2 e to the power of minus 1, and delta y multiplied with 1 by 2. So at t equals to 3 he has asked. So this value divide by 2. What is this value? Please tell me this value. Divide by 2 will be your answer. What is that answer? I don't understand. क्या बोल रहा है प्राची? I don't know what you are trying to say. क्या बोलना चाहते हैं? Lag by 2 hours, you are lagging it. What is the answer? 1 minus 4 upon e cube minus 1 minus 2 upon e. 1 minus 2 upon e. What is the answer? तक गया, ठीक है. We'll take a break for half an hour. What is this answer? Whatever the answer that you are getting, that is the answer for this. 1 minus 4 upon e cube minus 1 minus 2 upon e. That is the reason for every 2 hours I would like to take a break. But anyway, since you wanted it, I took for 3.5 hours. Let's take break for another half an hour and after that we'll start doing, what is that, flood routing. I'll try to complete flood in half an hour or 1 hour, maximum by 8 we'll try to complete it off, finish it off. What is the answer? I know there is no doubt. What is the answer? .53. So you are getting somewhere around 0.53 meter cube per second. Any option? 0.54 meter cube per second. So this is how you will try to solve these type of questions. Next. So next one is instantaneous unit hydrograph. A small point I wanted to say, instantaneous unit hydrograph means limit d tends to 0 dr unit hydrograph is called as instantaneous unit hydrograph. So instantaneous means for a single instant, what is the hydrograph? That is called as instantaneous unit hydrograph. Fine. Just for a small piece, for very small duration of time. Unit hydrograph for small duration of time. For small duration of time is called instantaneous unit hydrograph. Fine. Okay. So generally the ordinates for this is obtained from slope of S curve. Slope of S curve with effective rainfall intensity 1 centimeter per hour. Fine. That means if rainfall is occurring for 1 centimeter per hour, then ordinates is obtained by ordinates of IUH is obtained by slope of this one, ds by dt is obtained by slope of S curve, ds by dt with rainfall intensity of 1 centimeters per hour. I am directly giving, because you should be knowing in depth here, I am directly giving the values. Okay. 0.27 is answer. Oh, okay. So you mean to say this is 0.53, 0.54 by 2. So this would be 0.27. Fine, no issues. This is instantaneous unit hydrograph. So based on that, there were problems, not now, but very old questions it is being asked. And this method is also called as Clerk's method. Instantaneous unit hydrograph, that method is also called as Clerk's method. The major advantages, the time period, the one parameter is reduced. Time period of parameter is reduced. That means here we are taking d tends to 0, right? So if d tends to 0 means that parameter itself is being gone. That is the meaning of it. Like unit hydrograph is 1 hour. So for any, that means this is like, here it's like for any instant of time you can use this. For any instant of time, it doesn't matter whether it is occurring. It's not like time invariance. Like there are 2 hour unit hydrograph, 3 hour unit hydrograph, 4 hour unit hydrograph. 2 hour unit hydrograph is to be used for 2 hour rainfall only. 3 hour unit hydrograph has to be used for 3 hour rainfall only. But instantaneous unit hydrograph can be used for any hours of rainfall. That is the idea. Fine. So the question given to you is the peak discharge of instantaneous unit hydrograph when compared to peak discharge of 4 hour unit hydrograph will be always greater, because that is equals to slope of S curve. So it will be always greater. Next, the ordinate of instantaneous unit hydrograph of a catchment at any time t. At any time t, it is the slope of the S curve with effective rainfall intensity 1 centimeter per hour. With effective rainfall intensity 1 centimeter per hour. So direct theoretical questions these are. Fine. Anyway, so with this I am completing the hydrographs. We'll take a break, have a tea, and after that 6:30, it is already 7, we'll try to meet by 7:30. If you are present, I'll be taking the class, we'll be discussing flood routing. Okay, the last concept, return period, flood routing and all those things, we'll wind it off by half an hour. Okay, fine. Let's take a break. Hi friends, welcome back. So you're there, Chaitanya. What about synthetic unit hydrograph? Don't get much deeper into the things, formulas and all those stuff. Let be it very basic. Fine. So anyone else is there? Ha, being sarcastic, but anyway, I was standing here for 3.5 hours, so you have to be considering that also. From 3:30 to 6:37, I was standing here. Anyone else is there? Me, Chaitanya, and who is the other person? Prachi. I think she left. You there, Prachi? You there, Prachi? No, not there. Data gone. Data finished. Fine. Next thing would be flood, right? Flood, flood discharge, and all those things. So, flood. No one is there. Only 3 persons. Fine. It's okay. Flood. What is the flood? Flood is the high stage in the river or in the banks or anything. If water level increases to unexpected heights, then it is considered as flood. Just giving a basic idea, that is the flood. And the major thing that we are worried in the flood is the peak discharge. Major thing that we are worried in the flood is the peak discharge. There are many methods to find out the peak discharges. Just now we have seen unit hydrograph method, right? Just now we have seen the unit hydrograph method. So from the basics, if we start, first one is rational method. Rational method. Rational method. So rational method to find out the flood. This is to find out the flood. This is generally used. Hey, hi, Prachi, you came. This is generally used in the rational method is generally used if area is less than 50 kilometers square. That means, you know, small streets, small communities. For that, if you want to find out peak discharge, you are going to find out something like this: QP equals to K multiplied with rainfall intensity multiplied with area. So where K is the runoff coefficient. K is what? Runoff coefficient. K is runoff coefficient. PC is equals to intensity of rainfall. Intensity of rainfall. Intensity of rainfall. A is the catchment area. Catchment area. Catchment area. So if you substitute P in centimeters per hour, PC centimeters per hour, if you want to convert that into meters per meter cube per second, this would be 60 into 60 seconds. Multiplied with A in kilometer square, if you substitute, what will you get? Generally, A in hectares, if you substitute, A in hectares, if you substitute, this would be, so Q would be equals to 1 by 36 KPCA. 1 upon 36 KPCA. 1 upon 36 KPCA. Fine. So A, you will be substituting that in hectares. Fine. Intensity of rainfall, you will be substituting that in centimeters per hour. And K is the rainfall intensity. Then directly you will be getting this answer in meter cube per second. If you remember this formula, then remember PC, substitute PC in, I am not skipping anything here, PC in rainfall intensity, intensity of rainfall in centimeters per hour, and A value is the catchment area in hectares. So you'll be substituting that in meter. If you substitute A in hectares, you'll finally get answer in meter cube per second. And this formula is applicable. This formula is applicable if rainfall duration is greater than or equal to time of concentration. If rainfall duration, remember generally if you see hydrographs, rainfall duration is less than time of concentration over there, but this is the maximum, I mean this is the minimum time period here. That means, are you getting it? The rainfall duration. What is time of concentration? Time of concentration is the time taken by the farthest particle to reach the nearby outlet. Time taken by the farthest particle to reach the nearby outlet. So if rainfall duration is more than or equal to time of concentration, then only this formula is applicable. So that means the duration of rainfall should be very much high, or the outlet should be very much near. So that is the reason I said this is applicable for small communities. Rational formula is applicable for very small communities. Fine. So this QP is generally used in your sewers design also. By using this only you are going to find out the QP, right? Peak discharge. So one method of finding this is peak flood discharge is rational method. Next one is empirical formula. There will be Dickens formula. QP would be equals to CD a to the power of 3 by 4. CD value is a Dickens coefficient. Generally it will vary from 6 to 30, and A you will be substituting that in kilometer square. You will get this in meters per second. Fine. And this is generally used in northern part of India. Rives formula, that is generally QP equals to CR a to the power of 2 by 3. Fine. Here also A you will be substituting in kilometer square. You will get this in meter cube per second. Fine. This is used in southern parts of India, and there is English formula where Q equals to 124 A upon under root of A plus 10.4. So here also A you will be substituting that in kilometer square. So finally you will get Q in terms of meter cube per second. So these are the different types of formulas that you will be doing it. Fine. So different types of formula to find out the peak discharge. When I think you have got this phobia of thinking about future, Chaitanya. Once I am talking about rational formula, or I am talking about these formulas, why are you worried about synthetic unit hydrograph? Synthetic unit hydrograph, what is there in that? There is more of like, how to remember W50, W75, QP. There are some, formulas, that's it. And when I'm saying that it is not that much important, if I have a look in these things, have a look at these things, okay? This is much more important than that. Fine. So this is the idea. Okay? So rational formula, and we have seen this empirical formulas. Next one, the thing is unit hydrograph. From unit hydrograph, just we have seen how to find out peak discharge. Don't be fear, okay? Just be cool. Just be very, very cool. If you want something, I'll teach. There's nothing in that, okay? So these are the points that you have to remember. Fine? Not a big issue. Next, we have seen discharge. Next, probability method. Mainly statistical probability method. Theoretical probability method. There are two methods, or theoretical probability method. Statistical probability and theoretical probability method. Anyway, so here in these methods, what we'll be doing is the formulas and all those things. That is not the thing that you have to take. You have to know what is return period. That means, let us say some n number of discharges are given to you. So what you have to do is, first you have to write down in the descending order, 75, 60, 55, 45, something like this. Then give the numbering to it, 1, 2, 3, 4, 5, 6, 7. Fine. Now the return period for this. If they ask what is the return period for this, number, how much how many number is there? 7, right? 7 is there and n. Fine, n. So T would be equals to generally m upon n. M is 7, 7 upon 1. Return period would be, let us say, 7 years. 7 years. Fine. And return period for this one would be 7 upon 2, that is 3.5 years. And return period for this would be 7 upon 3. This would be 7 upon 4, 7 upon 5, 7 upon 6, 7 upon 7. That means return period is 1 year. And probability, if I ask probability, that equals to 1 upon T. This is a return period, and this one is probability. Probability equals to 1 upon T. Probability equals to 1 upon T. Fine, that means probability for this one is 1 upon 7. 1 upon, this would be 2 upon 7. This would be 3 upon 7. This is 4 upon 7. 5 upon 7. 6 upon 7. 7 upon 7. This is probability. See, return period means, when we are talking about return period means, in how many years this flood will return. That means here if I say 7 years, that is called as 7-year flood. If let us say return period is 7 years, that is called as 7-year flood. That means if 2022 it is occurring, that flood, next flood, if let us say 2022, the flood is occurring. I said 7-year flood is occurring. Okay. Next flood will occur in 2029. No, it is not like that. In these 7 years, it can occur one time. In next 7 years, that is equals to 2036, it occur for one more time. That means a 7-year flood means it will occur once in 7 years. It will occur once in 7 years. That means it can occur in 2028 and it can occur in 2030 also. It can occur in 2030 also. These 2 years it can occur. It can occur in these 2 years. But see, in this 7 years it occurred once. In this 7 years it occurs once. Fine. So 7-year flood. Return period is 7 years means 7 years once that flood will come. And probability will be obviously less. Right? Probability of occurring that flood will be very less. So it is 1 by 7. And similarly, if I say 1-year flood, that means every 1 year that flood keeps on coming. Probability of occurrence of that flood is very, very high. So please be very clear. Whenever I say 50-year flood, 50-year flood means return period is 50 years. Probability for that flood is 1 upon 50. It will occur once in 50 years. That is the meaning of it. Fine. So occurrence of flood is a binomial event. Occurrence of flood is a binomial event. Occurrence of flood is a binomial event. Binomial event. That means flood will either occur or it will not occur. Fine. So probability of occurring the flood is P. Then probability of not occurring the flood would be 1 minus P. Right? You know, tossing the coin is a binomial event. Probability of occurrence of head or it will be tail. Probability of occurrence of head is 1 by 2. Probability of occurrence of tail is also 1 upon 2. Fine. So if that is the thing, probability of occurring R times in n events. Probability of occurrence of flood or probability of occurrence of event in R times in n years. Probability of occurrence of flood, if they ask, this is a binomial event. So probability of occurrence of flood. Probability of occurrence of flood for R times in n years. For R times in n years. For R times in n years. Probability of occurrence of flood for r times in n years would be equals to NCR p to the power of r multiplied with 1 minus p whole to the power of n minus r, right? So that means let us say probability if let us say 50-year flood, I'll say 50-year flood. 50-year flood means return period is 50 years and probability is 1 upon 50, right? Now if they ask probability of occurrence of flood for 4 times in 10 years, probability of occurrence of 50-year flood for 4 times in 10 years if you want to calculate, that equals to 10C4 multiplied with 1 by 50 whole to the power of 4 minus multiplied with 1 minus 1 by 50 whole to the power of 10 minus 4. This is probability of occurrence, this is the probability of non-occurrence. Fine. So probability of occurrence of R events in n times would be something like this. So probability of occurrence of flood, 50-year flood for 4 times in 10 years. If they ask, this is how you will calculate. Fine. This is one point. Next, if probability of not occurrence, probability of not occurrence of flood, probability of not occurrence of flood, that means R equals to 0. So if R equals to 0, that is NC naught p to the power of naught 1 minus p to n minus 0, that equals to 1 minus p whole to the power of n. This is called as reliability. Reliability. That means in n years, what is the probability that flood will not occur? What is the probability that flood will not occur in n years is 1 minus p whole to the power of n. What is the probability that flood will not occur in n years is 1 minus p whole to the power of n. Next, probability that flood will occur, at least one time, at least once. Flood will occur at least once. That is also called as risk. Probability that flood will occur at least once, that is also called as risk, that equals to 1 minus p whole to the power of n. Generally how you are going to calculate is, it has to occur at least one, NC1 p to the power of n, 1 minus p to the power of 1, 1 minus p2 whole to the power of n minus 1 plus so on up to NCn p to the power of n 1 minus p2 whole to the power of n minus n. This can also be written as 1 minus NC naught p to the power of 0 1 minus p2 whole to the power of n minus 0, that equals to 1 minus p whole to the power of n. This is called as risk. That means flood will occur at least once in n years. Flood will occur at least once in n years. This is risk. So risk is equals to 1 minus reliability. Risk equals to 1 minus reliability. Fine. So these are the points that you should be generally knowing in statistical probability method or theoretical probability method. Questions were generally asked from here. So these are the points you should be knowing. Fine. And there are some theoretical concepts like what is that I'll discuss it here only while discussing problems. Like, what is standard project flood? Standard project flood. See, standard project flood. If they ask what is standard project flood, it is the flood which includes severe conditions. The flood under severe conditions is called standard project flood. The flood that is occurring under severe conditions is standard project flood, and flood occurring under catastrophic conditions. Catastrophic means even wilder conditions, that is called as probable maximum flood or maximum probable flood. Fine. So maximum probable flood includes catastrophic conditions. That means it occurs in the severe case. So standard project flood will be less than probable maximum flood. Fine. Next, design flood. is equals to flood of desired required recurrence interval. Fine. So this is what you are going to design for any dams or other things. This is the design flood. Next, maximum flood is the peak flow obtained from the observed data. Like from maximum flood that you can get this maximum flood discharge Q peak, that is from unit hydrograph and all those things, you will be getting this. Fine. So the option for this one would be A. So whenever they asked standard project flood is less than probable maximum flood, probable maximum flood, and design flood, and this is maximum flood that is obtained from the data. Fine. Generally this is the condition. So and the flood that is occurring under catastrophic conditions is considered as probable maximum flood. Severe conditions, that is standard project flood, and all the other things that you can see here. Fine. So that is the thing. Standard project flood is smaller than probable maximum flood. Option will be C. And the extreme flood that is physically possible in a region from a severe most combination includes a rare combination of meteorological and hydrological factors is designated as. Fine. That is probable maximum flood. This is extreme condition. Severe most combination, not severe combination, severe most combination. So that is probable maximum flood. Fine. This is the thing. Next, design flood. Design flood, it should be obtained from the data. So obtained from the statistical considerations. That's what I said. It should be obtained from the statistical considerations. Say flood of 50 years return period. Okay. Just an example. So these are the things. Next, anyway, while applying rational formula for computing design discharge, the rainfall duration is stipulated discharge as the time of concentration, because the time of concentration is the smallest rainfall duration for which rational formula is applicable. Option is C. TR should be more than or equal to TC. That's what I said, right? Fine. Next, Dickens formula predicts maximum flood discharge Q in terms of area. So Q equals to CD into A to the power of 3 by 4. So option would be 0.75. We have discussed that. Now try to solve these questions by your own. A temporary coffer dam is to be built to protect the 5-year construction activity for a major cross valley dam. If the coffer dam is designed to withstand the 20-year flood, the risk that structure will be topped in the 3rd year exactly is. Risk that structure will be topped in the 3rd year exactly is. Please give me the answer. A temporary coffer dam is to be built. What is D? A temporary coffer dam is to be built to protect 5-year construction activity for a major cross valley dam. If coffer dam is designed to withstand 20-year flood, the risk that the structure will be overtopped in the 3rd year exactly is. Let's see your mathematics here. One minus 19 by 20 to the power of 5. Really? See that question properly. Please see that question properly. I'll give you one more chance. Try to solve it. probability risk, the risk that the structure will be overtopped in the third year exactly. Probability the structure will be overtopped in the third year exactly. Probability that structure should be stopped in third year exactly. Try to solve it one more time. Point 0.45. That's the thing. So here a temporary coffer dam is to be built for 5-year construction activity. Fine. So 5-year construction activity. The coffer dam is withstand to the coffer dam is withstand. Is to withstand 20-year flood. It has to withstand 20-year flood. That means return period is 20 years. If return period is 20 years, what is probability? 1 upon 20. Probability of non-occurrence is 1 minus 1 upon 20, that equals to 19 upon 20. And what he is saying? It should exactly fail in the third year. What is the risk that it fails in the third year? So that means in the first year it should not fail, and second year it should not fail, and in third year it should fail. In third year it should fail. That is the idea. So that would be equals to how much? 0.045 multiplied with 100, that would be equals to 4.5%. So read the question properly. He has asked that it has to fail at third year. Sir, you have given some formula. I will be using risk means 1 minus 1 minus p whole to the power of n. Don't go blindly. Okay. The risk, risk means what? It should not occur at least once. And what he is saying, that probability that it has to occur exactly at the third year. First year it should not occur, second year it should not occur, and third year it should occur. That is the idea. Now, fine. Is it clear now? That is, so what? It should not be the answer. Who told you that? If that is too less, then you won't answer it. Fine. The return period for annual maximum flood for a given magnitude is 8 years. The return period for annual maximum flood of given magnitude is 8 years. The probability that flood magnitude will be exceeded once during next 5 years. The probability that it will be exceeded once during next 5 years. Probability that it will be exceeded once during next 5 years. Which question, about which question you are talking about, Chaitanya? We have moved from that question. Now it is question number 8. Question number 7 is already done. In question number 8, probability that it exceeds, that flood exceeds, occurs, or it exceeds at least, not at least once. He is saying once. He is saying once in next 5 years. So return period is how much? 8 years. Return period is 8 years. So probability of occurrence is 1 upon 8. Probability of non-occurrence is 1 minus 1 upon 8, that is 7 upon 8. In 5 years it has to occur once. So 5c1 p to the power of 1, 1 minus p to the power of 5 minus 1. So that is the probability. So that would be equals to 5c1 multiplied with 1 by 8 to the power of 1, 7 upon 8 to the power of 4. What is this value? What is this value? It should occur once, not at least once. Probability that it should occur once. Probability that it should occur once. So, what is the answer? Point 366. It is not there here. It is not there. Will be exceeded once, he is saying. If it is once, the answer you are getting 0.366. If it is at least once, then what would be the answer? At least once means 1 minus p whole to the power of 5. That equals to 1 minus 7 by 8 to the power of 5. What is this answer? If it is at least once, what would be the answer? If it is at least once, what is the answer? If it is at least once, what is the answer? 0.487. Okay. So there might be a calculation mistake. So at least once it should be. Okay. But anyway, if he asks once means 5c1, at least once means 0.487. Next question, probability that 10-year flood to occur at least once in next 4 years. Probability that 10-year flood to occur at least once in next 4 years. What is the answer? Chaitanya is talking something else. His probability that flood maximum will be exceeded at least once, if they say, then only the answer is 0.457. If they are saying once means once in 5 years, that is 5c1. It can occur in 2, 3, 4, any time. That is the meaning of it. If they are saying at least once, minimum once also he has to say, but he is not saying minimum once. Fine? He just said once. Question number 9, what is the answer? Question number 9, what is the answer? So, a probability that 10-year flood will occur at least once in 4 years. That equals to 1 minus 10-year flood means 9 by 10 to the power of 4. Right? So, what is this value? 35%? 35%? Option is B. Fine. Next, probability that 100-year flood equaled or exceeded at least once in 100 years. Equaled or exceeded at least once in 100 years. 1 minus 99 by 100 to the power of 100. What is this value? Probability that 100-year flood is equal or exceeded at least once. What is the value? A. 99%? Fine. Are you sure? What is the answer, guys? 1 minus 99 by 100 to the power of 100. Prachi is saying 64% and you are saying something else. What is the answer? 64%? Fine, well and good. Answer is 64%. Next, a bridge has an expected life of 50 years. A bridge has an expected life of 50 years and is to be designed for a flood of magnitude of return period 100 years. Flood of magnitude of return period 100 years. What is the risk associated with this hydrologic design? What is the risk? A bridge has an expected life of 50 years and it is to be return period is how much? 100 years. So probability is 1 upon 100. So he is asking life of bridge is 50 years. So that is equals to 1 minus 100 whole to the power of n. N is 50. 1 minus 99 by 100 to the power of 50. What is the value? 1 minus 0.99 to the power of 50. Directly you'll get the answer. Don't go with English literature. Fine, go with concepts. Okay. Your answer is 64%. 100-year flood at least once. Don't get too much confused. Give it a basic shot. Fine. 100-year flood means return period is 100 years and once in n years. N is 50, n is 100. Go with that. Don't think too much. Try to solve next question. It is proposed to design a causeway along a village road. The return period for annual maximum flood of a given magnitude was found to be 5 years. The probability that flood magnitude will be exceeded at least once during next 2 years. Probability that flood magnitude will be exceeded at least once in next 2 years. See, Chaitanya, right now if I say what is wrong in that and all those things, you will be getting more confused out of it. So just go with this. Try to get it out of your system. Okay. If you say, sir, what is wrong in that? The thinking is wrong. Fine. I already told you 100-year flood at least once in 100 years means it can occur once, it can occur twice, it can occur thrice, it can occur 100 times. That is the idea. Fine. So you can't get exactly into that. So don't go with the English wordings. Go with the concept. Your problems will be solved in a simplest way. At least once, we have just seen it can occur once, twice, thrice. So probability that it can occur all these things is not 100%. No. Okay. There is probability that it cannot occur in 100 years. 100-year flood, that doesn't mean it cannot occur. That is reliability. Fine. So what is the answer for this? Answer for this. Return period is 5 years. Probability is 1 upon 5 and 1 minus 1 upon 5 whole to the power of 2. So 1 minus 4 to the power of 4 to the power of 5 to the 2, that is 0.36, right? D. 0.36. So this is the idea. This is the major problems that we generally see in this one. Flood. Now, flood routing. Flood routing. Next concept would be flood routing or flood routing, whatever it is. Fine. Flood routing, it is a technique. Flood routing, it is a technique. It is a technique. That means if an inflow hydrograph is given to you, based on the inflow hydrograph, if it passes through any channel, or reservoir, you have to develop an outflow hydrograph. If there is an inflow hydrograph, there is an outflow hydrograph that is generated. That means there is a river flowing on. Okay, river flowing on. So inflow hydrograph means based upon the data you will get the peak discharge and all those things. You have generated a hydrograph Q with respect to T. This is inflow hydrograph. Fine. So generally that by using flood hydrograph we can generate this. Now if you are constructing a canal across this, or if you are constructing a dam across this, fine, then the flood hydrograph will try to see. What happens is flood will reduce. The peak will reduce. Because of constructing this, the flow is being arrested because of the reservoir or canal. Fine. Because of construction of reservoir and canal, the flow will be arrested. So the outflow hydrograph will be developed. Outflow hydrograph will be developed. So based on inflow hydrograph, if you are able to generate outflow hydrograph, that is called as flood routing. This is done across the canals, across the reservoirs and all those things, and you will generally see there is decrease in the peak. You will generally see there is decrease in the peak. This is called as attenuation. This is called as attenuation. Decrease in the peak value. That is the reason why you are constructing canals and reservoirs and all those things is you have to decrease the peak. At the same time, there is lag in the base time. Base time will be increased. This is called as lag. There will be lag. So there will be a decrease. This is decrease in the peak is called as attenuation. Increase in the base time. Increase in the base time is called as lag. Fine. Increase in the base time is called as lag. And generally, this is the point of intersection of inflow hydrograph and outflow hydrograph. This is the location where storage will be maximum. Storage will be maximum. This is the location where storage will be maximum. That means if you are trying to draw storage with respect to time curve, storage with respect to time curve, it will be maximum exactly at the point of intersection of inflow hydrograph and outflow hydrograph. Storage will be maximum, and that is also you will be seeing in the when gates are open, when there is free flow, over the reservoir or the dam, when there is free flow over the outflow is when there is free flow over the reservoir or dam. That means you are opening the gates, and when there is flow on the reservoir, if that type of flow is there, storage will be maximum at the intersection of inflow hydrograph and outflow hydrograph. Here you will be seeing storage will be maximum. Fine. You will generally find maximum storage, that is for free flow over the reservoir or the downstream of the reservoir. You can say over the downstream of the reservoir, Fine. See, to be more frank, this is on the upstream, this will be in the downstream. It's like this inflow is on upstream and outflow is on downstream. And why there is attenuation? Because we are constructing the dam. That's it. Fine. Now there are different types of routings. Hydrologic routing. So hydrologic routing means if we are using only equations of continuity. If we are using equations of continuity only, then it is called as hydrologic routing. That means to find out the ordinates of outflow hydrograph from inflow hydrograph, then it is called as hydrologic routing. And hydraulic routing. If we are using both equations of continuity, and equations of motion, equations of unsteady motion. If you are using equations of continuity and equations of unsteady motion both, then it is called as hydraulic routing. Hydrologic routing will be using only equations of continuity. Fine. I am not going in depth into it, just giving basic idea. Fine. So in hydrologic routing, generally we use a method which is called as Muskingum method. Fine. So we'll be using a method which is called as Muskingum method. According to this, storage is a function of inflow and outflow. Storage is a function of inflow and outflow, right? And that is generally given as S equals to K multiplied with x to the power of I x into I to the power of 1 by m and 1 minus x O to the power of m. O to the power of m. Fine. So x is a constant. If x equals to 0, then s is function of outflow only. S is function of outflow only. That type of channel is called as linear channel. If storage is function of only outflow, that type of channel or reservoir is called as linear reservoir or linear channel. Linear reservoir or linear channel. Fine. So K is also constant. Kxm. M depends upon types of channels. For artificial channels, M equals to 0.6 for artificial channels. And M equals to 1 for natural channels. M equals to 1 for natural channels, right? M equals to 1 for 0.6 for artificial channels, and for natural channels M equals to 1. If you substitute it over here, then storage will be equals to K multiplied with x into I plus 1 minus x multiplied with O. Fine. At the same time, we know change in storage would be equals to I1 plus I2 by 2 multiplied with delta T minus O1 plus O2 by 2 multiplied with delta T. And here also, if you want to find out change in storage, then K multiplied with x multiplied with I2 minus I1 plus 1 minus x multiplied with O2 minus O1, right? Something like that you will be getting. Fine. Oh, sir, how you got this? I got this from here. If this is I1, I2. This is I1, I2. If I say if this is I1, this is I2, this would be O1, this would be O2. For delta T time period, if you want storage, this will be your storage. Fine. Inflow minus outflow will be your storage, right? So this is the equation that will be generated from here. So finally, what you can write is O2 would be equals to C0 I2 plus C1 I1 plus C2 O1. Fine. Where C0 would be equals to 0.5 delta T minus Kx upon K multiplied with 1 minus x plus 0.5 delta T, and C1 equals to 0.5 delta T plus Kx upon K multiplied with 1 minus x plus 0.5 delta T, and C2 would be equals to K multiplied with 1 minus x minus 0.5 delta T upon K multiplied with 1 minus x plus 0.5 delta T. So all these three things is designed in such a way that C0 plus C1 plus C2 equals to 1. C0 plus C1 plus C2, if you add, it will be equal to 1. So delta T is generally taken in the range of a Kx to 2 times Kx. Anyway, I am not getting deeper into it. These are the basic things that you have to remember in Muskingum method. So based on this, if inflow hydrograph values are given to you, you can generate outflow hydrograph. That means ON would be equals to C0 IN plus C1 IN minus 1 plus C2 ON minus 1. From here you can generate this. You can generate whatever that means. Idea is what? Generating outflow hydrograph from inflow hydrograph is your flood routing concept. Okay, so this is how we will try to solve these type of questions. Fine. Any doubts in this? You can ask me. Any doubts? Any doubts, guys? So if there is no doubt, what is the answer for question number 14? What is the answer for question number 14? What is the answer for question number 14? What is the answer? I hope question number 14 is visible. What is the answer? A, B. When outflow from the storage reservoir is uncontrolled and is freely operating, the peak of outflow hydrograph occurs. The point of intersection of inflow and outflow hydrograph, a point after the intersection of inflow and outflow hydrograph, the tail of inflow hydrograph, a point before the intersection of inflow and outflow hydrograph. See, the same thing I said, when outflow from the storage reservoir is uncontrolled, that is from a freely operating spillway. If this is a spillway, if outflow is uncontrolled, so that time the peak of the outflow hydrograph will generally occur. This peak will generally occur at the point of intersection of inflow hydrograph and outflow hydrograph. The peak will be occurring here only. Fine. So this is the option is A. Peak will be occurring at the point intersection of inflow and outflow hydrograph. Okay. So Prachi, try to correct it. Next, this question, 2019 question. An inflow hydrograph is routed through a reservoir to produce an outflow hydrograph. The peak flow of inflow hydrograph and time of occurrence is P1 and T1, and peak flow of outflow hydrograph is P0 and time of occurrence is T0. Which one of the following statement is correct? Which one of the following statement is correct? Tell me which one of the following statement is correct. An inflow hydrograph is routed through a reservoir to produce an outflow hydrograph. The peak for inflow hydrograph is P1, it occurs at T1. Peak for outflow hydrograph is PO, it occurs at TO. Which of the following statement is correct? Which of the following statement is correct? Fine. So he said C. If you see here, peak of the inflow hydrograph is T1, Ti, Pi. Peak of outflow hydrograph is TO, PO. So what you can say? P1 is less than, Pi is less than PO, and TO is more than Ti. right? This can also be called as lag. Lag can be that, lag can be this. Both are considered as lag only. Fine. So P1 is more, Pi is more than PO, TO is more than T1. Okay. So this is the idea. Option is C. P1 is P1 Pi actually. Anyway, P1 is more than PO, T1 is more less than TO. That is the idea. A linear reservoir is the one in which storage varies linearly with outflow rate, right? So linear reservoir is the one in which m x equals to 0, right? X equals to 0, so storage varies with outflow rate. Storage is a function of outflow rate. Fine. Option is C. Option is C. Next, hydrologic flood routing. What is the answer for this? Hydrologic flood routing. Hydrologic flood routing. In hydrologic flood routing, what are the equations that you'll consider? You'll consider continuity equations. In hydraulic flood routing, what you will be considering? In hydraulic flood routing, what you will be considering? What you will be considering hydraulic flood routing? You will be considering momentum equation and equations of unsteady motion, that is continuity equation. Momentum equation and continuity equation 1 and 2. Please be clear with it. Please be clear with it, okay? 1 and 2. Not energy equations. We will be using continuity equations and equations of unsteady motion, that is momentum equation. So 1 and 2. So the Muskingum model of routing, a flood through a stream is expressed as O2 equals to K0 I2 K1 I1 plus K2 O1, where K0, K1 and K2 are the constants routing coefficients concerned reach. I1, I2 are the inflows to the reach, and O1, O2 are the outflows from the reach corresponding to the time steps 1 and 2 respectively. The sum of K1, K0, K1 and K2. So see, the question looks big. But what is the answer? Sum of K0 plus K1 plus K2 of the modulus. Sum is how much? D. Direct question. Muskingum method for routing of the flood. Muskingum method for routing of the flood is hydrologic method of routing flood through streams. Is a method of routing that uses continuity and momentum equation, is used for routing floods through the reservoirs, is the one which only energy equations is used. This is wrong. Muskingum method is hydrologic method of flood routing. So this is also wrong. So you can, between these two things you will get the doubt, but since he said hydrologic method, you have to go for this. Muskingum method is hydrologic method of flood routing. Okay, hydrologic method of flood routing through the streams. Next, for routing of the flood in given channel using Muskingum method, the two of the routing coefficients are estimated as C0 is minus 0.25, C1 equals to 0.55. What is the value of C2? What is the value of C2? C0 is minus 0.25 and C1 is 0.55. So 1 minus 0.55, that is 0.45 plus 0.25. The value would be 0.7, because C0 plus C1 plus C2 equals to 1. From this you will get this, right? So these are the major things in the flood that you have to see, right? So maximum based upon the previous year's questions, I can say that I have completed hydrology based on previous year's questions. Fine, don't get me in the other way, sir. You are saying that you have completed hydrology. No, but based on previous year's questions concepts, I have done the maximum part of it. You want synthetic unit hydrograph. What is there in that year? You just have to remember certain formulas over there. Synthetic unit hydrograph. Why it is generated? Because for developing a hydrograph, you need the stream characteristics. Stream characteristics you can know, but the catchment characteristics you can't know. So since you don't know catchment characteristics, there is a flood hydrograph that is generated that is called as synthetic unit hydrograph. This can be used for any catchment. That means it can be used for South India, it can be used for North India, it can be used for Western Ghats, it can be used for Eastern Ghats. Fine. So this is synthetic unit hydrograph. Fine. So there will be time for rainfall and there will be time of lag that is generally given as TP. Fine. And this is time with respect to discharge. And let us say if I take this as sum, this would be W75 and this would be W50 corresponding to the discharge of 50, corresponding to discharge of 50% and 75%, something like that you will be seeing here. Fine. So for generating TP, TP is given as some CTLLA to the power of 0.3, length of the basin and length of the basin from the centroid that will be given to you. All these values will be given to you. So there are some formulas only. TP equals to CTLLA to the power of 0.3 and rainfall, duration of rainfall would be equals to some TP upon 5 and TP dash would be equals to 21 upon 22 TP plus TR by 4. From that you will get, and discharge will be equals to 2.78 CP A upon TP dash, duration of rainfall TR. Fine. So these are the things that you generally see. And W50 equals to 5.84 upon Q to the power of 1.08. W75 equals to W50 upon 1.75. Actually it is of no meaning, but only meaning why synthetic hydrograph is said is it can be used for any area, southern, northern, western, eastern. Generally from engineering services point of view, if you do a problem then you can do this properly, but without that you can't solve this. This is like 50% of QP, 50% of QP, 75% of QP. That is the meaning of these things. Okay, so these are the various things. What is the use of all these values? That's what I am saying. By using all these values you will generate the synthetic unit hydrograph, and that synthetic unit hydrograph can be used for any of the places throughout the world. For India, this is the synthetic unit hydrograph. If I say, it can be used any places, because unit hydrograph depends upon catchment area, and whereas this does not depend upon catchment area. That is the idea. Fine. My suggestion is don't get into it, because question cannot be framed for this. First of all, question cannot be framed on this. From engineering services point of view, you can ask what is synthetic unit hydrograph. There you can explain something, but in GATE you don't have to be worried about this. Okay, so that's what I can say. I have covered based upon previous year's questions. I have covered. So if you are lucky enough, you can get a 2 marks out of it, 2 or 3 marks from whatever we have studied. So just if question comes, try to solve it as soon as possible. And for tomorrow class, you are asking for S. Tomorrow FM and OCF, please. To FM and OCF I can't promise, but surveying I can promise, and there are no other guys. So Chaitanya, I'll get back to you. If possible, I'll try to get a class tomorrow for surveying. And FM and OCF, I don't have booklets itself, because I'm not dealing with FM and OCF here. So if there is a possibility, I'll try to take surveying tomorrow. If there is a possibility, I exactly don't know whether I can take the class or not. I'll get back to you. If there is a class, link will be provided, but Monday definitely there will be a class, I think. Tomorrow I don't know when the class will be there. If at all there is a class, I'll try to take surveying. FM and OCF, I have to ask them. So tomorrow I'll try to ask them, and at least by Monday I'll try to take FM and OCF. And if you want surveying, let me know. If not, I'll not ask for the link. If you want surveying, let me know. Thank you, you're welcome. If you want surveying, let me know. You don't want, okay, fine, yeah. So I'll see if anybody wants any classes, you can always message me at fine. So you can WhatsApp me over here. I'll try to see what I can do. If you want surveying, you want FM and OCF, I'll try to get back to you by Monday. Yeah, by Monday, hopefully, because I don't have that booklet with me. If I get the booklet, I can teach, okay? Yeah, all the best, Chaitanya, and thanks for being there from the morning. Thanks, Prachi. Thanks, Chaitanya. Thanks for your patience, and thanks for being there, okay? And I hope this will be useful for you. Thank you very much. Bye-bye. Good night.